Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are beginning a new topic today, mensuration. What are the objectives that we look forward to achieving at the end of this topic? At the end of this topic, you should be able to find the area and perimeter of plane figures. You should be able to find the volume and surface area of solid figures. You should be able to find the area and perimeter of composite figures. And you should be able to find the volume and surface area of composite figures. So our studies on mensuration, we are going to concentrate on plane figures, solid figures, and composite figures. What is mensuration? Mensuration simply means measurements. But in this chapter on mensuration, we will be considering measurements about plane figures and solid figures. Because we are going to consider measurements about plane figures and solid figures, we need to know what plane figures are and what solid figures are. A plane figure is a flat, closed figure in a plane. So any flat, closed figure in a plane is a plane figure. We are going to consider the following plane figures. The first one is a triangle. So a triangle is a plane figure. The second plane figure we'll be considering are quadrilaterals. When you say quadrilaterals, in the video on plane geometry, we learned that a quadrilateral is a four-sided plane figure. So any plane figure with four sides is a quadrilateral. Okay, so you will consider the following quadrilaterals: rectangle, square, parallelogram, rhombus, trapezium, and kite. So you consider triangles, then you consider these quadrilaterals. We also consider a circle. A circle is another example of a plane figure. So you'll be considering triangles, you'll be considering quadrilaterals, then you also be considering circles. We will learn how to find the perimeter and area of these plane figures. So for each of these plane figures, we will learn how to find the perimeter and area. Our studies also include solid figures. We are going to consider the following solid figures: cylinders, we will consider a cuboid, we will consider a cone, we will consider a sphere, and we also consider pyramids. So the solid figures we'll be considering in our studies on mensuration are cylinder, cuboid or cube, cone, sphere or hemisphere, then pyramids. For solid figures, we are going to learn how to find the volume, the total surface area, and curved surface area. So for the plane figures, we will be considering how to find the perimeter and area. For solid figures, we will consider how to find the volume, the total surface area, and curved surface area. So we are going to concern ourselves mostly with plane figures and solid figures in our studies on mensuration. Thank you for watching this video. Don't forget to like and subscribe to this channel for more videos. As we said in the beginning of this video, we will be learning about plane figures and solid figures in these studies on mensuration. In the next video, we are going to begin with plane figures and we will be considering a triangle. Bye-bye. We are on the topic mensuration. We learned in the previous video that our studies on mensuration will be concentrated on plane figures and solid figures. We will be beginning with the plane figures and we are considering triangles. In the video on plane geometry, we learned that a triangle is a three-sided plane figure. So if you have any three-sided plane figure, it's called a triangle. So for example, looking at this plane figure here, A, B, C, we have the sides AB, AC, and BC. So this is an example of a triangle. In the first video or the previous video, we learned that we are going to learn how to find the perimeter and area of plane figures. So how do we find the perimeter of this plane figure? The perimeter of a plane figure is the total distance around the figure. So the total distance around this triangle here is the perimeter of the triangle. So to find the total distance around this triangle, we are going to say that the perimeter of this triangle here will be the length AB plus the length BC plus the length AC. So if you add all the distances around the figure, you get the perimeter of the figure. So if you are being told to find the perimeter of a triangle, all you need to do is to find the length of each side and you add them together. That will give you the perimeter of the triangle. Now let's say that we call this side here side AB. For this triangle, the side AB is the base. So here is the base. Now if you draw a perpendicular line from C to meet the base, it's going to create a 90 degrees angle here or a right angle here. In the video on plane geometry, we explained that wherever you see this sign here, it means the angle there is 90 degrees. So if you draw a perpendicular line from C to meet the base, which is AB, it's going to create this angle here, which is a 90 degrees angle. We call the distance from C to the line AB. We will call that distance the height of the triangle. So for this triangle, AB is the base. Then the distance from C to meet the base, the perpendicular distance from C to meet the base, which is AB, is called the height. The area of a triangle is equal to half times the length of the base times the length of the height. So for any triangle, the area of that triangle is equal to half times the base times the height. This formula is very important because we are going to use it a lot in our studies on triangles. So the perimeter of a triangle is the sum of the distance around the triangle. The area of a triangle is equal to half times the base of the triangle times the height of the triangle. So for this triangle here, AB is the base. Line AC and BC are the sides of the triangle, the sides. This line here, the perpendicular distance from C to meet the base, which is AB, is called the height of the triangle. So the area of a triangle is equal to half times the base times the height. In the video on plane geometry, we learned that there are different types of triangles. We learned that there is a right angled triangle, that is a triangle with one interior angle being equal to 90 degrees. So for example, this is a right angled triangle. We also learned about isosceles triangles, triangles with two sides being equal. So for example, the triangle ABC has the sides AC and BC as equal. So this is an example of an isosceles triangle. We also learned about equilateral triangles, that is triangles with all the sides being equal. So here AC is equal to BC and is equal to AB. So this is an example of an equilateral triangle. We also learned about scalene triangles, triangles that does not have any of the sides being equal. So all the sides are different. So here the side AB is not equal to BC and is not equal to AC. All the sides are different. We learned all these types of triangles in the video on plane geometry, but we concentrated on the angles in those triangles. In the subsequent videos, we are going to learn how to find the area and perimeter of these types of triangles. So in our studies on mensuration, we will be concentrating on finding the area and perimeter of these types of triangles. So we will learn how to find the area and perimeter of right angle triangles, We learn how to find the area and perimeter of isosceles triangles. We learn how to find the area and perimeter of equilateral triangles. And we also learn how to find the area and perimeter of scalene triangles. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to begin with learning how to find the area and perimeter of a right-angled triangle. Bye-bye. We are on the topic mensuration. We learned how to find the area and perimeter of triangles in the previous video. We also learned about the types of triangles. In this video, we will learn about how to find the area and perimeter of a right-angled triangle. In the previous video, we learned that a right-angled triangle has one of its interior angle as 90 degrees. So for example, in this right-angled triangle, the angle formed at B is 90 degrees, or is a right angle, just as the sign here indicates. So the triangle ABC is a right-angled triangle. In a right-angled triangle as we have here, AB is called the base and BC is called the height. So here AB is the base and BC is the height. We learned in the previous video that the perimeter of a triangle is the sum of the distance around the triangle. So here, let's say in a question we have AB and BC. We need to find AC in order to find the perimeter. Or maybe we have AC and AB and we need to find BC in order to find the perimeter. We are going to apply the Pythagoras theorem. We learned from the Pythagoras theorem that if we are applying it on this triangle, then AC squared is equal to AB squared plus BC squared. In the videos on trigonometry, I explained the Pythagoras theorem. We learned there that from the Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the other two sides. I explained the Pythagoras theorem into details in the videos on trigonometry. We are going to apply it a lot in our studies on mensuration. So I entreat you to go and watch the videos on trigonometry, the videos on Pythagoras theorem under trigonometry, and understand how to apply the Pythagoras theorem, because we'll be using it a lot in our studies. We've learned about a right-angled triangle. Just as we saw in the previous video, the perimeter of a triangle is the sum of the distance around the triangle. The area of a triangle is equal to half times the base times the height. We are going to use this to solve a question. Find the area and perimeter of a right-angled triangle with a base of 10 centimeters and a height of 20 meters. So let's say that we draw this as a right-angled triangle. The question says that it has a base of 10 centimeters. So the base, which is AB, is 10 centimeters, and the height, which is AC, is 20 centimeters. Okay, we know that area of a triangle is equal to half times base times the height. So this is going to give us half times the base, which is 10 centimeters, times the height, which is 20 centimeters. We simplify this, we are going to have 100 centimeters squared, because centimeters times centimeters will give us centimeters squared. So the area of this triangle is 100 centimeters squared. The question also said that we should find the perimeter of the triangle. We know the distance AC, we know the distance AB, but we don't know the distance BC. Since this is a right-angled triangle, we are going to apply the Pythagoras theorem. If we apply the Pythagoras theorem here, we know that the square of the hypotenuse, which is BC squared, is equal to the sum of the squares of the other two sides. So AB squared plus AC squared. So BC squared is equal to 10 squared plus 20 squared. If you simplify this, you see that the length BC will give us 22.4 centimeters. So the length BC here is 22.4 centimeters. Now look at it very well. We have AC, we have AB, we have BC. We know all the sides, so we can find the perimeter. We learned that the perimeter of a triangle is the sum of the distance around the triangle. So the perimeter of this triangle here is the sum of the length AB plus the length AC plus the length BC. So the length AB plus the length AC plus the length BC will give us the perimeter of this triangle. You sum all the sides. You have 10 centimeters plus 20 centimeters plus 22.4 centimeters, and this will give us 52.4 centimeters. So the perimeter of the triangle is 52.4 centimeters. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the area and perimeter of a right-angled triangle. Bye-bye. We are on the topic mensuration. In the previous video, we learned how to find the area and perimeter of a right-angled triangle, and we solved a question. In this video, we are going to solve another question on finding the area and perimeter of a right-angled triangle. So let's consider the question for this video. Find the area and perimeter of the right-angled triangle below. So this is the, not a. Okay. So find the area and perimeter of the right-angled triangle below. Okay. Now this is the right-angled triangle given to us, PQR. We know from this right-angled triangle that PQ is the height, PR is the base, then QR here is a side or the hypotenuse if we are considering the Pythagoras theorem. We know that to find the area, we need the height, which we already know as PQ, and we need the base, which is PR. We don't know PR. But here, we have been given QR, which is the hypotenuse, and PQ, which is the height. We can use PQ and QR to find PR because we know how to use the Pythagoras theorem. As I said in the previous video, we are going to apply the Pythagoras theorem a lot. So if you are not clear on it, watch the video explaining Pythagoras theorem under trigonometry. In that video, I explained the Pythagoras theorem into details and how to use it. If you were able to understand that, you understand most of the things that I'll be explaining in this video because you'll be applying that knowledge that you got there here. Okay, so to help us find PR, we are going to use the Pythagoras theorem. So from the Pythagoras theorem, if we are applying it here, we know that the hypotenuse, which is RQ or QR, so RQ squared is equal to PR squared plus PQ squared. RQ squared, RQ is the hypotenuse, so RQ squared is equal to PR squared plus PQ squared. RQ is 13 centimeters, so 13 squared is equal to PR squared plus 12 squared. We group like terms, you have 13 squared minus 12 squared is equal to PR squared. You simplify this and PR will give us 5 centimeters. So the length PR is 5 centimeters. So you can say that from P to R is 5 centimeters. Now, we have PR, we have PQ, we have RQ or QR. So we can find both the area and the perimeter. We know that the area of a triangle is equal to half times base times height. The base here is PR, which is 5 centimeters. So half times 5 centimeters times the height is PQ, which is 12 centimeters. And you simplify this, you are going to have 30 centimeters squared. So half times 5 times 12 will give us 30. Centimeters, they are multiplying, so centimeters squared. So the area of this triangle here is 30 centimeters squared. We learned that the perimeter of a triangle is the total distance around the triangle. So here the perimeter of this triangle will be PR plus PQ plus QR or RQ. So PR is 5 centimeters, PQ is 12 centimeters, and RQ is 13 centimeters. So when you add all the length of all the sides, you get the perimeter of the triangle. When you do that, you are going to have 30 centimeters. So the perimeter of the triangle is 30 centimeters. The area of the triangle is 30 centimeters squared, and the perimeter of the triangle is 30 centimeters. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to learn how to find the area and perimeter of an isosceles triangle. Bye bye. We are on the topic mensuration. In the previous video, we learned how to find the area and perimeter of a right-angled triangle. In this video, we are going to learn how to find the area and perimeter of an isosceles triangle. Let's learn more about isosceles triangles. If you consider the triangle ABC, we can see that the length of AC is equal to the length of BC. For isosceles triangles, one very unique property about it is that two sides of the triangle are equal. So here there are two lines here and there are two lines here, showing that the length AC is equal to the length BC. So if you have a triangle with two sides being equal, then that triangle is an isosceles triangle. So these two lines here and these two lines here means that the length AC and the length BC are equal. There is only one line here showing that the length AB is different from AC and BC. Another important thing about isosceles triangles is that the angles formed at the base are also equal. So the line AC or the side AC and the side BC, the angles formed at their bases, which means that the angle formed here, and the angle formed here are also equal. So that is another unique property about isosceles triangles. So if you are considering this isosceles triangle, then angle BAC is equal to angle ABC. That means that if angle BAC is equal to theta, then angle ABC is also equal to theta. So for isosceles triangles, two sides are equal and the angles formed at the bases of these two sides are also equal. We've learned that the perimeter of a triangle is the total distance around the triangle. So here the perimeter of this isosceles triangle will be the sum of the length AB, AC, BC, and AC. So we add the length AB to the length BC to the length AC, and we are going to get the perimeter of this isosceles triangle. We also learned in the previous video that the area of a triangle is equal to half times the base times the height. For this isosceles triangle, AB, the length AB is the base of the triangle. So AB is the base of the triangle. Now, the height of the triangle is the perpendicular distance from C to the base. So if you draw a perpendicular line from C to the line AB, that the length of that line is what we call the height of the triangle. We call this line a perpendicular line because it meets AB at 90 degrees. So if two lines meet at 90 degrees, those two lines are said to be perpendicular lines. So the height of this triangle here is the perpendicular distance from C to the base. So the length of the line from C to the base is the height of the triangle. One very important thing about the isosceles triangle is that because the line from C to the base is a perpendicular line, it's going to divide the length AB into two equal parts, meaning that if you call this point here point D, let's say I call this point here point D, that is where the perpendicular line meets AB. If I call this point here point D, because this line here, now the line CD, because it is a perpendicular line, is going to divide AB into two equal parts. So the length AD, or from A to D, will be the same as from D to B. So AD is equal to DB. This is very important. We are going to use it when we are finding the area of an isosceles triangle. Let's pick a question and see how you can apply what you just learned to solve a question. The height of an isosceles triangle is 8 centimeters and the base is 10 centimeters long. Find the A, area of the triangle, B, length of the sides, and C, perimeter of the triangle. So let's say that we are drawing this isosceles triangle. Let's call it ABC. The question says that the base of the triangle is 10 centimeters long. So from AB, which is the base, from line AB, which is the base of the triangle, is 10 centimeters long. It also said that the height of the triangle is 8 centimeters, which means that the perpendicular distance from C to the base is 8 centimeters. So since it's a perpendicular distance, we indicate the right angle sign here to show that they are going to meet at 90 degrees. And this line from C to the line AB is 8 centimeters. So the base of the triangle is 10 centimeters and the height of the triangle is 8 centimeters. Okay, the question says that we should find the area of the triangle, then the length of the sides of the triangle, then we find the perimeter of the triangle. Let's begin with the area. We've learned that the formula for finding the area of a triangle is half times base times height. Now, what is the base of this triangle? What is the length of the base of this triangle? It is 10 centimeters. The height is 8 centimeters. So we just substitute these values into the formula. So we have half times the base, which is 10 centimeters, times the height, which is 8 centimeters. And this is going to give us 40 centimeters squared. So the area of this triangle is 40 centimeters squared. So we can say that therefore the area of this triangle here is 40 centimeters squared. The question also said that we should find the length of the sides and the perimeter of this triangle. See you in the next video where we will learn how to find the length of the sides and the perimeter of this triangle. Bye bye. Welcome back. In the previous video, we learned about isosceles triangles and we started solving this question. For this particular isosceles triangle, we have the height as 8 centimeters and the base as 10 centimeters. We considered the first part of the question, that is finding the area of the triangle. With the height as 8 centimeters and the base as 10 centimeters, we were able to find the area and we got 40 centimeters squared. We are going to continue with the B and C parts, that is finding the length of the sides and perimeter of the triangle. So let's consider the length of the sides. We learned in the previous video that AB is the base of the triangle. So from A to B, which is 10 centimeters, is the base of this triangle. We also learned that the perpendicular distance from this point here, point C, to meet the line AB is the height of the triangle. So this line here, which is 8 centimeters, is the height of the triangle. We've learned that for isosceles triangle, For isosceles triangles, two sides of the triangle are equal. So in this question here, we have the base as AB, and we have that is giving us 10 centimeters. The two remaining sides are AC and BC. So for this triangle, the side AC is equal to the side BC. So from A to C is equal to from B to C. So all the question wants us to find is to find the length AC and the length BC. But since they are equal, we are going to find one of them, because if you find AC, it's the same as BC. So what we are saying is that for this particular isosceles triangle, from A to C is the same as from B to C, and we are using these lines to indicate that. Okay, we also learned in the previous video that for isosceles triangles, if we draw a line from this point here, point C, to meet the line AB, that is the height, where they meet, I'm going to call this point here point D, where the line from C meets the line AB. Okay, it meets it at point D. That is what I'm choosing to call it. Because this is a perpendicular line, it's going to divide AB into two equal parts. And AB is 10 centimeters. That means that from A to D is half of 10 centimeters, and from D to B is also half of 10 centimeters. Half of 10 centimeters is 5 centimeters, which means that from A to D is 5 centimeters, and from D to B is also 5 centimeters. So for isosceles triangles, if you draw a line from this point here to meet the base, which I'm going to call that point here point D, AD will be half of the base and DB is also half of the base. So the base is 10 centimeters and half of 10 centimeters is 5 centimeters. Now, if you look at this very carefully, you can see that ADC is forming a right-angled triangle. So if you take ADC, we are forming a right-angled triangle with the base as 5 centimeters and the height as 8 centimeters. Now we want AC, which is a side of the triangle. We have AD and we have DC. We want AC, which is the hypotenuse. We can use the Pythagoras theorem. As I said at the beginning of the videos on mensuration, we are going to apply the Pythagoras theorem a lot. So we are going to use the Pythagoras theorem to find AC, since this is a right-angled triangle. So if we apply the Pythagoras theorem here, we can say that the length of the square of the length of the hypotenuse. So here the hypotenuse is AC. That is the hypotenuse squared is equal to AD squared plus DC squared. We are looking for AC. So AC squared is equal to AD is 5 centimeters, so 5 squared, plus DC is 8 centimeters, so 8 squared. And this is going to give us AC squared is equal to 89. We take square root of both sides, and AC is giving us 9.4 centimeters. That means that from A to C is 9.4 centimeters. But since this is an isosceles triangle, if AC is 9 centimeters, then BC is also 9 centimeters, since the sides are the same. So from A to C is the same as from B to C. So if AC is 9 centimeters, then BC is also 9 centimeters. So we can say that the sides of the triangle are 9.4 centimeters long. So here we had 9.4 centimeters, not 9 centimeters. So if AC is 9.4 centimeters, then BC is also 9.4 centimeters. So the sides of the triangle are 9.4 centimeters long. Okay, so now we have the base, which is AB, as 10 centimeters. We have the sides as 9.4 centimeters. So the side AC is 9.4 centimeters and the side BC is also 9.4 centimeters. The perimeter of this triangle is the total distance around the triangle. So it means that here we are not going to include the height. We are looking for the distance around the triangle, which is AB plus AC plus BC. And this is going to give us 10 centimeters plus 9.4 centimeters plus 9.4 centimeters, which will give us 28.8 centimeters. So the perimeter of this triangle is 28.8 centimeters. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the area and perimeter of an isosceles triangle. Bye-bye. We are still on the topic mensuration. In the previous video, we solved the question on finding the area and perimeter of an isosceles triangle. In this video, we are going to solve another question. So let's consider the question for this video. Find the area and perimeter of the triangle below. We know that this is an isosceles triangle because the two lines here in the line AC and the line BC shows that the length AC is equal to the length BC. These two lines here, there are two lines here and there are also two lines here showing that AC is equal to BC. There is only one line here, meaning that AB is the length of AB is different from that of AC and that of BC. So we can see clearly AB is 16 meters and AC is 10 meters. So here AC is 10 meters. That means that BC is also going to be 10 meters since AC is equal to BC. So this is an example of an isosceles triangle. And we are supposed to find the area and perimeter of this isosceles triangle. So if you consider this isosceles triangle, as we said, AC is 10 centimeters. So from A to C is 10 centimeters. BC is also 10 centimeters since AC is equal to BC. So BC is also 10 centimeters. If we draw a line from C to meet AB, that is going to be the height. That's going to be the perpendicular height. If I call this point here, where that line meets AB, if I call that point here point D, we learned in the previous video that this line, that is the height, will divide the base, which is AB, into two equal parts. The base is 16 meters. So if it's dividing it into two equal parts, then AD will give us 8 meters, which is half of 16. Then DB will also give us 8 meters, which is half of 16. Okay, so we have this as our triangle. So we have AC as 10 meters, BC as 10 meters, then AB as 16 meters, but it has been divided into two. So AD is 8 meters and DB is also 8 meters. The first part of the question says that we should find the area of the triangle. We know that to find the area of a triangle, you need 1, the base, and 2, the height, because the formula says that the area of a triangle is half times the base times the height. We have the base as 16 meters, but we don't have the height. So we need to find the height of the triangle. If you consider this triangle here very carefully, we can draw a right angle triangle from this triangle. If you consider the point DBC, you see that it forms a right angle triangle. So DBC forms a right angle triangle, as you can see from here. From D to B is 8 meters. From B to C is 10 meters. So for the triangle DBC, we can see that from D to B is 8 meters and from B to C is 10 meters. But if you look at it very carefully, you can see that from C to D or from D to C is the height of the triangle. That is what we are looking for. Okay, since this is a right angled triangle, we can use the Pythagoras theorem to find the side that we want. If you are applying the Pythagoras theorem to this, we are going to have BC squared is equal to DC squared plus BD squared. Once again, I have explained the Pythagoras theorem and how to use it in the videos under trigonometry. If you watch that video, you are going to understand it very, very carefully. Here, I will just be quoting the theorem and you apply it to solve the questions. So BC squared is equal to DC squared plus BD squared. We are looking for DC. We have BC as 10 meters. So we have 10 squared is equal to DC squared plus BD is 8 meters. So 8 squared. When you simplify this, you are going to have 10 squared minus 8 squared is equal to DC squared. So DC squared is going to give us 36. You take square root of both sides, and DC, which is the height of this triangle, is 6 meters. So DC, which is the height of the triangle, is 6 meters. So now we know that the side AC is 10 meters, the side BC is 10 meters, and the side AB, which is the base, is 16 meters. Then the height of the triangle is 6 meters. We can now find the area of the triangle because we know that the area is equal to half times base times the height. Base is the base is 16 meters and the height is 6 meters. So you have half times 16 meters times 6 meters, and this is going to be 48 meters squared. So the area of this triangle is 48 meters squared. We are also going to find the perimeter of the triangle. As we learned in the previous video, the perimeter of the triangle is the total distance around the triangle. So AB plus AC plus BC. AB is 16 meters, AC is 10 meters, and BC is 10 meters. So we have 16 meters plus 10 meters plus 10 meters, and that is going to give us 36 meters. So the perimeter of the triangle is 36 meters. So using the Pythagoras theorem, we have been able to find the area of the triangle as 48 meters squared and the perimeter of the triangle as 36 meters. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to learn how to find the area and perimeter of an equilateral triangle. Bye-bye. We are on the topic mensuration. In the previous video, we learned how to find the area and perimeter of an isosceles triangle. In this video, we are going to learn how to find the area and perimeter of an equilateral triangle. So let's learn some few things about an equilateral triangle. For equilateral triangles, all the sides are equal in length. So for example, in this triangle, the side AB is equal to the side AC and is equal to the side BC. The length of the side AB or AC is equal to the length of the side BC and is equal to the length of the side AB. So all the sides are equal in length. And also, each of the interior angles is 60 degrees. So this interior angle here is 60 degrees, this interior angle here is 60 degrees, and this interior angle here is 60 degrees. So this is the unique property about equilateral triangles. All the sides are equal and each interior angle is 60 degrees. Just as it was for isosceles triangles, the area of this triangle here is still half times base times height. So for this triangle, AB is the base. The height is the perpendicular distance from C to meet the base here. And since it is a perpendicular line, it's going to divide the line AB into two equal parts. So it means that from A to this point here is the same as from this point here to B. Okay. Let's use what we've learned here to solve a question. The length of a side of an equilateral triangle is 18 centimeters. Find 1. the height of the triangle, 2, area of the triangle, and 3, perimeter of the triangle. So this is an equilateral triangle, and it says that the length of the side is 18 centimeters. We've learned that for an equilateral triangle, all the sides are equal. So if one side is 18 centimeters, then it means that all the sides are also 18 centimeters. So AC is 18 centimeters, BC is 18 centimeters, and AB is also 18 centimeters. We just learned that for equilateral triangles, all the interior angles are 60 degrees. So it means that this angle here is 60 degrees, this one here is 60 degrees, and this one here is also 60 degrees. The first part of the question says that we should find the height of the triangle. Let's concentrate on that. Okay, so we have the triangle ABC here. From A to C is 18 centimeters. From B to C is 18 centimeters. And from A to B is also 18 centimeters. Since the height is a perpendicular line, it's going to divide AB into two equal parts. So if you call this point here, that is the line from C to AB meets at point D. If you call this point here point D, then AD is 9 centimeters and DB is also 9 centimeters, since this line here will divide AB into two equal parts. Okay, so this is our triangle, and we are supposed to find the height of this triangle. The height of this triangle is the length of the line DC or CD. So let's consider this right angle triangle here, ADC. We can see that AD is 9 centimeters as we have here, and AC is 18 centimeters as we have here. We are looking for DC. We have AC and AD. We can do this in two ways. Someone can choose to use the Pythagoras theorem. If you do that, you will have AC squared is equal to AD squared plus DC squared, and you can find DC from there. Someone can also choose to use the trigonometric ratios, that is sine, cos, or tan. With this acute angle at 60 degrees, we can use the any of the trigonometric ratios or one of them to find the length of the line DC. Now, considering 60 degrees, remember we are looking for DC. So DC is opposite to 60 degrees. If you are going to use the trigonometric ratios, we have AC as the hypotenuse and we have AD as adjacent to 60 degrees. So we have the hypotenuse and we have adjacent. We are looking for opposite. So we can either use sine or we can use tan. So I'm going to use tan here. I'm going to use tan because with tan, we are going to have, we know that tan theta is equal to opposite divided by adjacent. So the opposite, which is DC, divided by the adjacent, which is AD, and with tan 60 we can find DC from there. Once again, I explained how to use the trigonometric ratios. I explained how to use each one of them in the videos on trigonometry. So if you want to learn more about how to use the trigonometric ratios, I recommend that you watch those videos. Okay, so from this triangle ADC, we can say that tan 60 degrees is equal to the length DC divided by DC, which is the opposite, divided by the adjacent, which is 9 or 9 centimeters. So we have tan 60 degrees is equal to DC divided by 9. We multiply both sides by 9, and DC will give us 9 times tan 60 or 9 tan 60, and that is going to give us 15.6 centimeters. So the length of the height, which is the length of DC, is 15.6 centimeters. Once again, as I said, someone can choose to use the Pythagoras theorem. With AC and AD, you can find DC. But here, I chose to use the trigonometric ratios, and you are still going to get the same answer. So with tan 60 degrees, you are going to have DC divided by 9, and if you simplify, DC will give us 15.6 centimeters. So the height of the triangle is 15.6 centimeters. Okay, so we now have the height of the triangle as 15.6 centimeters. We have the base as 18 centimeters, and we have the size as also 18 centimeters. We can find the area and perimeter. The area of a triangle is half times base times height. So this is going to give us half times base is 18 centimeters times height is 15.6 centimeters. You simplify this and you get 140.4 centimeters squared. So the area of the triangle is 140.4 centimeters squared. The perimeter is the total distance around the figure. So the perimeter of this triangle is going to be the length of AB plus the length of AC plus the length of BC. And we know that AB is equal to AC is equal to BC, and they are all 18 centimeters. So 18 centimeters plus 18 centimeters plus 18 centimeters, and we are going to have 54 centimeters. So the perimeter of the triangle is 54 centimeters. We found the area, we got 140.4 centimeters, and the perimeter is also 54 centimeters. Thank you for watching this video. Don't forget to subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the area and perimeter of an equilateral triangle. Bye-bye. We are on the topic mensuration. In the previous video, we solved the question on finding the area and perimeter of an equilateral triangle. We are going to solve another question in this video. So let's consider our question. An equilateral triangle is 10 centimeters high. Find the length of the sides of the triangle, the area of the triangle, and the perimeter of the triangle. So now we have been given the height of the triangle. So if we have the triangle ABC, we have this triangle ABC as an equilateral triangle. We have been given the height of the triangle, which is the perpendicular height, as 10 centimeters. So from C to the line AB, the perpendicular line from C to the line AB is 10 centimeters long. So it means that the height of this triangle is 10 centimeters. The question says that we should find the length of the sides of this triangle. We learned in the previous video that for equilateral triangles, each of the interior angle is 60 degrees. So we can say that the angle formed here is 60 degrees. The one formed here is also 60 degrees, and the one formed here is also 60 degrees. This is very important because it's going to help us to solve this question. Okay, so we have this triangle ABC. I'm calling the point here, that is where the line from C meets AD. I'm going to call that point D. So we can say that from C to D is 10 centimeters. So the height of the triangle is 10 centimeters. Now we need to find the length of the sides. Remember that for equilateral triangles, all the sides are equal. So if you're able to find one side, it's the same as the other two sides. Okay, so if you consider the triangle ADC, we have this interior angle here as 60 degrees. Then we have this line, this side DC as 10 centimeters. We are looking for a side of the triangle. If you look at the triangle very carefully, you can see that AC is one side of the triangle. So we are looking for AC. Okay, we have 60 degrees here. 10 centimeters is opposite to 60 degrees. We have AC as the hypotenuse. So we have the opposite, which is 10 centimeters, and we are looking for the hypotenuse, which is AC. We have opposite, we have hypotenuse, so we are going to use sine. So we can say that considering this triangle, sine 60 degrees is going to give us 10 centimeters, or 10 divided by the length AC. Okay, You multiply the left hand side by AC, you multiply the right hand side by AC, you are going to get AC sine 60 degrees is equal to 10. I'll divide both sides by 60 degrees and AC is equal to 10 divided by, I'll divide both sides by sine 60 degrees and AC will give us, you see when you do this, sine 60 here will cancel sine 60 here. So you have AC is equal to 10 divided by sine 60. And when you do this on your calculator, you are going to have 11.5 centimeters. So we have AC as 11.5 centimeters. It means that the length of the side of the equilateral triangle is 11.5 centimeters. Now, since AC is equal to BC and is equal to AB, we can say that BC is also 11.5 centimeters and AB is also 11.5 centimeters. So AC is 11.5 centimeters, BC is 11.5 centimeters, AB is also 11.5 centimeters. Now we can find the area. Area of a triangle is equal to half times base times height. Base is now 11.5 centimeters. So you have half times base, which is 11.5 centimeters, and height, which is 10 centimeters. So half times 11.5 centimeters times 10 centimeters. And this gives us 57.5 centimeters squared. So the area of the triangle is 57.5 centimeters squared. The perimeter is the total distance around the triangle. So it's going to be the length of AB plus the length of AC plus the length of BC. And each one of them is 11.5 centimeters. So 11.5 centimeters plus 11.5 centimeters plus 11.5 centimeters. And this is going to give us 34.5 centimeters. So the area of the triangle is 57.5 centimeters squared and the perimeter of the triangle is 34.5 centimeters. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to apply everything we've learned so far to find the area and perimeter of a scalene triangle. Bye-bye. We are on the topic mensuration. In the previous video, we learned how to find the area and perimeter of an equilateral triangle. In this video, we are going to learn about the last type of triangle, which is the scalene triangle. Scalene triangles are unique. They are different from all the types of triangles. For scalene triangles, the length of the sides are different. So the length of AC is different from that of AB and is different from that of BC. All the interior angles are also different. So the angle formed here and the angle formed here and the angle formed here. That is, the angle formed at point A and point B and point C are also different. And there is no line of symmetry, meaning that there is no line that you can draw that will divide the triangle into two equal parts. So it makes finding the area of a scalene triangle a bit complicated. To help us find the area of a scalene triangle, we are going to consider this example. So in this example here, we are going to find the area and perimeter of this scalene triangle PQR. Because there is no line of symmetry, you see that this triangle PQR is part of a bigger right-angled triangle, that is PSR. So you see that PQR is part of the triangle PSR. When you have something like this, then you can find the area and perimeter of this scalene triangle PQR. Let's learn how to do it. So in this triangle, we have been given from S to R as 9 centimeters, as we have here. Then we have QR as 4 centimeters. So if SR is 9 centimeters and QR is 4 centimeters, then we can say that SQ is 5 centimeters, because 5 centimeters plus 4 centimeters will give us a total of 9 centimeters. Now let's consider this triangle very carefully. Remember, we are looking for the area of triangle PQR. As I said, since there is no line of symmetry in a scalene triangle, we can't find the height of the triangle. And if you can't find the height of the triangle, there is no way you can find the area of the triangle. So here, the triangle PQR is part of a bigger right angle triangle, that is PSR. So we can work our way around it such that we get the area of triangle PQR. You can also see that triangle PSQ is also a right angle triangle. So we have two right angle triangles here. The bigger one, which is PSR, and the smaller one, which is PSQ or PQS. Okay, you can also see that triangle PQS, if you add that to PQR, you get the bigger one, which is PSR. That is, you add this one here, this right angle triangle here, to this, you are going to get the bigger right angle triangle. So we can see that the area of the bigger right angle triangle, that's the area of triangle PQR. If you want the area of triangle PQR, which is the scalene triangle, is going to be the area of the bigger right angle triangle, which is PSR, minus the area of the smaller right angle triangle PQS. Because if you subtract PQS from the bigger one, which is PSR, you are going to get the scalene triangle, which is PQR. I hope that is clear. So the area of the triangle PQR is going to be area of the bigger right angle triangle, which is PSR, minus the area of the smaller right angle triangle, which is PQS. We can find area of PSR and area of PQS since they are right angle triangles. We know that area of PSR, so PSR is going to be half times the base. So you are considering PSR. Since you are considering PSR, SR is going to be the base, and that is 9 centimeters. And PS is going to be the height, and that will give us 6 centimeters. So SR is the base, that is 9 centimeters, and PS is the height, which is 6 centimeters. So area of triangle PSR is equal to half times base, which is 9 centimeters, times the height, which is 6 centimeters. And that is going to give us 27 centimeters squared. Now let's move on to area of triangle PQS. If you are considering triangle PQS, QS or SQ is the base and PS is the height. Okay, so area of triangle PQS is equal to half times the base, which is QS or SQ, and that is 5 centimeters, times the height, which is PS, and that is 6 centimeters. So half times 5 centimeters times 6 centimeters, and that will give us 15 centimeters squared. So we now know area of triangle PSR as 27 centimeters squared and area of triangle PQS as 15 centimeters squared. So if you want area of triangle PQR is going to be 27 centimeters squared minus 15 centimeters squared, and that will give us 12 centimeters squared. So you see that with these two right angle triangles, we have been able to find the area of this scalene triangle PQR as 12 centimeters squared. The question also said that we should find the perimeter of the triangle PQR. We are going to do that in the next video. So see you in the next video. Welcome back. In the previous video, we learned about scalene triangles and we started solving this question. With the help of these two right-angled triangles PSR and PQR and PQS, we were able to find the area of this scalene triangle and we got 12 centimeters squared. We are going to continue with finding the perimeter of the triangle PQR in this video. So let's learn how to do that. Finding the perimeter of triangle PQR. We've learned in the previous videos that the perimeter of a triangle is the total distance around the triangle. So the perimeter of triangle PQR is going to be the length of PQ plus the length P plus the length QR plus the length PR. So we need to find PQ, we need to find PR because we already know QR as 4 centimeters. Let's concentrate on finding PQ. If you look at this diagram very carefully, you can see that PQ is part of this right angle triangle PQS. So if you consider the right angle triangle PQS, we have PS as 6 centimeters and SQ or QS as 5 centimeters. And we have PQ in it, so we can find PQ from here. We know PS, we know QS. We can use the Pythagoras theorem. If you apply the Pythagoras theorem here, you are going to have PQ squared is equal to SQ squared plus PS squared. And this will give us PQ squared is equal to 5 squared plus 6 squared. You simplify this, you get square root. PQ will give us square root of 61. And so PQ is 7.8 centimeters. So we have been able to find PQ as 7.8 centimeters. So we now know PQ. We also know QR. What we don't know yet is PR. Let's consider PR also very carefully. We are going to consider PR very carefully here. Now, if you look at PR, you can see that it's part of the bigger right angle triangle PSR. Okay, so PR is part of triangle PSR, which is a right angle triangle. So if you consider the right angle triangle PSR, you see that PS is 6 centimeters, SR is 9 centimeters, and PR is part of it. Okay, so we can use the Pythagoras theorem to find PR from here. If you apply the Pythagoras theorem here, you have PR squared is equal to SR squared plus PS squared. And this will give us PR squared is equal to 9 squared plus 6 squared. PR squared is equal to 117. You take square root of both sides and PR is equal to 10.8 centimeters. So we now know PR as 10.8 centimeters. And we also know PQ as 7.8 centimeters. We know QR as 4 centimeters. So if you consider the scalene triangle PQR, we know all the sides. What is the perimeter of a triangle is the total distance around the triangle. So it means that the perimeter of this triangle PQR is equal to the length of PQ plus the length of QR plus the length of PR. PQ is 7.8 centimeters, QR is 4 centimeters, and PR is 10.8 centimeters. So you add everything and you are going to get 22.6 centimeters. So the perimeter of this triangle is 22.6 centimeters. The perimeter of the triangle PQR is 22.6 centimeters as we found out. Thank you for watching this video and all the videos on triangles. So far, we've considered how to find the area and perimeter of a scalene triangle, of an isosceles triangle, of an equilateral triangle, and a right-angled triangle. In the next video, we are going to learn how to find the area and perimeter of quadrilaterals. And the first quadrilateral we are going to learn how to find its area and perimeter is a rectangle. So we will consider how to find the area and perimeter of a rectangle. Bye-bye. We are on the topic mensuration. In the previous videos, we have considered how to find the area and perimeter of triangles. In this video, we are going to consider how to find the area and perimeter of a rectangle. What is a rectangle? A rectangle is a four-sided plane figure. That is one property of a rectangle. It has four sides. So if you consider this plane figures here, we have the side AB, the side DC, the side AD, and the side BC. All the sides are at right angles to each other. So the side AD is at right angle to the side DC. That is why you see this sign here. The same thing happens here, and the same thing happens here, and the same thing also happens here. Opposite sides are equal and parallel. So for rectangles, the opposite sides are equal in length and they are parallel. So here, the length AB is equal to the length DC, and the same way the length AD is equal to the length BC. So this is a rectangle. Each interior angle is 90 degrees, or the interior angles, the sides are at right angles to each other. So each interior angle is 90 degrees. So the angle formed at point D here is 90 degrees. The angle formed at point A here is 90 degrees. The angle formed at point B is 90 degrees. And the angle formed at point C is also 90 degrees. Now, the opposite sides are also equal in length and they are parallel. So the length AD is equal to the length BC, and the length AB is equal to the length DC. That's why you see that AB has one line across it, the same with DC. And for AD, there are two lines here, and for BC also, there are two lines here. So the length AB is equal to the length DC, and the length AD is equal to the length BC. For this rectangle, AB is referred to as the length, which is normally represented with the small letter L, and BC is referred to as the width of the rectangle. So for here, AB is the length of the rectangle and BC is the width of the rectangle, which is also represented with W. We are going to learn how to find the area and perimeter of this rectangle, of a rectangle. The perimeter of a rectangle is equal to 2 times the length plus 2 times the width. So if you want to find the perimeter of a rectangle, find the length and multiply it by 2, then you find the width, you multiply it by 2, and you add them. Because you can see from here that BC is equal to AD. So if you multiply the width by 2, you are going to get BC and AD. In the same way, AB is equal to DC. So if you multiply the length by 2, you are going to get AB and DC. And we learned that the perimeter of a figure is the total distance around the figure. So if you add them, you are going to get 2 times the length plus 2 times the width. So the perimeter of a rectangle is equal to 2 times the length plus 2 times the width. Let's concentrate on the area now. The area of a rectangle is the length of the rectangle times the width of the rectangle. So to find the area of a rectangle, you multiply the length by the width. These are the two formulas that you'll be using. Let's use it to solve a question. The length of a rectangle is 10 centimeters and its width is 6 centimeters. Find the perimeter and area of the rectangle. Okay, so this is our solution. If you draw the rectangle here, we have the rectangle A, B, C, D. The question says that the length is 10 centimeters. So AB is 10 centimeters and the width is 6 centimeters. So BC is also 6 centimeters. We are going to concentrate on finding the perimeter and the area. So the length is 10 centimeters and the width is also 6 centimeters. We know that the area of a rectangle is the length times the width. So the length, which is 10 centimeters, times the width, which is 6 centimeters, and that will give us 60 centimeters squared. The perimeter of the rectangle is 2 times the length plus 2 times the width. The length is 10 centimeters and the width is 6 centimeters. So we have 2 times 10 centimeters plus 2 times 6 centimeters, and that will give us 32 centimeters. So the area of the rectangle is 60 centimeters squared and the perimeter of the rectangle is 32 centimeters. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the area and perimeter of a rectangle. Bye-bye. We are still on the topic mensuration. In the previous video, we learned how to find the area and perimeter of a rectangle and we solved a question. We are going to solve another question on finding the area and perimeter of a rectangle in this video. So let's consider the question for this video. The length of a rectangle is 16 centimeters. If the area of the rectangle is 80 centimeters squared, find the width and perimeter of the rectangle. So in this question, we have been given the length of the rectangle and the area of the rectangle. And we are going to use these two information to find the width and perimeter of the rectangle. Okay. So we are going to let L represent the length of the rectangle and W represent the width of the rectangle. If the length of the rectangle is L and the width of the rectangle is W, we know that the area of a rectangle is the length times the width. So area of a rectangle is equal to length times width, or L times W. We know area of the rectangle. It has been given to us as 80 centimeters. So it means that the area of the rectangle is 80 centimeters squared. Sorry, the area is 80 centimeters squared. So that is what we have here. We also know the length of the rectangle as 16 centimeters. So the length of the rectangle here is 16 centimeters. We are looking for the width. So we have 80 centimeters squared is equal to 16 centimeters times W. This is a linear equation. So we solve this linear equation for the variable which is W. To do this, we divide the left hand side by 16 centimeters and the right hand side also by 16 centimeters. So we are going to have 80 centimeters squared divided by 16 centimeters is equal to 16 centimeters times W divided by 16 centimeters. So we have 80 centimeters squared divided by 16 centimeters is equal to 16 centimeters times W divided by 16 centimeters. And when you have this, 16 centimeters will cancel 16 centimeters here. So we have W, which is the width of the rectangle, being equal to 80 centimeters squared divided by 16 centimeters. So we have 80 centimeters squared divided by 16 centimeters. Since we have centimeters squared here and centimeters, this centimeters will cancel one of the centimeters squared. So it means that the unit of the width will be in centimeters. 80 divided by 16 will give us 5. So you are going to have the width is equal to 5 centimeters. So we know that the width of the rectangle is 5 centimeters. The question also said that we should find the perimeter of the rectangle. Now we know the length of the rectangle as 16 centimeters and we know the width of the rectangle as 5 centimeters. In the previous video, we learned that the perimeter of a rectangle is 2 times the length plus 2 times the width. We know the width as 16 centimeters. We know the length as 16 centimeters and the width as 5 centimeters. So the perimeter of the rectangle is equal to 2 times 16 centimeters plus 2 times 5 centimeters. And that will give us 42 centimeters. So we can say that the width of the rectangle is 42 centimeters. Thank you for watching this video. Don't forget to like and subscribe to this channel for more videos if you haven't done that already. In the next video, we are going to solve another question on finding the area and perimeter of a rectangle. Bye-bye. We are on the topic mensuration. In the previous video, we solved a question on finding the area and perimeter of a rectangle. We are going to solve another question in this video. So let's consider the question for this video. The length of a rectangle is twice its width. If the perimeter of the rectangle is 18 meters, find the length and width of the rectangle and the area of the rectangle. So for this particular rectangle given to us, the length of the rectangle is twice its width. What that means is that the length is equal to 2 times the width. And the perimeter of the rectangle is given to us as 18 meters. We are going to use this information given us to find the length and width of the rectangle and the area of the rectangle. So we are going to let L represent the length of the rectangle and W represent the width of the rectangle. We learned that the length of the rectangle is twice its width. That is what the question told us. The length of the rectangle is twice its width. What this means is that the length of the rectangle is 2 times the width. So L is equal to 2W. We learned in the previous video that the perimeter of a rectangle is equal to 2 times the length plus 2 times the width. The question told us that the perimeter of this rectangle is 18 meters. So 18 meters is equal to 2 times the length plus 2 times the width. But we have also found out that for this particular rectangle, the length is equal to 2 times the width. What that means is that wherever we see 2W, we can replace it with L because L is equal to 2W. So 18 meters is equal to 2L plus 2W can also be written as 18 meters is equal to 2L plus L because 2W is now L. When we simplify this, 2L plus L will give us 3L. So 3L is equal to 18 meters. This is a linear equation. We want to find L, so we divide both sides by 3 and L will give us 6 meters. So the length of this rectangle is 6 meters. The question also said that we should find the width of the rectangle. We know that for this rectangle, the length is equal to 2 times the width. We have just found out that the length is 6 meters. So we can say that 2W or 2 times the width is equal to 6 meters. This is another linear equation. We want to find W, which is the width. So we divide both sides by 2 and W will give us 3 meters. So the width of the rectangle is 3 meters. So we have been able to find the length as 6 meters and the width as 3 meters. The second part of the question said that we should find the area of the rectangle. The area of a rectangle is equal to the length of the rectangle times the width of the rectangle. The length of the rectangle is 6 meters and the width of the rectangle is 3 meters. So the area is equal to 6 meters times 3 meters. And this will give us 18 meters squared. So the area of the rectangle is 18 meters squared. Thank you for watching this video. Don't forget to like and subscribe to this channel for more videos. In the next video, we are going to learn how to find the area and perimeter of another quadrilateral. The quadrilateral we'll be considering is a squared. So we are going to learn how to find the area and perimeter of a square. Bye-bye. We are still on the topic mensuration. In the previous video, we learned about how to find the area and perimeter of a rectangle. In this video, we are going to consider a square and how to find the area and perimeter of a square. A square is a special rectangle with all the sides being equal to each other. So for squares, all the sides are equal to each other. So AB in this diagram is equal to BDC and is equal to AD and is equal to BC. So for squares, all the four sides are equal in length, and each of the interior angle is also 90 degrees. So the angle formed at A is 90 degrees, the angle formed at B is 90 degrees, the angle formed at C is 90 degrees, and the angle formed at D is also 90 degrees. So for squares, the perimeter of the squared is the total distance around the squared. So if I call AB as the length represented by L, then BC is also the length, DC is the length, and AD is also the length. So the perimeter is equal to L plus L plus L plus L, which will give us 4L. So for the perimeter of a square, multiply the length by 4 and you get the perimeter. For the area is L times L. So the area of a square is the square of one of the length, or the square of the length. So L times L giving us L squared. This is how to find the area and perimeter of a square. Let's solve a question. The side of a square is 18 millimeters long. Find the perimeter and area of the square and the length of the diagonal. Let's concentrate on the first part, the perimeter and area of the square. So for example, if this is the square, then AB is 18 millimeters, BC is also 18 millimeters, so DC is also 18 millimeters, and AD is also 18 millimeters. So the length is 18 millimeters. The perimeter of a square is equal to 4 times the length, and this will give us 4 times 18 millimeters, which is 72 millimeters. The area of a square is equal to the length squared. So the area is equal to 18 millimeters squared. 18 squared will give us 324. So the area of the square is 324 millimeters squared. So the perimeter is 72 millimeters and the area is 324 millimeters squared. The question also said that we should find the length of the diagonal. When we talk about the diagonal, in this diagram, it is the line drawn from A to C or the line drawn from B to D. So for this diagram here, for this particular diagram, the diagonal is the length of the line drawn from A to C, or the diagonal is the line drawn from A to C, or the line drawn from D to B. Since it is a square, the line drawn from A to C will be the same as the length of the line drawn from A to C will be the same as the length of the line drawn from B to D. So you can find either one of them and you still have the same answer. So we are going to concentrate on finding the length of the line drawn from A to C, since that is the diagonal in this case. So if we take out the points A, B, C, you see that it's forming a right angled triangle because the angle formed at B here is 90 degrees. The length AB is 18 millimeters. The length BC is also 18 millimeters. We are looking for AC, which is the diagonal. We are going to apply the Pythagoras theorem. If you apply the Pythagoras theorem here, we will have AC squared is equal to AB squared plus BC squared. AB is 18 millimeters, BC is 18 millimeters. So AC squared is equal to 18 millimeters squared plus 18 millimeters squared. When you simplify this, you are going to have AC is equal to 25.5 millimeters. So the length of the diagonal is 25.5 millimeters. In the same way, if you find the length of the line drawn from B to D, you are going to have 25.5 millimeters. So for this particular square, the length of the diagonal is 25.5 millimeters. Thank you for watching this video. Don't forget to subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the area and perimeter of a square. Bye-bye. We are on the topic mensuration. In the previous video, we learned about a square and how to find the area and perimeter of a square. We are going to solve another question in this video. Let's consider the question for this video. The diagonal of a square is 16 centimeters long. Find the length of the square and perimeter and area of the square. Okay, so for this question given to us, we are being told that the length, we are going to let the L represent the length of the square. And we have also been told that the diagonal of the square is 16 centimeters. So we will let L represent the length of the side of the square. Okay, so if we draw a simple square here, PQRS, the diagonal PR is given as 16 centimeters. We have let L represent the length of the side of a square. So PQ is L, QR is L, SR is also L, and PS is also L. We learned in the previous video that for a square, each of the interior angles is 90 degrees. So it means that the angle formed at Q here is also 90 degrees. Now, if you consider the points P, Q, R, we can see that PQR forms a right-angled triangle with PR as the hypotenuse, giving us 16 centimeters. PQ is L and QR is also L. Remember, we are looking for L, which is the length of the side of the square. We can use the Pythagoras theorem to find the value of L. If we apply the Pythagoras theorem on this right-angled triangle, you will see that PR squared is equal to PQ squared plus QR squared. PR is 16 centimeters, so 16 squared is equal to PQ is L and QR is also L. So 16 squared is equal to L squared plus L squared. We learned from algebra that L squared plus L squared is the same as 2L squared. And this is equal to 16 squared will give us 256. We divide both sides by 2 and we will have L squared is equal to 128. We want to find L. So what we do is that we take square root of the left hand side and we take square root of the right hand side. Square root of L squared will give us L. Square root of 128 will give us 11.3. So L is equal to 11.3 centimeters. That means that for this square, the length of the side is 11.3 centimeters. The question said that we should find the perimeter of the square. We learned in the previous videos that perimeter of a square is equal to 4 times the length. We have just found out that the length is 11.3 centimeters. So the perimeter of the square is equal to 4 times 11.3 centimeters, which will give us 45.2 centimeters. So we can say that the perimeter of the square is 45.2 centimeters. It also said we should find the area of the squared. Area of a squared is equal to the length squared. So the length is 11.3 centimeters. So it means that the area of the squared is equal to 11.3 centimeters squared. 11.3 squared will give us 127.69. So the area of the squared is 127.69 centimeters squared. So the perimeter of a square with a diagonal of 16 centimeters is 45.2 centimeters, and the area of the square with a diagonal of 16 centimeters is 127.69 centimeters squared. Thank you for watching this video. Please subscribe to this channel for more videos. In the next video, we are going to learn how to find the area and perimeter of another quadrilateral. The quadrilateral we'll be considering is a parallelogram. So you will learn how to find the area and perimeter of a parallelogram. Bye-bye. We are still on the topic mensuration. In the previous video, we learned how to find the area and perimeter of a square. In this video, we are going to learn how to find the area and perimeter of a parallelogram. A parallelogram is a four-sided plane figure. So for example, in the diagram here, we have the plane figure with the vertex A, B, C, and D. This is an example of a parallelogram. It has four sides. In a parallelogram, opposite sides are equal in length and parallel to each other. So in this diagram, the side AB is parallel to the side BDC and they are equal in length. In the same way, the side AD is parallel to the side BC and they are also equal in length. For this particular parallelogram here, AB is called the base of the parallelogram, and BC is also called the side of the parallelogram. But remember that AB is equal, the length of AB is equal to that of DC, and the length of BC is also equal to that of AD. The perpendicular distance drawn from the line DC to meet the base is called the height of the parallelogram. So for this parallelogram, this distance, the length of the line drawn from DC to meet AB, which is the base, is called the height of the parallelogram. And since it is a perpendicular line, it's going to create an angle of 90 degrees at the point where it meets the base. How do we find the perimeter of a parallelogram? The perimeter of a parallelogram is equal to 2 times the side plus 2 times the base. So for a parallelogram, the perimeter is equal to 2 times the side, which is S, plus 2 times the base, which is B. The area of a parallelogram is equal to the base times the height. So if you have the base and the height and you multiply them, you have the area of the parallelogram. Let's use this to solve a question. Find the perimeter and area of the parallelogram below. So you have been given this parallelogram A, B, C, D. We can see from here that AB is the base and is giving us 37 centimeters. It means that DC is also 37 centimeters. AD is the side of the parallelogram and is giving us 25 centimeters. So BC is also 25 centimeters. Now, the perpendicular distance from this line, which is DC, to meet the base, which is AB, is 19 centimeters. It means that if you draw a line from DC, a perpendicular line from DC to meet here, to meet AB, which is the base, is going to be 19 centimeters as we have here. So that means that the height of this parallelogram is 19 centimeters because that is the perpendicular height. Okay, so we know the base of the parallelogram as 37 centimeters. The side of the parallelogram is 25 centimeters. And the height, that is the perpendicular height of the parallelogram, is 19 centimeters. The question said we should find the perimeter of the parallelogram. We know that the perimeter of the parallelogram is equal to 2 times the side plus 2 times the base. The side is 25 centimeters and the base is 37 centimeters. So you have 2 times 25 centimeters plus 2 times 37 centimeters, and that will give us 124 centimeters. So the perimeter of this parallelogram is 124 centimeters. It also said that we should find the area of this parallelogram. The area of a parallelogram is equal to the base times the height. The base is 37 centimeters and the height is 19 centimeters. So the area of this parallelogram is equal to 37 centimeters times 19 centimeters, and that will give us 703 centimeters squared. So from here, we have been able to find the area of the parallelogram as 124 centimeters, and we have been able to find the perimeter of the parallelogram as 124 centimeters and the area of the parallelogram as 703 centimeters squared. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the area and perimeter of a parallelogram. Bye-bye. We are on the topic mensuration. In the previous video, we learned how to find the area and perimeter of a parallelogram, and we solved a question. In this video, we are going to solve another question. So let's consider the question for this video. Find the perimeter and area of the parallelogram ABCD below. So this is the diagram given to us, and we are supposed to find the area and perimeter of the parallelogram ABCD. Okay, so if you look at this parallelogram very carefully, we can see that AD has been given to us as 4 meters, and that's the side of the parallelogram. Now, DC, which is the same as AB, has been given to us as 7 meters, so that is the base of the parallelogram. The 9 meters given to us is the distance from A to E. That is not the base. The base is the distance from A to B, which is the same as the distance from D to C. So it means that in this diagram, the base of the parallelogram, or AB, is 7 meters. So we have the side as 4 meters and we have the base as 7 meters. With the side and the base, we can find the perimeter of the parallelogram. We know that the perimeter of a parallelogram is equal to 2 times the side plus 2 times the base. The side is 4 meters and the base is 7 meters. So it's equal to 2 times 4 meters plus 2 times 7 meters, and that will give us 22 meters. So the perimeter of this parallelogram is 22 meters. Let's move on to the second part of our question, which is finding the area of this parallelogram. To find the area of a parallelogram, we know that the formula is the base times the height. That means that we need the height of this parallelogram. That was not given to us, so we have to find it. The height of this parallelogram is the perpendicular distance drawn from DC to meet AB. So the distance drawn, the line drawn from DC, so the line drawn from DC to meet AB, that perpendicular line is called the height of this parallelogram. If you look at this diagram very carefully, you will see that the line drawn from DC to meet AB is the same as the line from C to E. So it means that if we're able to find the distance CE or EC, we are going to have the height of the parallelogram. Okay, so let's concentrate on finding the distance EC or CE. Considering this diagram very carefully, you can see that AE, the distance AE is 9 meters and the distance AB is 7 meters. So if AE is 9 meters and AB is 7 meters, then this small distance here BE is going to be 9 meters minus 7 meters, which is 2 meters. If you also look at this diagram very carefully, we learned in the previous video that for parallelograms, the length of opposite sides are equal. So if AD is 4 meters, we can say that BC is also 4 meters since they are opposite. And as we've just found out, if AE is 9 meters and AB is 7 meters, then this small distance here, which is BE, is 2 meters, because 7 meters plus 2 meters will give us 9 meters. So we now have BC as 4 meters, we have BE as 2 meters. You can see that this here, the angle created at E here will be a right angle, because this perpendicular distance here, this is a perpendicular line, so it's going to meet the line AE at right angle. So the angle created at point E will be 90 degrees. And when we form a right angle triangle using the points AEC, using the points BEC, we are going to have a right angle triangle like this, which has BC as 4 meters, BE as 2 meters, and the distance we are looking for is EC. So we are going to apply the Pythagoras theorem here to find EC. If you apply the Pythagoras theorem here, you will see that BC is equal to BC squared is equal to BE squared plus EC squared. And this is going to give us 4 squared is equal to 2 squared plus EC squared. When you simplify this, you are going to have EC squared is equal to 12. You take square root of both sides, and EC is equal to 3.5 meters. That means that the height of this parallelogram is 3.5 meters, because the height of the parallelogram here is EC. Okay, so we now have the height of the parallelogram as 3.5 meters. We know that the base is 7 meters and the side is 4 meters. We want to find the area of the parallelogram. The area of a parallelogram is equal to the base times the height. We know that the base is 7 meters and we just found out that the height is 3.5 meters. It means that the area of this parallelogram is equal to 7 meters times 3.5 meters, which is the height. 7 meters times 3.5 meters will give us 24.5 meters squared. So for this parallelogram, the area is 24.5 meters squared. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to consider another quadrilateral. The quadrilateral we'll be considering is a trapezium. So you will learn how to find the area and perimeter of a trapezium. Bye-bye. We are on the topic mensuration. In the previous video, we learned how to find the area and perimeter of a parallelogram. In this video, we are going to learn how to find the area and perimeter of a trapezium. A trapezium is a four-sided plane figure. So a trapezium is an example of a quadrilateral, a four-sided plane figure. One unique property about trapezium is that one pair of opposite sides are parallel but unequal. The figure we have here, figure ABCD, is an example of a trapezium. If you consider this figure very carefully, we can see that the side DC is parallel to the side AB. So for trapeziums, you have one pair of opposite sides being parallel but not equal. It's clear that the length DC is not equal to the length AB. AB is longer than DC. So for trapeziums, you have one pair of opposite sides being parallel but unequal. Remember that AD is not equal to BC. they have different lengths. How do we find the area and perimeter of a trapezium? Considering this trapezium, let's say that we call this side here, we call DC, the length DC, we call that A. The length AB is B. The length AD is C, and the length BC is D. We know that the perimeter of a figure or the perimeter of a plane figure is the sum of the distance around the figure. So for this particular trapezium here, the perimeter is equal to A plus B plus C plus D. That will give us the perimeter of this trapezium. How do we find the area of a trapezium? The formula for finding the area of a trapezium is half times sum of the length of the parallel lines times height. So to find the area of a trapezium, the formula is half times sum of the length of the parallel lines times height. We've seen that for trapeziums, one pair of opposite sides are parallel but unequal. To find the area is half multiplied by the sum of those two, the sum of the length of those two parallel lines. So here the two parallel lines are DC and AB. The length of DC is A and the length of AB is B. So the area of this trapezium is half times the sum of the length of these two parallel lines. So A plus B. That is the length of DC plus the length of AB, which will give us A plus B, times the height of the trapezium. The height of the trapezium is the perpendicular height. So the perpendicular line drawn from DC to meet AB. So here in this diagram, H represents the height of the trapezium. The perpendicular line drawn from DC to meet AB will give us the height of the trapezium in this case. So for this particular trapezium here, the perimeter is A plus B plus C plus D. And the area is half times sum of the length of the parallel lines times height, which will give us half times A plus B times H. Let's use this to solve a question. The parallel sides of a trapezium are 15 centimeters and 10 centimeters long. The height of the trapezium is 5 centimeters. Find the area of the trapezium. So for this particular trapezium, we have been given the length of the parallel lines. So the length of the parallel sides. One of them is 15 centimeters and the other is 10 centimeters. We have also been given the height of the trapezium. The question says that we should find the area. Area of a trapezium is equal to half times the sum of the length of the parallel lines times the height. Okay. In this question here, we were given the length of the parallel sides as 15 centimeters and 10 centimeters. So the area is equal to half times the sum of these lengths, 15 centimeters and 10 centimeters, since they are the parallel sides, times the height of the trapezium, which is 5 centimeters. So you have half times 10 centimeters plus 5 centimeters. Remember, since this is a binomial, you have to put it in a bracket. So it's 10 centimeters plus 15 centimeters in a bracket, then times 5 centimeters. This is going to give us half times 10 centimeters plus 15 centimeters will give us 25 centimeters times 5 centimeters. If you simplify this, you are going to have 62.5 centimeters squared. So the area of this trapezium is 62.5 centimeters squared. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the area and perimeter of a trapezium. Bye-bye. We are on the topic mensuration. In the previous video, we learned how to find the area and perimeter of a trapezium and we solved a question on it. In this video, we are going to solve another question on finding the area and perimeter of a trapezium. Let's consider the question for this video. Find the perimeter and area of the trapezium below. So in this trapezium, we have the side AB being parallel to the side DC. So the two parallel sides are AB and DC. AB is given as 7 centimeters, DC is 5 centimeters, AD is 2.8 centimeters, BC is 3 centimeters, and the height of the trapezium is 2 centimeters. The question says that we should find the perimeter and area. Let's begin with the perimeter. For this particular trapezium, the perimeter is equal to the length AB plus the length BC plus the length CD plus the length DA. So the total distance round the trapezium. And it's going to be 7 centimeters plus 3 centimeters plus 5 centimeters plus 2.8 centimeters. When you add everything here, we are going to have 17.8 centimeters. So the perimeter of this trapezium is 17.8 centimeters. The next part of the question says we should find the area of the trapezium. We learned in the previous video that the area of a trapezium is equal to half times sum of the length of the parallel sides times the height. We know from the diagram here that the height is 2 centimeters. As I said previously, the two parallel sides are DC and AB. The length of DC is 5 centimeters. The length of AB is 7 centimeters. So the area of this trapezium is equal to half times the two parallel sides have the length 5 centimeters and 7 centimeters. So the sum of it, that means that 5 centimeters plus 7 centimeters times the height of the trapezium, which is 2 centimeters. This is going to give us half times 5 centimeters plus 7 centimeters is 12 centimeters. So half times 12 centimeters times 2 centimeters. And when you simplify this, you have 12 centimeters squared. So the area of this trapezium is 12 centimeters squared. So the most important thing to note when you are finding the area of a trapezium is that you first need to identify the parallel sides, then the height. The area of the trapezium is half times the sum of the two parallel sides times half times the sum of the length of the two parallel sides times the height. We did that for this question, and we have the area of the trapezium as 12 centimeters squared. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to learn how to find the area and perimeter of another quadrilateral. The quadrilateral we are going to consider this time is a rhombus. So we will learn how to find the area and perimeter of a rhombus. Bye-bye. We are still on the topic mensuration. In the previous video, we learned how to find the area and perimeter of a trapezium. In this video, we are going to learn how to find the area and perimeter of a rhombus. A rhombus is a parallelogram with equal sides. So the diagram we have here, A, B, C, D, is an example of a rhombus. It looks like a parallelogram. The only difference is that it has equal sides. That means that the length DC is equal to the length AB. So represented by this bar here and this bar here. In the same way, the length AD is equal to the length BC. So AB is equal to DC and is equal to AD and is equal to BC. So just as it were for squares, we learned in squares that all the sides are equal. For rhombus also, all the sides are equal. So for a rhombus, it's a parallelogram with equal sides. If I call the distance AB, if I call that L, that means that this side here is also L, because DC is the same as AB, and AD is also L, so BC is L. So each of the sides is L. It means that the perimeter of this rhombus here will be L plus L plus L plus L, which is 4L. So the perimeter of a rhombus is 4L. We also learned that the perimeter of a square is 4L because all the sides are equal. Rhombus has all its sides being equal, so the perimeter of a rhombus is 4L, where L is the length of the side of the rhombus. Okay, let's say that for this particular rhombus, H here represents the height. The height is the perpendicular distance from DC to meet AB. So the perpendicular line drawn from DC to meet AB is the height. So whenever you talk about the height, you are referring to the perpendicular height. So this distance here represented by H, that is the height of the rhombus. We want to find the area of a rhombus. If you have the length of the side and the height, the area of a rhombus is L times H. That is the length times the height. That is the area of the rhombus if you have the length and the height. So the perimeter is 4 times the length, and the area is the length times the height. There are two formulas for finding the area of a rhombus. One of them is length times height. You use it when you are given the length and height of the rhombus. The other one is using the diagonals. If you draw a line from A to C, it's called a diagonal of the rhombus. If you draw another line from B to C, it's also called the diagonal of a rhombus. So you see that a rhombus has two diagonals. In this diagram here, one of them is AC and the other is BD. If you are being given the length of these diagonals, then the area of this rhombus is half times the product of the diagonals. That is half times the length of AC times the length of BD. So if you have the length and height, the area of a rhombus is length times height. If you have the length of the two diagonals, the area of the rhombus is half times the product of the diagonals. So in this case, half times the length AC, which is one diagonal, times the length BD, which is another diagonal. One very important thing you need to note about the diagonals of a rhombus is that the diagonals bisect each other at right angles. So for this particular rhombus here, the diagonal AC will divide the diagonal BD into two equal parts. So because the diagonal AC meets the diagonal AD, for this particular rhombus is going to divide it into two equal parts. In the same way, the diagonal BD will divide the diagonal AC into two equal parts. That is what we mean by it bisect it. It also says that they bisect each other at right angles, which means that the angle formed at where they meet is 90 degrees. So the angle formed here is a right angle or a 90 degrees angle. So that means that their point of intersection here is a right angle. The angle formed there is a right angle. The point also says that, and also bisect the opposite angles. What this means is that the diagonal AC, the angle that is formed at point C here, this diagonal AC will bisect it. It means that the diagonal AC will divide the angle here into two equal parts, and to divide the angle here into two equal parts. In the same way, the diagonal BD will divide the angle at D into two equal parts and the angle at B into two equal parts. These are very important properties of a rhombus that you need to know and understand. Let's use what we've learned so far to solve a question. The length and height of a rhombus are 4 centimeters and 3 centimeters respectively. Find the perimeter of the rhombus and area of the rhombus. So we have the length and height of the rhombus as 4 centimeters and 3 centimeters respectively. It means that the length is 4 centimeters and the height is 3 centimeters. And we are supposed to find the perimeter and area. So we have the length as 4 centimeters and the height as 3 centimeters. The perimeter of a rhombus is 4 times the length. The length is 4 centimeters. So the perimeter is 4 times 4 centimeters, which is 16 centimeters. We have been given the length and the height. So to find the area of the rhombus, we are going to use the formula area is equal to length times height. If you have the length and height, this is the formula you are going to use. So the area is equal to the length times the height. The length is 4 centimeters and the height is 3 centimeters. So you have 4 centimeters times 3 centimeters, and that will give us 12 centimeters squared. So the perimeter of the rhombus is 16 centimeters and the area of the rhombus is 12 centimeters squared. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the area and perimeter of a rhombus. Bye-bye. We are on the topic mensuration. In the previous video, we learned how to find the area and perimeter of a rhombus and we solved a question. In this video, we are going to solve another question on finding the area and perimeter of a rhombus. Let's consider the question. The diagonals of a rhombus are 10 centimeters and 16 centimeters long. Find 1. The area of the rhombus and 2. Perimeter of the rhombus. So in this question, we have been given the diagonals of the rhombus and we are supposed to find the area and perimeter. Let's concentrate on the area for now. So it means that if we draw this rhombus A, B, C, D, we have the diagonal AC and the diagonal BD. You can see from this diagram that AC will be longer than BD. So the diagonal AC is 16 centimeters and the diagonal BD is 10 centimeters. Okay, so we have AC as 16 centimeters and BD as 10 centimeters. We learned in the previous video that the diagonals bisect each other at right angles. So if I call their point of intersection, the point of intersection of the diagonals, if I call it point E, it means that the angle created at point E here is 90 degrees or a right angle. As we said, the diagonals bisect each other. It means that the diagonal AC will divide BD into 2 equal parts. BD is 10 centimeters. So if AC divides into 2 parts, then it means that from D to E is 5 centimeters and from E to B is 5 centimeters. The same way, the diagonal BD will also divide the diagonal AC into 2 equal parts. AC is 16 centimeters. So if it's divided into 2 equal parts, then it means that from A to E is 8 centimeters and from E to C is also 8 centimeters. Okay, the question says that we should find the area of the rhombus. Given the diagonals, the area is equal to half times the product of the diagonals. The diagonals are 16 centimeters and 10 centimeters long. So it's equal to half times 16 centimeters times 10 centimeters. And if you simplify this, you are going to have 80 centimeters. So the area of this rhombus is 80 centimeters squared. So we have two formulas for finding the area: length times height and half times product of the diagonals. So if you are being given the length and height, you use length times height. If you are being given the diagonals, you use half times product of the diagonals. Here we had the diagonal AC and the diagonal BD. So it's going to be half times AC, which is 16 centimeters, times BD, which is 10 centimeters. And this will give us 80 centimeters squared. So the area of this rhombus is 80 centimeters squared. The second part of the question says that we should find the perimeter of the rhombus. The perimeter of the rhombus. To find the perimeter of the rhombus, we know that the formula is 4L, or 4 times the length of the rhombus. It means that we have to find the length of the rhombus. That is what we are going to look for now. We have DE as 5 centimeters and EC as 8 centimeters. There is a right angle here. Remember that DC is the side or the length of the rhombus. For rhombus, all the sides are equal. So if you're able to find one side, it means that it will be the same for all the sides. If you're able to find the length of one side, it will be the same for all the other sides. Okay, so if you consider the points D, E, C, you will see that it forms a right-angled triangle with DE as 5 centimeters and EC as 8 centimeters. Remember, we are looking for the side DC, since that will be the length of the side of the rhombus. So we can apply the Pythagoras theorem here. If you apply the Pythagoras theorem here, you have DC squared is equal to DE squared plus EC squared. DE is 5 centimeters, so 5 squared, plus EC is 8 centimeters, 8 squared. So DC squared is equal to 5 squared plus 8 squared. If you simplify this, DC, which is the length of the side of the rhombus, will give us 9.4 centimeters. So here, the length of the side DC is 9.4 centimeters. But for rhombus, all the sides are equal. So if DC is 9.4 centimeters, then it means that AD is also 9.4 centimeters, AB is also 9.4 centimeters, and BC is also 9.4 centimeters. Okay, so we now know that the length of the side of the diagonal is 9.4 centimeters. We can find our perimeter. Perimeter is equal to 4 times the length. We found the length to be 9.4 centimeters. So it's going to be 4 times 9.4 centimeters, which will give us 37.6 centimeters. So the perimeter of the rhombus is 37.6 centimeters. Thank you for watching this video. I hope this video was helpful. Don't forget to like and subscribe to this channel for more videos. In the next video, we are going to consider how to find the area and perimeter of another quadrilateral. This time, the quadrilateral we'll be considering is a kite. So we will learn how to find the area and perimeter of a kite. Bye-bye. We are on the topic mensuration. In the previous video, we learned how to find the area and perimeter of a rhombus. In this video, we are going to learn how to find the area and perimeter of a kite. A kite is a four-sided plane figure, so it's another example of a quadrilateral. So the figure we have here, A, B, C, D, is an example of a kite. Two pairs of adjacent sides are equal, and the diagonals bisect each other at 90 degrees. So for this kite, the side BC and the side DC are adjacent to each other and they are equal. So the length BC is equal to the length DC. The same way, the length AD and the length AB are also equal. So BC is equal to DC and AD is equal to AB. The diagonals also bisect each other at 90 degrees. So the diagonal BD will bisect the diagonal AC at 90 degrees. What that means is that this diagonal here, which is AC, will divide BD into two equal parts. So the diagonal BD will be divided into two equal parts by the diagonal AC, and they meet at 90 degrees. So the angle here is 90 degrees. Okay. Now, how do we find the area and perimeter of a kite? The perimeter, as we've been learning, is the total distance around a figure. So here is going to be the length AB plus the length BC plus the length CD plus the length DA. The area is equal to half times the product of the diagonals. So here is going to be half times the length AC times the length BD. Let's use this to solve some questions. Find the area and perimeter of the kite below. So we have been given this kite. We have SR to be 7 centimeters, PT to be 3 centimeters, ST to be 2 centimeters. Okay, considering this kite, we have just learned that the diagonals meet at 90 degrees. So it means that the angle here is going to be 90 degrees. We also learned that this diagonal PR will divide the diagonal SQ into two equal parts. So if from S to T is 2 centimeters, then it means that from T to Q is also 2 centimeters. So now we have the length of this diagonal, which is SQ, because it's going to be 2 centimeters plus 2 centimeters. Remember that the area of a kite is half times the product of the diagonals. So we have one diagonal, we have to look for the other one. The other diagonal is PR. We have PT as 3 centimeters. So it means that we need the length TR. If you consider the point STR, you will see clearly that it forms a right-angled triangle with ST as 2 centimeters, SR as the hypotenuse giving us 7 centimeters, and we are looking for TR. So we are going to apply the Pythagoras theorem here. If you apply the Pythagoras theorem, you will see that SR squared is equal to ST squared plus TR squared. So you have 7 squared is equal to 2 squared plus TR squared. You simplify everything and you find TR, you are going to get 6.7 centimeters. So it means that from T to R is 6.7 centimeters. So now we have the diagonal PR, we have the diagonal SQ, so we can find the area of this kite. Okay, so SQ and PR are the diagonals. SQ is equal to 2 centimeters plus 2 centimeters, as you can see here, and that will give us 4 centimeters. PR will give us 3 centimeters plus 6.7 centimeters, and that will give us 9.7 centimeters. So we have these two diagonals. The area of a kite is equal to half times the product of the diagonals. So it's equal to half times 4 centimeters times 9.7 centimeters, and this will give us 19.4 centimeters squared. So this is the area of this kite. Let's move on to the perimeter of the kite. So the area of the kite is 19.4 centimeters squared. The perimeter of the kite. We know that the perimeter is the total distance around the figure. We have SR as 7 centimeters. We learned that for kites, for this particular kite here, the length SR will be equal to the length QR. So if SR is 7 centimeters, then QR is also 7 centimeters. In the same way, the length PS is equal to the length PQ, since we learned that for kites, adjacent sides are equal. So PS is equal to PQ. So it means that if you're able to find PS is the same as PQ. If you consider the point PTS, you see that it also forms another right-angled triangle with PT as 3 centimeters, and TS as 2 centimeters. So if we apply the Pythagoras theorem here, we can find PS. If we are applying the Pythagoras theorem, we will have PS squared is equal to PT squared plus TS squared. So PS squared is equal to 3 squared plus 2 squared. You will simplify this and PS is equal to 3.6 centimeters. What that means is that from P to S is 3.6 centimeters. But since PQ is equal to PS, PQ is also 3.6 centimeters. So if you consider the kite now, we have SR, we have RQ, we have PQ, and we have PS. So we can find the perimeter. The perimeter of this kite here is going to be the length of PS plus the length of SR plus the length of RQ plus the length of QP or PQ. That will give us 3.6 centimeters plus 7 centimeters plus 7 centimeters plus 3.6 centimeters. You add everything and we are going to get 21.2 centimeters. So the perimeter of this kite here is 21.2 centimeters. Thank you for watching this video. Don't forget to subscribe to this channel for more videos. So far, we've considered how to find the area and perimeter of 6 quadrilaterals. We've learned how to find the area and perimeter of a rectangle, a square, a rhombus, a parallelogram, a trapezium, and a kite. In the next video, we are going to learn how to find the area and perimeter or circumference of a circle. So we are going to concentrate on a circle in our next video. Bye-bye. We are on the topic mensuration. We have considered triangles and quadrilaterals in the previous videos. In this video and the subsequent ones, we are going to consider circles. To begin our studies on circles, we are going to learn about the parts of a circle. So the first part of a circle we are going to consider is the circumference. The circumference is the circular part of the circle. So in other words, the circumference is the distance around the circle. In the previous videos, we learned that the perimeter of a triangle or the perimeter of a quadrilateral is the total distance around the triangle or the quadrilateral. For a circle, the perimeter of a circle is called its circumference. So whenever we say the word circumference, we are referring to the distance around the circle or the perimeter of the circle. The circumference of a circle is the circular part of the circle or the total distance around the circle. An arc. An arc is a part of the circumference. So let's say that we have this circle here and we have this point here, point A. So I'm going to indicate here point A, and we have this point here, point B. Now you see that A and B is just a part of the circle. So if we cut this point A here and we cut this point here, B here, we are going to have this part AB. This is the smaller part. And we have this bigger part here, AB. So this smaller part here, AB, is called an arc. And this bigger part here, AB, is also called an arc. So any part of the circumference, or if you take a part of the circumference, is called an arc. Because this arc is bigger, it's called a major arc. And because this arc is smaller, it's called a minor arc. So an arc is a part of the circumference. The next part of a circle we are going to consider is the radius. A radius is a line drawn from the center of the circle to any point on the circumference. Okay, so let's say that we have the circle here and O is the center of the circle. If we draw a line from O to point A, which is on the circumference, this line is called the radius of the circle. So a line drawn from the center of the circle to a point on the circumference is called the radius. In the same way, if you draw a line from the center O to a point B on the circumference, is called the radius. So any line drawn from the center of the circle to a point on the circumference is called the radius of the circle. Another thing we are going to consider about a circle is a chord. A chord is a straight line joining 2 points on the circumference. So let's say we have this circle here and we have points P and point Q on the circumference. If we draw a line to join point P and point Q, that line is called a chord. So a chord is a straight line joining 2 points on the circumference. If you have point P and point Q on the circumference and we draw a line to join point P and point Q, that line is called a chord. The next part of the circle we are going to consider is the diameter. The diameter is the chord passing through the center of the circle. The diameter is the chord passing through the center of the circle. Okay, so let's say that we have this circle here and O is the center. We have point C on the circumference and point D on the circumference. If we draw a chord from point C to point D and that chord passes through the center, the name of that line is the diameter. Now you can see that the diameter will be 2 times the radius, because the radius is a line drawn from the center to the circumference. So if you draw a line from one point of the circumference to another point on the circumference, that line passes through the center, it is called the diameter. And the diameter is 2 times the radius. The next part of a circle we are going to consider is a segment. A segment is an area of a circle bounded by a chord and an arc. An area of a circle bounded by a chord and an arc. So we have this circle here. We have point M and point N on the circumference, and there is a chord joining point M to point N. Okay. The area of the circle bounded by an arc and a chord is called a segment. So let's say that we take this lower part here. So we have the chord MN and we have the arc MN. Now if you look at this figure here, it's bounded by an arc. This arc here MN and this chord MN. This is called a segment. This is the lower part. If you take the upper part too, you can also see that it's bounded by this major arc MN and the chord MN. So this one is also another segment. So if you draw a chord, you can see that it divides the circle into 2 segments. You have this bigger segment, that is the area of a circle bounded by an arc and a chord, and we have this minor or this smaller segment. Because this segment is smaller, it's called the minor segment, and because this segment is bigger, it's called the major segment. These are very, very important things that you need to understand, because you are going to learn how to find the area and perimeter of a segment. So you need to understand what a segment is. The last part you'll be considering is a sector. A sector is an area of a circle bounded by 2 radii and an arc. One is called a radius, 2 is radii. So if you have a circle like this with O as the center and OP as a radius and OQ also as a radius, the area of the circle bounded by 2 radii, in this case OP and OQ, and the arc PQ is called a sector. This is what we mean. If we take this portion out, you can see that this figure here is bounded by the radius OP and OQ and the arc PQ. So this is a sector. In the same way, if you take this bigger part here, it's bounded by the arc PQ. So this arc and the radius OP and OQ. So this is also another sector. Because this sector is small, we will call it the minor sector, and we will call this sector here to the major sector. So the area of an arc bounded by 2 radii, the area of a circle bounded by two radii and an arc is called a sector. Thank you for watching this video. I hope the video was helpful. Don't forget to like and subscribe to this channel for more videos. We've learned more about circles in this video. In the next video, we are going to learn how to find the area and circumference of a circle. Bye-bye. We are on the topic mensuration. In the previous video, we learned about the parts of a circle. In this video, we are going to learn how to find the area and circumference of a circle. So, circumference and area of a circle. The formula for finding the circumference of a circle is 2 pi r, where r is the radius of the circle. This is when you are being given the radius of the circle. If you have the diameter of the circle, then the formula is pi d, because 2r is the diameter. So 2 pi r is the same as pi d. So if you have the radius of the circle, then the formula is 2 pi r. But when you are given the diameter of the circle, then the formula for finding the circumference of a circle is pi d. This is for the circumference. The formula for finding the area of a circle is pi r squared. This is when you have the radius of the circle. But if you have the diameter of the circle, then the formula is pi d squared divided by 4. So if you have the radius, the formula is pi r squared. For the diameter, the formula is pi d squared divided by 4. So these are the formulas for finding the area and circumference of a circle. Let's use this to solve some questions. The question is, find the area and circumference of a circle with radius 10 centimeters. So here the radius has been given to us. Okay, the radius of the circle, which is usually represented by r, is equal to 10 centimeters. We are supposed to find the area and circumference. The formula for finding the area of a circle when you have the radius is pi r squared. Okay, and the question told us that r is 10 centimeters. So this is going to give us pi times 10 centimeters squared. So you will have to find this on a calculator. Here, pi was not given to us as 22/7, so you are going to use pi just as you have it here, and you are going to do that on your calculator. So this is how to do it. To find pi, press on shift, then you press on, you see, if you at the bottom of the calculator, you have this button with times 10 to the power x on it. If you look on top of that, you see the sign pi. So if you press shift, then you press that button. That button is what you have to the left of the A and S button. Okay, so if you press on that button, you are going to have pi. So I'm going to do it again. You press on shift, then you press on the times 10 to the power x button. When you do that, you are going to have pi. So we have pi here, then times, you have 10 centimeters squared, so 10 squared. And that is going to give us, the calculator is giving us 100 pi. We want our answer in decimals. So you press on the S to D button and it will change it to decimal for you. So you have 314.15. We are not told the number of decimal places, so I'm just going to leave it in one decimal place, and that will give us 314.2 centimeters squared, since the area is centimeters squared. So the area of the circle is 314.2 centimeters squared. Let's go on and do for the circumference. We know that the circumference of a circle is 2 pi r. So this will give us 2 times pi times 10 centimeters. Now to find this, so you show on your calculator, we have 2 times 2. find pi, you press shift, then you press the times 10 to the power x button. We have pi there, then times 10, and that is going to give us 20 pi. We have it in terms of pi. We want our answer in terms of decimal, so you press on the S to D button and to change it to decimal for you. So we have 62.8318. We are not told the number of decimal places, so I'll just leave my answer in one decimal place, which is 62.8 centimeters. So the area is 314.2 centimeters squared, and the circumference is 62.8 centimeters. Thank you for watching this video. Don't forget to like and subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the area and circumference of a circle. Bye-bye. We are on the topic mensuration. In the previous video, we solved a question on finding the area and circumference of a circle. In this video, we are going to solve another question. So let's consider the question for this video. The area of a circle is 210 centimeters squared. Find its radius and circumference. So for this question, the area has been given to us and we need to find the radius, then we use the radius to find the circumference. Okay, we know that the formula for finding the area of a circle when we have the radius is pi r squared. So the area of a circle is pi r squared. The question told us that the area of this circle is 210 centimeters squared. So we can say that 210 centimeters squared is equal to pi r squared, where r is the radius of the circle. So if you're able to find r, we will have the radius of this circle with an area of 216 centimeters squared. So with an area of 210 centimeters squared. So the area of the circle is 210 centimeters squared, and this is equal to pi r squared. We want to find the radius, which is r. So what we do is that we divide both sides by pi, which is a constant. So you divide the left hand side by pi and you divide the right hand side by pi. When you do that, you have pi here cancelling pi, so that we have r squared. Then the left hand side will be 210 centimeters squared divided by pi. So to find that, you switch on your calculator. Since it's division, you click on the division button. You have 210 as the numerator, then the denominator is pi. So you press shift, then you click on the times 10 to the power x button. Click on that. So we have 210 divided by pi. Press equal to, and we have 66.845. The number goes on and on. Remember, the question did not tell us the number of decimal places to leave our answer, so I'll leave mine in one decimal place. So we have r squared is equal to 210 divided by pi. 210 centimeters squared divided by pi will give us 66.8 centimeters squared. So r squared is equal to 66.8 centimeters squared. We want to find the radius, which is r. To do that, we take square root of the left hand side and we take square root of the right hand side. Immediately we take the square root, you see that from indices we learned that the square will cancel the square root sign. So here is going to be r. Then r is equal to the square root of 66.8 centimeters squared. And when you do that, r will give us 8.2 centimeters. So the radius of this circle is 8.2 centimeters. Okay. The question also said that we should find the circumference of the circle. We know that the radius is 8.2 centimeters. The formula for finding the circumference of a circle when you have the radius is 2 pi r. So this is going to give us 2 times pi times 8.2. And To do that, we have 2 times shift pi times 8.2, and that is going to give us 51.522 centimeters. And this will give us 51.5 centimeters, since I'm leaving my answer in 1 decimal place. So the circumference of the circle is 51.5 centimeters. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to learn how to find the length of an arc. Bye bye. We are on the topic mensuration. In the previous video, we solved a question on finding the area and circumference of a circle. In this video, we are going to learn how to find the length of an arc. In the video on parts of circles, we learned that an arc is a part of the circumference. So for example, in this circle here, where O is the center, we know that OA is a radius and OB is also a radius. Now you can see that this angle theta is being formed between these two radii. AB is an arc. We have this minor arc AB and a major arc AB. The length of this minor arc AB is given by theta, which is the angle between the two radii, divided by 360 degrees times 2 pi r. The length of the major arc AB is given by 360 degrees minus theta divided by 360 degrees times 2 pi r. So for the minor arc, the formula is theta, and theta is the angle between the two radii, divided by 360 degrees times 2 pi r. For the major arc AB, the formula is 360 degrees minus theta divided by 360 degrees times 2 pi r. Let's use these to solve some questions. Find the length of the minor and major arc PQ in the diagram below. So we have this diagram with the arc PQ, and we are supposed to find the length of the minor arc PQ and the major arc PQ. So for this question too, this point here is O, where O is the center of the circle. Okay, and we are supposed to find the length of the minor arc PQ and the major arc PQ. We learned that the length of the minor arc PQ is equal to theta, which is the angle formed between the two radii, divided by 360 degrees times 2 pi r. So we have theta divided by 360 degrees times 2 pi r, where r is the radius of the circle, and we have that as 28 centimeters, and theta is the angle between the two radii, which is 110 degrees. So this is going to give us 110 degrees divided by 360 degrees times 2 times pi times 28 centimeters. When you do this on your calculator, you are going to have 53.8 centimeters. So the length of the minor arc is 53.8 centimeters. For the major arc, we learned that the length of the major arc PQ is equal to 360 degrees minus theta divided by 360 degrees times 2 pi r. But we know that theta is 110 degrees. So this is going to give us 360 degrees minus 110 degrees divided by 360 degrees times 2 times pi times 28 centimeters, since r is 28 centimeters. When you do this on your calculator, you are going to have 122.2 centimeters. So the length of the major arc PQ is 122.2 centimeters. Thank you for watching this video. I hope this video was helpful. Subscribe to this channel for more videos. In the next video, we are going to learn how to find the area and perimeter of a sector. Bye bye. We are on the topic mensuration. In the previous video, we learned how to find the length of an arc. In this video, we are going to learn how to find the area and perimeter of a sector. In the video on parts of circles, we learned that a sector of a circle is the area of a circle bounded by two radii and an arc. So, in this diagram here, OAB is a sector, and since it's the smallest sector, it's called the minor sector. So the shaded portion here is a sector, then the unshaded portion is also another sector. The shaded portion is the minor sector, and the unshaded portion is the major sector. From the diagram, the angle between the radius OA and the radius OB is theta. So the angle between the two radii is theta, and the radius is r. We are going to learn how to find the area of this minor sector and the perimeter of the minor sector. We will also learn how to find the area of the major sector and the perimeter of the major sector. There are going to be a lot of formulas here. The area of the minor sector, that is the shaded portion. To find the area, it is theta divided by 360 times pi r squared. The perimeter of this shaded portion or the minor sector is 2r, where r is the radius of the circle, plus theta divided by 360 times 2 pi r. Now you can see that theta divided by 360 times 2 pi r is the length of a circle. Sorry, is the length of an arc. So the length of this minor arc AB is theta divided by 360 times 2 pi r. If you add that to the two radii, OA and OB, you get the perimeter of this minor sector. Okay, let's move on to the major sector, that is the unshaded portion. The area of this major sector is going to be 360 degrees minus theta divided by 360 degrees times pi r squared. And the perimeter of this major sector is 2r, which is OA plus OB, then plus the length of this major arc, which is 360 degrees minus theta divided by 360 degrees times 2 pi r. So these are the formulas for finding the area and perimeter of the major sector and the minor sector. Let's solve a question with these formulas. The diagram below shows a circle with center O and a radius of 7 centimeters. The shaded region POQ is a sector with angle 60 degrees. Find the I, length of the minor arc PQ, perimeter of the minor sector, area of the minor sector, length of the major arc PQ, perimeter of the major sector, and area of the major sector. We will solve the first two questions in this video, then we solve the others in the subsequent videos. So the first part is the length of the minor arc PQ. We know that formula for finding the length of the minor arc is theta divided by 360 degrees times 2 pi r, where r is the radius and theta is the angle between the two radii. Theta is 60 degrees and the radius is 7 centimeters. So you are going to have 60 degrees divided by 360 degrees times 2 times pi times 7 centimeters, and this will give us 7.3 centimeters. So it means that the length of this arc PQ is 7.3 centimeters. The second part of the question says that we should find the perimeter of this minor sector. We learned that to find the perimeter, it is the length OP, which is the radius, plus OK, which is another radius. So 2 times the radius, then plus the length of the minor arc PQ, which is theta divided by 360 degrees times 2 pi r. So this is going to be 2 times 7 centimeters is the radius. So 2 times 7 centimeters plus, we just found this to be 7.3 centimeters. 60 degrees divided by 360 degrees times 2 times pi times 7 centimeters. That was what we did previously, and we got 7.3 centimeters. So here you are going to have 2 times 7 centimeters, which will give you 14 centimeters, then plus everything here. And when you do that, you are going to have 21.3 centimeters. So to find the length, the perimeter of this minor sector here, all you need to do is to find the length of the arc PQ, then you add it to 2 times the radius. And when we did that here, we had 21.3 centimeters. In the next video, we are going to solve the second, the third, and fourth part of this question. See you in the next video. Welcome back. In the previous video, we started solving this question, and we solved the first and second part of the question, which is the length of the minor arc PQ and the perimeter of the minor sector. In this video, we are going to solve the third and fourth part, which is the area of the minor sector and the length of the major arc PQ. So we have the radius of the circle as 7 centimeters and the theta as 360 degrees. The area of the minor sector is equal to theta divided by 360 degrees times pi r squared. So this is going to give us theta is 60 degrees, so we have 60 degrees divided by 360 degrees times pi times the radius, which is 7 centimeters, so 7 centimeters squared. When you do this on your calculator, you are going to have 25.7 centimeters squared. So the area of the circle, the area of the minor sector, which is the shaded portion, is 25.7 centimeters squared. Okay, the question also says that we should find the length of the major arc PQ. The length of the major arc PQ. And we learned that to find the length of this major arc PQ is going to be 360 degrees minus theta divided by 360 degrees times 2 pi r, where theta is 60 degrees and r is the radius of the circle. So we are going to have 360 degrees minus 60 degrees divided by 360 degrees times 2 times pi times 7 centimeters. And when you find this on your calculator, that will give you 36.7 centimeters. So the length of the major arc PQ, we found the length of the minor arc. This is for the major arc, that is the unshaded portion. So the length of the major arc PQ is 36.7 centimeters. In the next video, we are going to solve the fifth and sixth parts of this question. So see you in the next video, and let's continue solving this question. Welcome back. We have solved the first, second, third, and fourth part of this question. In this video, we are going to solve the fifth and sixth part, which are the final parts of this question. That is finding the perimeter of the major sector and the area of the major sector. We have the radius as 7 centimeters and theta, which is the angle between the two radii, at 60 degrees. Perimeter of the major sector, we learned that is equal to 2r, which is the radius, plus 360 degrees minus theta divided by 360 degrees times 2 pi r, where r is the radius and theta is the angle between the two radii, that is 60 degrees. So this is going to give us 2 times 7 centimeters plus 360 degrees minus 60 degrees divided by 360 degrees times 2 times pi times 7 centimeters. And if you do this on your calculator, you are going to have 50.7 centimeters. So the perimeter of the major sector, which is the unshaded portion, is 50.7 centimeters. Okay, the last part is area of the major sector. Area of the major sector. The formula is 360 degrees minus theta divided by 360 degrees times pi r squared. We have 360 degrees minus theta is 60 degrees, so 60 degrees divided by 360 degrees times pi times 7 centimeters squared. And when you do this on a calculator, you have 128.3 centimeters squared. So the area of the minor sector is 128.3 centimeters squared. Thank you for watching this video. Subscribe to this channel for more videos. You can subscribe by clicking on the subscribe button that you see. In the next video, we are going to learn how to find the area and perimeter of a segment. Bye-bye. We are still on the topic mensuration. In the previous video, we learned how to find the area and perimeter of a major and minor sector. In this video, we are going to learn how to find the area and perimeter of a major and minor segment. In the video on parts of circles, we learned that a segment is an area of a circle bounded by an arc and a chord. So, in this diagram here, we can see that the shaded portion is bounded by the arc AB and the chord AB. So this is a segment. In the same way, the unshaded portion is also bounded by the major arc AB and the chord AB. So the unshaded portion is also another segment. The shaded portion is called the minor segment and the unshaded portion is called the major segment. If we draw a line from A to O, which is the center of the circle. So here O is the center of the circle. So if we draw a line from A to O and from B to O, we know that AO and BO will all be the radius of the circle. Okay, the angle between the two radii is theta. When you have this, then we say that the perimeter of the minor segment, that is the shaded portion, is theta divided by 360 times 2 pi r plus the length of the chord. So in effect, it is the length of the arc AB plus the length of the chord AB. That will give us the perimeter of this minor segment. The area of the minor segment, the area of this minor segment is theta divided by 360 degrees times pi r squared minus half r squared sine theta, where theta is the angle between the two radii as we have here. So this is the formula for finding the area of this minor segment or the shaded portion. When we come to the major segment or the unshaded portion, the perimeter of this major segment is 360 degrees minus theta divided by 360 degrees times 2 pi r plus the length of the chord. So in effect, it is the length of this major arc plus the length of the chord AB. Then the area of this major segment is 360 degrees minus theta divided by 360 degrees times pi r squared plus half r squared sine theta, where theta is the angle between the two radii. Let's use these formulas to solve some questions. In the diagram below, O is the center of the circle of radius 14 centimeters. Find correct to two decimal places. I, the length of the length of the minor arc XY, the length of the chord XY, perimeter of the minor segment, area of the minor segment, perimeter of the major segment, and area of the major segment. We will solve the first part in this video and we will solve the others in the subsequent videos. So the question says we should find the length of the minor arc XY. We have the radius as 14 centimeters and theta as 70 degrees. The formula is theta divided by 360 degrees times 2 pi r. So this is going to give us 70 degrees divided by 360 degrees times 2 times pi times 14 centimeters. When you do this on your calculator, you are going to have 17.10 centimeters. Remember, the question said we should leave our answer in 2 decimal places. So you do exactly that. So we can say that the length of the minor arc is 17.10 centimeters. We are going to solve the remaining part of the question in the previous video. So see in the previous. We are going to solve the remaining part of the question in the next video. So see in the next video where we will continue solving this question. Bye bye. Welcome back. In the previous video, we started solving this question and we solved the first part of the question, which is the length of the minor arc XY. In this video, we are going to concentrate on the second part of the question, which is the length of the chord XY. So we are supposed to find the length of this chord XY. The radius is 14 centimeters. So if we draw the circle again here with O as center, we know that OX is a radius and OY is also a radius. So OX is 14 centimeters and OY is 14 centimeters. Now if you look at this triangle formed here very carefully, triangle OXY, you will see that it is an isosceles triangle. We learned that for isosceles triangles, two sides are equal. So since OX is equal to OY, then triangle XOY is an isosceles triangle. And if it's an isosceles triangle, it means that if we draw a line from O to meet XY here, this line here will become the height of the triangle. And this line also is a perpendicular bisector. What that means is that it's going to divide the angle here. It's going to divide this angle here into 2 equal parts. And also, it's going to divide the line XY into 2 equal parts since it is a perpendicular bisector. So it means that if we call this point here point X, this point where the line from O meets XY, if you call it point X, we can say that since OX is a perpendicular bisector, it's going to divide the angle here, which is 70 degrees. It's going to divide it into 2 equal parts. So this part is 35 degrees and this part is also 35 degrees. So we now have OZX and OZY as 2 right-angled triangles. Okay, so I'm going to call this point here point Z, just as we saw. Now, if I call the distance from X to Y, if I call it X, so the distance XY, I'm calling it X. That is, moving from X to Y, I'm going to call that distance X. We learned that since OZ is a perpendicular bisector, what it means is that it's going to divide OY into 2 equal parts. So if from X, it means that it's going to divide XY into 2 equal parts. Sorry. OZ is going to divide XY into 2 equal parts. So if from X to Y is X, then it means that from X to Z is half of X, which is 0.5x or 1/2x. Then from Z to Y is also half of X, which is 0.5x. Because OZ will divide XY into 2 equal parts. I hope that is clear. So from X to Z will be the same as from Z to Y. And from X to Z is 0.5x. So from Z to Y is also 0.5x. Now, if you take the point OZX, you will see that it's forming a right-angled triangle. where xz is 0.5x, xo is 14 centimeters, and the angle formed at O is 35 degrees. We want to find x. 0.5x is opposite to 35 degrees, and 14 is and 14 is the hypotenuse. So we have opposite and we have the hypotenuse. We know that from the triangle XOZ, we can say that sine 35 degrees is equal to opposite, which is 0.5x, divided by hypotenuse, which is 14 centimeters. Okay, so to find x, I'll multiply the left hand side by 14 and multiply the right hand side by 14. So 14 will cancel 14. This will give us 0.5x is equal to 14 sine 35. I will divide both sides by 0.5. So you have x to be equal to 14 sine 35 degrees divided by 0.5. And when you find this on your calculator, you have 16.06 centimeters. What it means is that from x to y, which is the length of the chord, is 16.06 centimeters. Remember, the question said we should leave our answer in 2 decimal places. So we can say that the length of the chord is 16.06 centimeters. In the next video, we are going to solve the third and fourth part of this question. See you in the next video. Welcome back. We have solved the first and second parts of this question in the previous videos. In this video, we are going to solve the third and fourth part. So let's concentrate on the third part. It says that we should find the perimeter of the minor segment. The formula is theta divided by 360 times 2 pi r plus the length of the chord xy. We know that the radius is 14 centimeters and theta is 70 degrees. And we found the length of the chord in the previous video as 16.06 centimeters. So the perimeter of the minor segment is equal to 70 degrees divided by 360 degrees times 2 times pi times 14 centimeters plus the length of the chord xy, which we have found to be 16.06 centimeters. When you simplify this on your calculator, or you do this on your calculator, you are going to have 33.16 centimeters. So it means that the perimeter of the minor segment, or the shaded portion, is 33.16 centimeters. Remember, the question said we should leave our answer in 2 decimal places. The fourth part is the area of the minor segment. The formula is theta divided by 360 degrees times pi r squared minus half r squared sine theta. R is the radius and theta is 70 degrees. So this will give us 70 degrees divided by 360 degrees times pi times r, which is 14, so 14 squared, minus half times r squared, which is 14 squared, times sine 70 degrees. And when you do this on your calculator, you are going to get 27.64 centimeters squared. So the area of the minor segment, or the shaded portion, is 27.64 centimeters squared. In the next video, we are going to solve the fifth and sixth part of this question. So see you in the next video. Welcome back. We have solved the first, second, third, and fourth part of this question in the previous videos. In this video, we are going to solve the fifth and final part of this video, which is the sixth part. So you concentrate on question 5 and question 6, which is finding the perimeter of the major segment and the area of the major segment. So the radius is 14 centimeters and the angle theta is 70 degrees. The perimeter of the major segment is equal to 360 degrees minus theta divided by 360 degrees times 2 pi r plus length of the chord xy. We found the length of the chord xy to be 16.06 centimeters. So this is going to give us 360 degrees minus 70 degrees divided by 360 degrees times 2 times pi times 14 centimeters plus length of the chord, which is 16.06 centimeters. When you do this on your calculator, you are going to have 86.92 centimeters. So the perimeter of the major segment is 86.92 centimeters. Let's look at the sixth part, or the final part. Area of the major segment, and that is giving us 360 degrees minus theta divided by 360 degrees times pi r squared plus half r squared sine theta. And this is going to give us 360 degrees minus 70 degrees divided by 360 degrees times pi times 14 squared plus half times 14 squared times sine 70. And when you find this on your calculator, you are going to have 588.11 centimeters squared. So area of the major segment is 588.11 centimeters squared. Thank you for watching this video. Subscribe to this channel for more videos. So far, we've learned how to find the area and perimeter of circles, of triangles, and quadrilaterals. For circles, we've also learned how to find the area and perimeter of sectors and segments, and we've learned how to find the area and circumference of a circle. Sometimes, a plane figure may contain more than one shape. Such figures are called composite figures or composite shapes. In the next video, we will learn how to find the area and perimeter of composite figures. Bye-bye. We are on the topic mensuration. In the previous video, we learned how to find the area and perimeter of a segment. In this video, we are going to learn how to find the area and perimeter of composite shapes. Composite shapes. Sometimes, a shape may consist of more than one plane figure. These are called composite shapes. We've learned about plane figures. Examples are quadrilaterals, circles, and triangles. We've learned how to find the area and perimeter of these plane figures. Sometimes, we may be given a shape that contains more than one of these plane figures. So, for example, we can have a triangle on a rectangle, or a triangle in a circle. These shapes are called composite shapes. To find the area of these shapes, you split them or you divide them into regular shapes like triangles, square, circle, etc. Then you find their areas separately. So to find the area of a composite shape, you split them into the regular shapes that we know, like triangles, squares, or circles. Then you find their areas separately. Let's pick an example and see how to do this. So we have this shape here, and we are going to find the area. To find the area of this shape, you can see that if we extend this line here to meet this line, we have divided it into two rectangles. So I'm going to call this rectangle A, then I'll call this rectangle B. If I find the area of rectangle A and I add it to the area of rectangle B, I'll find the area of this shape here. In the same way, you can also extend this line to meet this line here. When you do that, I can call this area I can call this figure here figure 1, then I'll call this figure 2. You can clearly see from the diagram that figure 1 is a rectangle and figure 2 is also a rectangle. So if I find the area of figure 1, which is a rectangle, and I add it to the area of figure 2, which is also a rectangle, I'll get the area of the shape. So you can use either one of these and you'll be able to solve the question. Let's go ahead. For now, or to help me solve this question, I'm going to extend this line from here to this side. Now look at something here. We can see from this diagram that the dimensions has been given to us. From this end to that end has been given to us as 8 centimeters. And from this end to this end has also been given to us as 4 centimeters. What that means is that this remaining side here is also 4 centimeters, since 4 centimeters plus 4 centimeters will give us 8 centimeters. Okay, I'm going to call this rectangle here A, then I'll also call this rectangle here B. So the area of this shape is the area of A plus the area of B. A is a rectangle with a length of 4 centimeters and a breadth of 10 centimeters. When we are learning about rectangles, we learned that area of a rectangle is equal to the length times the breadth. The length of this rectangle is 4 centimeters and the breadth is 10 centimeters. So the area of this rectangle is equal to 10 centimeters times 4 centimeters, which will give us 40 centimeters squared. So this is the area of the shape A. Let's go on to shape B. Shape B is also another rectangle with a length of 4 centimeters and a breadth of 2 centimeters. Once again, the area of a rectangle is length times breadth. So the area of shape B is 4 centimeters times 2 centimeters, and this will give us 8 centimeters squared. So we now have area of shape A and area of shape B. So to find the area of this shape, or to find the total area of this shape, is equal to the area of shape A plus the area of shape B. Area of A is 40 centimeters squared and area of B is 8 centimeters squared. So if you add them, you are going to have 48 centimeters squared. What it means is that the area of this shape here is 48 centimeters squared. So we have the area as 48 centimeters squared. So whenever you are being given a composite shape, all you need to do is to split them into regular shapes. Then you find the area of these regular shapes and you add them to get the area of the composite shape. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the area and perimeter of composite shapes. Bye-bye. We are on the topic mensuration. In the previous video, we solved a question on finding the area and perimeter of composite shapes. In this video, we are going to solve another question. So let's consider the question for this video. Find the area of the shape below, and this is the shape that has been given to us. We learned in the previous video that if you are being given a composite shape, what you have to do is to first divide the shape into regular shapes, then you find their areas separately. So with this shape here, we can see that if I connect the line from this side here, if I extend this line to this side, the length of that line will be 4 centimeters, because from the diagram, from this end to this end is 4 centimeters. Now, from the dimensions that we have on the diagram here, from this end to this end is 6 centimeters. So you have 6 centimeters here. We know that from the bottom part to the top part here is 13 centimeters as we have here. And from this end here, which is the bottom part, to this point is 8 centimeters. So we have 8 centimeters here. Now, if here from here to here is 13 centimeters, and from this side here to this side is 8 centimeters, then we can say that from this side here to the top part will be 13 centimeters minus 8 centimeters, which is 5 centimeters. Now, if I draw a line from this point to this point, you can see that it will divide this composite shape into two different regular shapes. We have this one here as a triangle, then we have this shape here as a rectangle. So we can find their areas separately, then we add them. Okay, so I'm going to call the triangle shape A, then I'll call the rectangle shape B. So to find the area of this composite shape is going to be the area of A plus the area of B. If you look at the shape A very carefully, you can see that it is a triangle with a base of 10 centimeters and a height of 5 centimeters. We learned that the area of a triangle is equal to half times the base times the height. So the area of this triangle is going to be equal to half times base, which is 10 centimeters, times height, which is 5 centimeters. And that will give us 25 centimeters squared. So we have found the area of the triangle, which is area of A. Let's move on to B. If you consider the shape B is of this form, it's a rectangle with a length of 10 centimeters and a breadth of 8 centimeters. But within this rectangle, we have another rectangle, which is an opening here. It's an empty space. And that empty space is also in a form of another rectangle with a length of 4 centimeters and a breadth of 6 centimeters. What this means is that to find the area of this shape here, which is shape B, we need to find the area of the whole rectangle. Then we find the area of this open space here, which is also another rectangle, and we subtract the open space from the area of the bigger rectangle. Now, this is what we mean. We have this rectangle here with a length of 10 centimeters and a base of 8 centimeters. A length of 10 centimeters and a breadth of 8 centimeters. Within this rectangle, there is another rectangle that has a length of 4 centimeters and a breadth of 6 centimeters. But this rectangle that is found within the bigger rectangle is an empty space or an open space. So we need to find this area and we subtract it from the bigger one to get the shape. Okay, so what this means is that the area of B will be equal to, we know that area of a rectangle is equal to length times breadth. So 8 centimeters times 10 centimeters, and that will give us area of the bigger rectangle. Because what we have here is an open space, we will subtract the area of this rectangle here. So 4 centimeters times 6 centimeters. We will subtract it from the bigger one to get the area of the shape B. And when you do that, you are going to have 56 centimeters squared. So area of the rectangle of the triangle, which is shape A, is 25 centimeters squared. And area of the rectangle, which is shape B, is 56 centimeters squared. So to find the area of the shape, you are going to have 25 centimeters squared plus 56 centimeters squared, which will give us 81 centimeters squared. So we can say that the area of this composite shape is 81 centimeters squared. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the area and perimeter of composite shapes. Bye-bye. We are on the topic mensuration. In the previous video, we solved a question on finding the area of composite shapes. In this video, we are going to solve another question. The question is, find the area of the shaded portion in the figure below. If we consider this figure carefully, we can see that we have a circle in a square, and we are supposed to find the area of the shaded portion. To help us find the area of the shaded portion, we can see that the area of this shaded portion is equal to area of the squared minus area of the circle, because the circle is unshaded. So if you're able to find area of the squared and we subtract the area of the circle from it, you get area of the shaded portion. We know that area of a squared is equal to length times length. So area of this squared here is going to be equal to 10 meters times 10 meters, and that will give us 100 meters squared. We need to find area of the circle. We learned that area of a circle is equal to pi r squared, where r is the radius of the circle. We can see clearly from this diagram that the distance from this point here to this point here is 10 meters. And the distance from this point here to this point here is also 10 meters. What that means is that if we draw a line from this side here through the middle of the circle to another side, is going to be 10 meters. Okay, so this means that the radius of the circle, this means that the diameter of the circle is 10 meters, since the circle fits directly into this squared. Because it fits directly into the squared, the diameter of the circle is going to be 10 meters. From the formula here, we have the radius in it, which is pi r squared. We learned that radius is equal to diameter divided by 2. So the radius of this circle, represented by r, is going to be the diameter, which is 10 meters divided by 2. So to find the radius of this circle is going to be 10 meters divided by 2, which is 5 meters. Okay, so we now have the radius of the circle. So the area of the circle is equal to pi times r, and r is 10 meters divided by 2. So 10 meters divided by 2 squared. We know that 10 meters divided by 2 gives us 5 meters. So in fact, you have pi times 5 meters squared, and that will give us 78.5 meters squared. But we just saw from here that area of the shaded portion is equal to area of the squared, which is 100 meters squared, area of the square, which is 100 meters squared, minus area of the circle, which is 78.5 meters squared. And when you do this, you are going to have 21.5 meters squared. So we can say that area of the shaded portion in this diagram is equal to 21.5 meters squared. Thank you for watching this video. Don't forget to like and subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the area of composite shapes. Bye-bye. We are on the topic mensuration. In the previous video, we solved a question on finding the area of composite shapes. In this video, we are going to solve another question. The question for this video is, find the area of the shaded portion if the line AC passes through the center of the circle. So for this shape, we have a right-angled triangle in a circle. And the question is telling us that the line AC passes through the center of the circle, meaning that the line AC is the diameter of the circle. And the question says we should find the area of the shaded portion. If you look at the diagram very carefully, you can see that the area of the shaded portion is equal to the area of the circle minus area of the triangle, because the triangle is the unshaded portion. So if you're able to find the area of the circle and we find the area of the triangle, then we subtract the area of the triangle from the area of the circle, you will get the area of the shaded portion. To find the area of a circle, so this is a circle, okay, circle. So a C is here. Okay. So to find the area of the circle, we know that the formula is pi r squared, which means that we will need the radius of the circle. Here is the case that AC, which is the diameter, has not been given to us. So we need to find AC. From the diameter, we can get the radius, then we use it to find the area of the circle. If we consider the triangle ABC, we can see that it's a right-angled triangle with BC as 7 centimeters, AB as 25 centimeters, and we are looking for AC. We can apply the Pythagoras theorem on this right angled triangle to find the length AC. If you apply the Pythagoras theorem on this triangle, we will see that AC squared is equal to AB squared plus BC squared. So AC squared is equal to 24 squared plus 7 squared. AC squared is equal to 625. You take square root of both sides, and AC is 25 centimeters. That means that the length of the diameter is 25 centimeters. Okay, so from here we now have the length of the diameter as 25 centimeters. But remember that the area of a circle is equal to pi r squared, and we have the diameter as 25 centimeters. We have learned that radius is equal to the diameter divided by 2. In this case, the diameter is 25 centimeters. So you have 25 centimeters. So you have 25 centimeters divided by 2. Okay. So we now know the radius. We can find the area of the circle. So area of the circle is equal to pi times the radius, which is 25 centimeters divided by 2 squared. When you do this on your calculator, you are going to have 490.9 centimeters squared. So the area of the circle is 490.9 centimeters squared. We need to find the area of the triangle. This is the triangle with a base of 7 centimeters and a height of 24 centimeters. 25 centimeters here is the hypotenuse. We learned that the area of a triangle is equal to half times base times height. The base of this triangle is 7 centimeters and the height is 24 centimeters. So the area of this triangle is equal to half times base, which is 7 centimeters, times height, which is 24 centimeters. And this will give us 84 centimeters squared. So we can say that the area of the shaded portion is equal to area of the circle, which is 490.9 centimeters squared, minus area of the triangle, which is 84 centimeters squared. And this will give us 406.9 centimeters squared. So area of the shaded portion is 406.9 centimeters squared. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the area of composite shapes. Bye-bye. We are on the topic mensuration. In the previous video, we solved a question on finding the area of composite shapes. In this video, we are going to solve another question. So let's consider the question for this video. In the figure below, EHF is a semicircle. Find the area of the shaded portion. So you have been given this figure and you are being told that EHF is a semicircle, which is half of a circle. And we are supposed to find the area of this shaded portion. Remember, we learned that to find the area of a composite shape, you first need to split the shape into regular shapes, then you find their areas separately. So to find the area of this composite shape here, we are looking for the shaded portion. So if I draw a line from E to F, we just found out from the question that EHF is a semicircle, that is half of a circle. We can find the area of that. Then GEF is also a triangle. We can find the area of that. So after you find the area of the triangle and the area of the semicircle, you can add it to get the area of the shaded portion. So the area of the shaded portion is equal to area of the triangle GFE plus area of the semicircle EHF. Let's begin with area of the triangle GFE. From the diagram here, we know that from D to E is 20 meters. So from G to F is also 20 meters. And GF is the base of the triangle GEF. We can also see that DG is 15 meters. So EF is also 15 meters. Now, EF is the height of the triangle GFE. So the base of the triangle GFE is 20 meters and the height of the triangle GFE is 15 meters. And we know that area of a triangle is equal to half times base times height. So it means that area of the triangle GFE is equal to half times base, which is 20 meters, times height, which is 15 meters. And this will give us 150 meters squared. So we are done with the triangle. Let's focus on the semicircle. A semicircle is half of a circle. So if the area of a circle is pi r squared, then area of a semicircle is half of pi r squared. That is half times pi r squared. So area of the semicircle EHF is half times pi times the radius of the circle times the square of the radius of the circle. From the diagram here, we can see that EF is the diameter of the circle. EF is the diameter of the semicircle. EF is the diameter of the semicircle. We learned that radius is equal to diameter divided by 2. So it means that the radius of this semicircle EHF is equal to half of 15 meters. Okay, so the area of the semicircle EHF is equal to half times pi times r squared. We know that the r, which is the radius, is equal to 15 meters divided by 2. So 15 meters divided by 2 squared. And when you do this on your calculator, you're going to have 88.4 meters squared. So since a semicircle is half of a circle, the area of a semicircle is half pi r squared, and that is giving us 88.4 meters squared. So now area of the shaded portion is area of the triangle plus area of the semicircle. We found the area of the triangle to be 150 meters squared and area of the semicircle to be 88.4 meters squared. So if you add them, you are going to have 238.4 meters squared. So we can say that area of the shaded portion is 238.4 meters squared. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the area and perimeter of composite shapes. Bye-bye. We are on the topic mensuration. In the previous video, we solved a question on finding the area of composite shapes. In this video, we are going to solve another question. The question for this video is, the diagram below represents a field with a circular pond of 14 meters. Find, correct to 2 decimal places, A, the distance around the field, B, area of the field excluding the pond. So we have this as a field and we have a pond in the middle of the field. The first part of the question says that we should find the distance around the field, that is the perimeter of the field. And the second part says that we should find the area of the field. We will solve the first part in this video, then we will solve the second part in the next video. So let's consider the perimeter of the field, or the distance around the field. From this diagram here, we can see that the distance around the field is equal to the length PQ plus the length SR plus circumference of PTS. So PTS is half of a circle, that is a semicircle. So circumference of this semicircle, PTS, plus circumference of this semicircle, PUR. So if you add PQ to PS to the circumference of PTS and circumference of QUR, you get the distance around the field. We can see that PQ is 112 meters and SR is also 112 meters. So all we need to find is the circumference of PTS, then the circumference of QUR. From this diagram here, we can see that QR is 56 meters. In the same way, PS is also 56 meters. QR is the diameter of the semicircle QUR. So the radius will be half of 56 meters. We know that a semicircle is half of a circle. So if the circumference of a circle is 2 pi r, then circumference of a semicircle is half times 2 pi r. Remember, we are interested in finding the circumference of QUR, which is a semicircle. So you say that circumference of PTS is equal to half times 2 times pi times the radius of PTS, which is 56 meters, divided by 2, because PS is the diameter. So the radius is half of it, that is 56 meters divided by 2, since PS is 56 meters. So the circumference of PTS is equal to half times 2 times pi times 56 meters divided by 2. And this will give us 87.96 meters. The question said we should leave our answers in 2 decimal places. The circumference of QUR will also be the same thing. So half times 2 times pi times 56 meters divided by 2. And that will also give us 87.96 meters. So the circumference of PTS is 87.96 meters, and the circumference of QUR is also 87.96 meters. Now we can say that the distance around the field is equal to PQ plus SR plus circumference of PTS plus circumference of QUR. And this will give us 112 meters plus 112 meters plus 87.96 meters plus 87.96 meters. You add everything here and you are going to get 399.92 meters. So the distance around the field, or the perimeter of the field, is 399.92 meters. The question said that we should find the area of the field excluding the point. We are going to do that in the next video. So see you in the next video, and let's continue solving this question. Welcome back. In the previous video, we solved the first part of this question, that is finding the distance around the field. We are going to consider the second part of the question in this video, the area of the field excluding the point. So we are supposed to find the area of the field excluding the point. Okay, so area of the field excluding the point is going to be area of the semicircle PTS plus area of the rectangle PQRS plus area of the semicircle QUR. Since the question said we should find the area excluding the pond minus area of the pond. So area of this semicircle, area of that semicircle, area of the rectangle minus area of the pond. Remember, the pond is a circular pond with a diameter of 14 meters. So let's begin with the first one, which is area of the semicircle PTS. We know that area of a circle is pi r squared. Since a semicircle is half of a circle, the area of a semicircle is half times pi r squared. The diameter of PTS is 56 meters, so the radius is 56 meters divided by 2. So it means that area of PTS is equal to half times pi squared, half times pi times r squared, which is 56 meters divided by 2 squared. And this will give us 1231.50 meters squared. So this is the area of the semicircle PTS. Let's find the area of the semicircle QUR. That is also half times pi times r squared, and r squared is 56 meters divided by 2. So you have 56 meters divided by 2 squared, and this is also going to give us another 1231.50 meters squared. So we have found the area of the two semicircles PTS and QUR. We need to find the area of the rectangle PQRS. We know that area of a rectangle is equal to length times breadth. The length of the rectangle PQRS is 122 meters. The breadth is 56 meters because QR is 56 meters. So we can see that area of PQRS is equal to the length, which is 112 meters, times the breadth, which is 56 meters. And this will give us 6272 meters squared. So we now have the area of this semicircle, we have the area of this semicircle, and we have the area of the rectangle. But the question said we should find the area excluding the pond. So we need to find the area of the pond and subtract it from it. Let's move on to area of the pond. The pond is a circle with a diameter of 14 meters. We know that area of a circle is equal to pi r squared. So area of the pond is equal to pi times r. R is the diameter divided by 2. Here the diameter is 14, so r will be 14 meters divided by 2. So we have pi times 14 meters divided by 2 squared. And this is going to give us 153.94 meters squared. Okay, so we now have the area of the semicircle PTS, area of the rectangle PQRS, and area of the semicircle QUR. We also have the area of the pond. So area of the field excluding the pond is equal to area of PTS, area of PQRS, area of QUR. You add all of them, then minus area of the pond. And this is going to give us 1231.50 meters squared plus 6272 meters squared plus 1231.50 meters squared minus 153.94 meters squared. You do everything here and you're going to have 8581.06 meters squared. So you can see that area of the field excluding the pond is 8581.06 meters squared. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the area and perimeter of composite shapes. Bye-bye. We are on the topic mensuration. In the previous video, we learned how to find the area and perimeter of a composite shape and we solved a question on it. In this video, we are going to solve another question. The question is, the diagram below represents a playground. Calculate the distance around the playground. Correct your answer to the nearest whole number. So we have been given this playground and we are supposed to calculate the distance around the playground. We have learnt that the distance around a figure is the same as the perimeter of the figure. So the perimeter of this playground here is equal to the distance SR plus the distance RQ or QR plus the distance QY plus the circumference of the semicircle YZS plus the distance XP plus the distance PS. We can see from this diagram that we have SR, we have RQ, we have QY, we have SP, and we have PS. What we don't have is the circumference of YZS, and that is what we need to find. YZS is a semicircle. We have learned that the circumference of a circle is 2 pi r. So the circumference of a semicircle is half times 2 pi r. That means that to find the circumference of a semicircle, we need to know the diameter so that we can use it to find the radius. The diameter of the semicircle YZX or XZY is XY. So if you join the distance from X to Y like this, that is going to give us the diameter of this semicircle, and we can use that diameter to find the circumference of the semicircle. But we don't know XY. Now look at something here. If we draw a line from S here upwards, then we extend the line from P to join it, we can call this point here point A. The same way, if you draw a line from Q to this point and we draw R, we extend the line from R to join it, we can call it point B. If we're able to find AP and we find QB, we can say that AP plus PS plus XY plus YQ plus QB will be the same as SR. So from here, that means that if we're able to find AP and QB, we can find SY, since we already know SP as 50 meters and QY as 50 meters. All we need to do is to find AP and QB. We can add everything here and equate it to SR, since it's the same thing. And that is what we are going to do. From this diagram, as we saw previously, if we draw this line here, then we extend this one to meet it, they are going to meet at right angle or 90 degrees here. That means that if we have the angle here to be 60 degrees, we are going to call this point here point A. So if you have the angle here to be 60 degrees, since the angle that will be formed here is a right angle, we have drawn a perpendicular line from S to this point here. So since the angle that will be formed here is 90 degrees, if what you have here is 60 degrees, then this angle here will be 30 degrees. Okay. Now look at something. SAP or APS is a right angle triangle. We have 30 degrees here. AP is opposite to 30 degrees and PS is the hypotenuse. So we have opposites, we have hypotenuse. We can use sine to find AP. From the triangle APS, we can say that sine 30 degrees is equal to AP, which is opposite, divided by the hypotenuse, that is 200 meters. We multiply the left hand side by 200, the right hand side by 200, and AP is equal to 200 sine 30, which is 100. So we can say that AP is 100 meters. In the same way, when you come here, if you draw a perpendicular line from R and we extend the line from Q to meet it, we are going to form a right angle here. I'm going to call their meeting point point B. Now, since this is a perpendicular line, it means that the total angle here is 90 degrees. So if you have the angle here at 60 degrees, this one is also going to be 30 degrees. We want QB. QB is opposite to 30 degrees and QR is the hypotenuse. So we can say that from triangle QBR, sine 30 degrees is equal to QB, which is opposite to 30 degrees, divided by the hypotenuse, that is 200 meters. We multiply the left hand side by 200, the right hand side by 200, and QB is equal to 200 sine 30 degrees. So we can see that QB is equal to 100 meters. So we now have AP, we have QB. So AP is 100 meters and QB is 100 meters. If you look at the diagram very carefully, as you've already known, the distance SR is the same as the distance AP plus the distance PS plus the distance XY plus the distance YQ plus the distance QB. We know that SR is equal to 314 meters. AP is 100 meters, PS is 50 meters. We are looking for SY, YQ is 50 meters, and QB is 100 meters. When we simplify everything here, you have XY is equal to 14 meters. So now we know the diameter of the semicircle as 14 meters. Okay, so the distance XY is now 14 meters. The circumference of a semicircle, we've just found out that is half times 2 pi r. So we can say that the circumference of the semicircle YXZ is equal to half, or 1 divided by 2 times 2 times pi times r. R is the diameter divided by 2, and the diameter is 14 meters, so 14 meters divided by 2. So it means that the circumference is equal to half times 2 times pi times 14 divided by 2. And this will give us 22 meters. So the circumference of the semicircle YXZ is 22 meters. We can now find the perimeter of the playground. That will give us SR plus RQ plus QY plus circumference of the semicircle XYZX plus XP plus PS. So you have 314 meters plus 200 meters plus 50 meters plus 22 meters plus 50 meters plus 200 meters. We add everything and we have 836 meters. So the distance around the playground is 836 meters. So all we needed to do was to find the circumference of this semicircle here, and we add it to the other distance that we had. We have the playground, the perimeter of the playground, or the distance from the playground, and that is 836 meters. Thank you for watching this video. Subscribe to this channel for more videos. This is the end of the videos on plane figures. In the next video, we are going to consider solid figures, and the first solid figure we'll be considering is a cylinder. Bye-bye. We are on the topic mensuration. So far, we have considered how to find the area and perimeter of plane figures and composite shapes. In this video and the subsequent ones, we are going to concentrate on solid figures. The solid figures we'll be considering are cylinder, cuboid, cone, sphere, and pyramids. So we will consider these types of solid figures. For plane figures, We learned how to find the area and perimeter. For solid figures, we are going to learn how to find the total surface area, the curved surface area, and the volume. So for each of these plane solid figures, we are going to learn how to find its total surface area, curved surface area, and volume. The first solid figure you'll be considering is a cylinder. Cylinder. The diagram we have here is a cylinder with height of h and a radius of r. So the distance from the top part to the bottom is h, which is the height of the cylinder, and the radius of the circular end that we have here is r. That is the radius of the cylinder. So this is an example of a cylinder with radius r and a height of h. One thing you need to know about a cylinder is that a cylinder may be closed at both ends, opened at one end and closed at the other end, or opened at both ends. So for this cylinder, we know that the top part here has a circular surface and the bottom will also have a circular surface. Now we are learning that both ends, that is both circular surface, can be closed. It can also be that one is closed and the other is opened, or both of them are opened. So for example, in the picture here, the top part, the circular end here is closed. The bottom is also closed. This is a type of a cylinder. It can also happen that you have a cylinder where the top part is open, as we have in this picture, and the bottom is closed. This is another type of a cylinder. It can also happen that the top part here is opened, as we have here, and the bottom is also opened. If you have a cylinder like that, it's called a hollow cylinder. A cylinder with both ends open is called a hollow cylinder. So for cylinders, you can have both ends opened, both ends closed, or one end opened and the other end closed. Just as we've seen, we are going to learn how to find the total surface area, curved surface area, and volume of these types of cylinders. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to learn how to find the total surface area, curved surface area, and volume of a cylinder. Bye-bye. We are on the topic mensuration. In the previous video, we considered a cylinder and we looked at some types of cylinders. In this video, we are going to learn how to find the total surface area, curved surface area, and volume of a cylinder. To do that, we need to note the following formulas. We learned in the previous video that a cylinder can have both ends closed. So if a cylinder has both ends closed, the total surface area of the cylinder is given by 2 pi r squared plus 2 pi rh, where r is the radius of the cylinder and h is the height of the cylinder. If the cylinder has one end closed and the other end open, the total surface area is given by pi r squared plus 2 pi rh. And if the cylinder has both ends open, then the total surface area is given by 2 pi rh. So you can see from here that the formula for finding the total surface area depends on the type of cylinder you are considering. The formula for finding the volume and the curved surface area does not depend on the type of cylinder. So the condition of the ends of the cylinder does not affect its volume and curved surface area. That means that the formula for finding the volume of all cylinders is pi r squared h. It does not depend whether one end is closed or one end is open. The volume is pi r squared h. And in the same way, the formula for finding the curved surface area is also 2 pi rh. It does not depend on whether one end is opened or one end is closed, or both ends are open or closed. So these are the formulas that you'll be using. If you look at this very carefully, you can see that the formula for finding the total surface area of a hollow cylinder or a cylinder with both ends open is the same as the formula for finding the curved surface area of a cylinder. Let's use these formulas to solve some questions. The question we are considering is a cylindrical container closed at both ends has a radius of 7 centimeters and a height of 5 centimeters. And we are supposed to calculate the total surface area, curved surface area, and the volume of the cylinder, and we leave our answer in terms of pi. Okay, so we are talking about a closed cylinder, and the radius is 7 centimeters and the height is 5 centimeters. The total surface area of a closed cylinder is given by 2 pi r squared plus 2 pi rh, where r is the radius, in this case 7 centimeters, and h is the height, in this case 5 centimeters. It means that you have 2 times pi times 7 centimeters squared plus 2 times pi times 7 centimeters times 5 centimeters. We are supposed to leave our answer in pi, so you have 2 times 7 squared times pi, and that will give us 98 pi centimeters squared. When you come here to, you have 2 times 7 times 5, that will give us 70. So times pi, you have 70 pi centimeters squared. If we add 98 pi to 70 pi, you will get 168 pi centimeters squared. If you find this on your calculator, you will see that you have 168 pi centimeters squared. Since the question said we should leave our answer in pi, this is going to be our final answer. So the total surface area of the cylinder is 168 pi centimeters squared. The question also said that you should find the curved surface area, and we have just found out that the formula is 2 pi rh. So this will give us 2 times pi times 7 centimeters times 5 centimeters. We are leaving our answer in pi. So we have 2 times 7 times 5, which is 70, times pi. So you have 70 pi centimeters squared, since we have centimeters times centimeters. So the curved surface area of the cylinder is 70 pi centimeters squared. The question also said we should find the volume of the cylinder, and the formula is pi r squared h. So you have pi times 7 centimeters squared times 5 centimeters, and this will give us 7 squared times 5 times pi, and that will be 245 pi centimeters cube. Since this is the volume, the unit will be in a cube, so centimeters cube, meaning that you have centimeters squared here times centimeters, which will give us centimeters cube. So pi times 7 centimeters squared times 5 centimeters will give us 245 pi centimeters cube. We are leaving our answer in terms of pi. So the volume of the cylinder in terms of pi is 245 pi centimeters cube. So the most important thing here is that you identify the type of cylinder you are considering, then you look through the formulas and you pick the formula that will help you to solve the question. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the total surface area, the curved surface area, and volume of a cylinder. Bye-bye. We are on the topic mensuration. In the previous video, we learned how to find the total surface area, curved surface area, and volume of a cylinder with both ends closed. In this video, we are going to consider how to find the total surface area, curved surface area, and volume of a cylinder with one end open and the other end closed. Let's consider this question. A cylinder of diameter 4 centimeters and height 14 centimeters has one of its ends open. Find, correct to 2 decimal places, the total surface area, curved surface area, and volume of the cylinder. So for this cylinder, one end is open and the other end is closed, and the diameter of the cylinder is 4 centimeters and the height is 14 centimeters. We are supposed to find the total surface area, curved surface area, and volume of the cylinder, and we correct our answer to 2 decimal places. Okay, so the diameter is 4 centimeters. It means that the radius is going to be 4 centimeters divided by 2, since radius is equal to diameter divided by 2. So the radius is 2 centimeters and the height is 14 centimeters. The question said we should find the total surface area. This is a cylinder with one end open. So the total surface area is equal to pi r squared plus 2 pi rh. We saw this in the previous video. We have the radius as 2 centimeters and the height as 14 centimeters. So this will give us pi times 2 centimeters squared plus 2 times pi times 2 centimeters times 14 centimeters. If you find this on the calculator, you have shift pi times 2 squared plus 2 times shift, then you press on times 10 to the power x, that will give you pi times 2 times 14, and this will give us 60 pi. The question did not tell us to leave our answer in terms of pi. It said we should give our answer in 2 decimal places. So you press on the S to D button and to give you your answer in decimals. The question said 2 decimal places, so you correct this here to 2 decimal places, and that will be 188.50 centimeters squared. So the total surface area of this cylinder in 2 decimal places is 188.50 centimeters squared. The question also said we should find the curved surface area, and the formula is 2 pi rh. So this will give us 2 times pi times 2 centimeters times 14 centimeters. Once again, if you do this on your calculator, you are going to have 2 times, you press on shift, then you press on this button to get pi times 2 times 14, and this will give us 56 pi. We want our answer in decimal, so you press on the S to D button, and to give you your answer in decimal, then you correct that answer to 2 decimal places, and you have 175.93 centimeters squared. So the curved surface area of the cylinder is 175.93 centimeters squared. If you want to learn how to correct your answer to a given decimal place, watch the videos on approximations. I explain how to correct your answer to a given decimal place there. The question also said we should find the volume of the cylinder, and this is giving us pi r squared h. So you have pi times 2 centimeters squared times 14 centimeters. If you do this on your calculator and you correct your answer to the decimal place to 2 decimal places, you have 175.93 centimeters cube. So the volume of the cylinder is 175.93 centimeters cube. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to learn how to find the total surface area, curved surface area, and volume of a cylinder with both ends open. Bye-bye. We are on the topic mensuration. In the previous video, we learned how to find the total surface area, curved surface area, and volume of a cylinder with one end open and the other end closed. In this video, we are going to consider a cylinder with both ends open, or a hollow cylinder. The question for this video is, a cylinder with both ends open has a height of 12 centimeters and a diameter of 10 centimeters. Correct your answer to 3 significant figures: the total surface area and the volume of the cylinder. In previous videos, we have learned that for a cylinder with both ends opened, the total surface area is the same as the curved surface area. So in this question, we are considering the total surface area and the volume of the cylinder. So the diameter is 10 centimeters, which means that the radius is 10 centimeters divided by 2, which is 5 centimeters, and the height is 12 centimeters. This is a hollow cylinder. For a hollow cylinder or a cylinder with both ends open, the total surface area, which is also the same as the curved surface area, is equal to 2 pi RH. So we have 2 times pi times 5 centimeters times 12 centimeters. The question said we should leave our answer in 3 significant figures. So you find 2 times shift pi times 5 times 12. We are going to have 120 pi. We need our answer in decimals, so you press on the S to D button and it gives us in decimals. We correct this answer here to 3 significant figures and you are going to have 377 centimeters squared. Once again, if you want to learn how to correct your answer to given significant figures, watch the videos on approximation that is available on this channel, and you will know how to correct your answer to a given significant figures. So the total surface area of this cylinder is 377 centimeters squared, which means that the curved surface area will also be 377 centimeters squared, because for a hollow cylinder, the total surface area is the same as the curved surface area. The volume of the cylinder is always the same. The formula is pi r squared each. It does not depend on whether one end is opened or the other end is closed. The volume of a cylinder is always pi r squared each. R is 5 centimeters and h is 12 centimeters. So we have pi times 5 centimeters squared times 12 centimeters. So we are going to have shift pi times 5 squared times 12, and this will give us 300 pi. We need our answer in decimals, so you press on the S to D button to convert it to decimals. Then you correct this answer here to 3 significant figures, and that will give us 4942 centimeters cube. Since it's a volume, you have centimeters cube as the unit. So it means that the volume of this cylinder is 942 centimeters cube. Once again, if you want to know how to correct your answer to a given significant figures, watch the video on approximation that is available on this channel. I explain how to correct a given number to a given significant figures. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to consider a special type of cylinder called the annular cylinder. Bye-bye. We are on the topic mensuration. In the previous video, we considered a hollow cylinder and we learned how to find the total surface area, curved surface area, and volume of a hollow cylinder. In this video, we are going to consider annular cylinder. Annular cylinder. The picture that we see here is an example of an annular cylinder. So it's like we have one cylinder that is fixed into another. If you have an annular cylinder, from the center to the inner cylinder is called the distance from the center to the inner cylinder is called the internal radius. So in this diagram here, the distance from the center here to the inner cylinder, to the surface of the inner cylinder or an end of the inner cylinder is called the internal radius, and the distance from the center to an end of the outer cylinder is called the external radius. A typical example of an annular cylinder is a pipe. So if you have a pipe, you can see that it looks like the picture that we have here. The distance from the center here to the inner cylinder is called the internal radius, represented by a small r, and the distance from the center to the outer cylinder is called the external radius, represented by big R. The distance from the top to the bottom of the cylinder is h, that is the height of the cylinder. If you have an annular cylinder like this, we will say that in order to find the cross-sectional area, the formula is pi r squared minus pi rh, where the first r is the external radius and the second r is the internal radius. So pi big R squared minus pi small r squared. To find the volume of the cylinder, the formula is pi r squared h, where r here is the small r, that is the internal radius, and h is the height of the cylinder. And to find the volume of material used in making the cylinder, the formula is pi big R squared minus pi small r squared into brackets times h. That means that, let's say that this annular cylinder we have here is a pipe. To find the volume of the plastic or metal used in making the pipe, the formula is pi the external radius squared minus pi internal radius squared times the height of the cylinder. Let's pick a question and see how to apply these formulas. A cylindrical pipe is 2.8 meters long. Remember that a pipe is an example of an annular cylinder. Its internal radius is 3.5 centimeters and its external radius is 5 centimeters. Calculate, correct your answer to one decimal place, the cross-sectional area of the pipe, volume of water the pipe can hold when full, and volume of plastic used in making the pipe. Give your answers in centimeters. We have been given the height of the pipe here to be 2.8 meters. It's in meters, but the question said we should give our answer in centimeters, which means that we have to convert this from meters to centimeters. Okay, so the height is 2.8 meters. If you convert it to centimeters, you have 280 centimeters. So you multiply 2.8 by 100 to convert it to centimeters. The internal radius, which is small r, is 3.5 centimeters. That's what the question told us. It said the internal radius is 3.5 centimeters. And the external radius was also given to us as 5 centimeters. So small r is 3.5 centimeters and big R is 5 centimeters. The question said we should find the cross-sectional area. The formula is pi big R squared minus pi small r squared. And this will give us pi times 5 centimeters squared minus pi times 3.5 centimeters squared. If you find this on your calculator, you are going to get 40.1 centimeters squared. So you find this on the calculator, then you correct your answer to one decimal place, just as the question told us. This means that the cross-sectional area of the pipe is 40.1 centimeters squared. Okay. The question also said we should find the volume of water the cylinder can hold when full. The volume of water the cylinder can hold when full is the same as the volume of the cylinder, because the volume of the cylinder will determine the amount of liquid that the cylinder can hold when full. So the volume of water the cylinder can hold when full is the same as volume of the cylinder. To find volume of this cylinder, we have learned that the formula is pi r squared h, where r here is the internal radius. So this will give us pi times 3.5 centimeters squared times h. We want our answer in centimeters, so we are going to use 280 centimeters. When you do this on your calculator and you correct your answer to one decimal place, you should have 10775.7 centimeters cube. That means that the volume of water the cylinder can hold when full is 10775.7 centimeters cube, which means that when the pipe is full with water, the volume of water in the pipe is 10775.7 centimeters cube. The question also said that we should find the volume of plastic used in making the pipe. The volume of plastic used in making the pipe. We learned that the volume of material used in making an annular cylinder is given by pi big R squared minus pi small r squared times h, where big R is the external radius and small r is the internal radius, and h is the height of the cylinder. So the volume of plastic used in making the pipe is equal to pi big R squared minus pi small r squared times h. And this will be given by pi times 5 squared minus pi times 3.5 squared times 120 centimeters, or times 120. When you do this on your calculator, you're going to have 11215.5 centimeters cube. This means that the volume of plastic used in making the pipe is 11215.5 centimeters cube. So for an annular cylinder, you need to note these formulas and you use them whenever you are being told to find the cross-sectional area, the volume of water the cylinder can hold, or the volume of the cylinder, and the volume of plastic or material used in making the cylinder. Thank you for watching this video. Subscribe to this channel by clicking on the subscribe button that you see. In the next video, we are going to consider another solid figure. The solid figure we will be considering is a cuboid. So we will learn how to find the total surface area, curved surface area, and volume of a cuboid. Bye-bye. We are on the topic mensuration. In the previous video, we considered an annular cylinder and we learned how to find the cross-sectional area and volume of an annular cylinder. In this video, we are going to consider a cuboid and a cube. A cuboid. The diagram we have here is an example of a cuboid. It is a box with all its sides closed. So a cuboid is a box. If we call this point here point A, we call this one here point B, point C, E, H, G, and F. We can draw this same cuboid as what we have here with the point A, B, C, D, E, F, G, H. So we will call this point that will be formed here point D. The length from A to B is X, and the length from B to C is Y. The length from C to H is Z. For this cuboid, the length X is called the length, Y is called the breadth, and Z is called the height. So if you have a cuboid like this with these dimensions, then A to B is the length, B to C is the breadth, and C to H is the height of the cuboid. This is a cuboid. A cube is a cuboid with equal sides. So if the length, breadth, and height of a cuboid are the same, then that cuboid is called a cube. If the length is equal to the breadth and is equal to the height, then the cuboid you have is a cube. Let's learn the formulas we are going to use to solve questions on cuboids. Formulas relating to cubes and cuboids. If you have a cuboid like this, just as we've seen, with the length X, breadth Y, and height Z, and all the sides of the cuboid are closed, then the total surface area of the cuboid is equal to 2xy plus 2yz plus 2xz. And the volume of the cuboid is given as x times y times z. That is the length times the breadth times the height. That gives you the volume of the cuboid. So if all the sides are closed, then the total surface area of the cuboid is 2xy plus 2yz plus 2xz. And the volume of the cuboid is x times y times z. If we draw a line from B to G, as we have in this diagram, this line is called the principal diagonal of the cuboid. The principal diagonal of the cuboid. And the length of this principal diagonal BG is given as square root of x squared plus y squared plus z squared. So if you draw a line from B to G as we have in this diagram, that line is called the principal diagonal, and the length of that line is equal to square root of the length squared plus the breadth squared plus the height squared. These are the formulas for cuboids. For cubes, we have learned that x is equal to y and is equal to z. So the total surface area for a cube is 6x squared and the volume is s cubed. Since y will be x and z will also be x, so you have x times x times x, and that will give us s cubed. In the same way, for this part, y will be x, so you have 2 times x times x. Both y and z will all be x, so you have 2 times x, and z will also be x, so you have 2 times x, and when you add that, you are going to get 6s squared. So the total surface area will give us 6s squared and the volume is s cubed, where x is the length of the side of the cube. So the length of the side of the cube is x, then the total surface area is s squared and the volume is s cubed. These are the formulas for cubes and cuboids. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to use these formulas that we've learned to solve questions on cube and cuboids. Bye-bye. We are on the topic mensuration. In the previous video, we learned how to find the total surface area and volume of a cube and cuboid. In this video, we are going to use the formulas we studied in the previous video to solve a question. The question for this video is, the length of a cuboid is 10 centimeters. Its breadth is 6 centimeters and its height is 4 centimeters. Find the total surface area and volume of the cuboid. 2. The length of the longest stick that can fit into the cuboid. So we have been given the dimensions of the cuboid. The length, which is indicated by x, is 10 centimeters. The breadth, indicated by y, is 6 centimeters. And the height, indicated by z, is 4 centimeters. The question said that we should find the total surface area and volume of the cuboid. In the previous video, we learned that the total surface area of a cuboid is 2xy plus 2yz plus 2xz. We have x as 10 centimeters, y as 6 centimeters, and z as 4 centimeters. So you substitute these values into the formula. We are going to have 2 times 10 times 6 plus 2 times 6 times 4 plus 2 times 10 times 4. And that will give us 248 centimeters squared. Since it's the total surface area, the unit is centimeters squared. So the total surface area of the cuboid is 248 centimeters squared. The question also said we should find the volume of the cuboid. We learned in the previous video that the volume of a cuboid is equal to the length, which is x, times the breadth, which is y, times the height, which is z. So the volume is equal to 10 centimeters times 6 centimeters times 4 centimeters. And that will give us 240 centimeters cube. Since it's the volume, the unit is centimeters cube. So the volume of the cuboid is 240 centimeters cube. The question also said that we should find the length of the longest stick that can fit into the box. The length of the longest stick that can fit into the box is equal to the length of the principal diagonal. We learned what the principal diagonal is in the previous video. So the length of the longest stick that can fit into the box is equal to the length of the principal diagonal. In the previous video, we learned that if the length is x, the breadth is y, and the height is z, then the length of the principal diagonal is equal to square root of s squared plus y squared plus z squared. That is square root of the length squared plus the breadth squared plus the height squared. and this will give us square root of 10 squared plus 6 squared plus 4 squared, and this is equal to 12.3 centimeters. That means that the length of the longest stick that can fit into the box is 12.3 centimeters. So whenever you are being asked to find the length of the longest stick that can fit into a box or a cuboid, it is equal to the length of the principal diagonal, which is giving us square root of the length squared plus the breadth squared plus the height squared. We did that here and we got 12.3 centimeters. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the total surface area and volume of a cube and cuboid. Bye-bye. We are on the topic mensuration. In the previous video, we solved a question on finding the total surface area, volume, and length of the principal diagonal of a cuboid. In this video, we are going to solve another question on a cube. So let's consider the question for this video. The side of a cube is 7 centimeters long. Find the total surface area and volume of the cube. So for this cube, we have been given the side as 7 centimeters long. So the length of the sides of the cube is 7 centimeters, and we are representing that length with x. So x is 7 centimeters. In the video on cube and cuboid, we learned that the total surface area of a cube is equal to 6s squared, where x is the length of the side of the cube. So the total surface area of this cube is 6s squared, and x is 7 centimeters. So it means we are going to have 6 times 7 centimeters squared, and this will be 294 centimeters squared. So the total surface area of this cube is 294 centimeters squared. The question said we should find the volume of the cube. We know that the length of the side of the cube is 7 centimeters. The volume of the cube is equal to s cubed, and s is the side of the cube, which is 7 centimeters. So the volume is equal to 7 centimeters cubed, and this will give us 343 centimeters cubed, since 7 cubed is 343. So the volume of the cube is 343 centimeters cubed. So with the length of the side being 7 centimeters, we have been able to find the total surface area and the volume of the cube. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the total surface area and volume of a cube and cuboid. Bye-bye. We are on the topic mensuration. In the previous video, we solved a question on finding the total surface area and volume of a cube. In this video, we are going to solve a question on a cuboid. So let's consider the question for this video. A closed rectangular box measures 6 meters by 4 meters by 5 meters. Find the total cost of painting the external surface of the box. If it costs 0.80 Ghana cedis to paint 1 square meter. So we have been given the dimensions of the box as 6 meters by 4 meters by 5 meters. This means that the length of the box is 6 meters, the breadth is 4 meters, and the height is 5 meters. So if you have this as the box, the length is 6 meters, the breadth is 4 meters, and the height is 5 meters. The question says that we should find the total cost of painting the external surface. That is, we should find the cost of painting this side here, and this side, and this side. When you paint the top part here, you paint the bottom. When you paint this side here, you will paint the back. And if you paint the right side here, we are also going to paint the left side. So we should find the cost of painting these sides or the external surface if painting 1 meter squared costs 0.80 Ghana cedis. So if you are painting the external sides, we need to find the area of these external sides. Remember, we are painting these surfaces, so we need to find the total area of these surfaces. That is the total surface area. So in order to know the cost of painting these external sides, we need to find the area of these external sides, because you have been given 1 meter squared. The cost of painting 1 meter squared to be 0.80 Ghana cedis. So we are going to find the total surface area of the box, since that is the area that we will be painting. If the length is x, the breadth is y, and the height is z, and the box that we have is a closed box, then the total surface area is equal to 2xy plus 2yz plus 2xz. So x is 6, y is 4, and z is 5. The total surface area will give us 148 meters squared. So it means that the total surface area of this box is 148 meters squared. Remember, the question said that the cost of painting 1 meter squared is 0.80 Ghana cedis. So we are going to do simple proportion here. If the cost of painting 1 meter squared is 0.80 Ghana cedis, then the cost of painting 148 meters squared will be more. And from proportion, if more, less we divide. So if the cost of painting 0.80, if the cost of painting 1 meter squared is 0.80 Ghana cedis, then the cost of painting 148 meters squared is going to be less is going to divide. That means that it's going to be 148 meters squared divided by 1 meter squared times 0.80 Ghana cedis, because if more, less we divide. And obviously you can see that if painting 1 meter squared is 0.80 Ghana cedis, then painting 148 meters squared will be more. And if it's more, then the less, which is 1 meter squared, is going to divide. So you have 148 meters squared divided by 1 meter squared times 0.80 Ghana cedis. When you do this, you will see that this 1 meter squared, this meter squared will cancel meter squared. So you have 148 times 0.80 Ghana cedis. It means that we are going to find 148 times 0.80, and that will give us 118.40 Ghana cedis. So if the cost of painting 1 meter squared of the box is 0.80 Ghana cedis, then the cost of painting the total surface area, that is the external surface of the box, which is 148 meters squared, will be 118.40 Ghana cedis. Thank you for watching this video. I hope the video was helpful. If you did, subscribe to this channel by clicking on the subscribe button that you see. In the next video, we are going to consider another solid figure. The solid figure we've been considering this time is a cone. So we will learn how to find the total surface area, curved surface area, and volume of a cone. Bye-bye. We are on the topic mensuration. In the previous video, we learned how to find the total surface area and volume of a cube and cuboid. In this video, we are going to concentrate on a cone. So we will learn how to find the total surface area, curved surface area, and volume of a cone. Cone. The diagram we see here is an example of a cone with vertex V. So O is called the vertex. So V is called the vertex. O is the center of the circular base. And B is a point on the circumference of the circular base. When you have a cone like this, from V to B, represented by L, is called the slant height. From V to O, represented by H, is called the height of the cone. And from O to B, which is a point on the circumference of the circular base, is called the radius of the base. So this is a cone with vertex O, with vertex V, O as the center of the circular base, and B as a point on the circumference of the circular base. VB, represented by L, is called the slant height of the cone. VO is called the height of the cone, and R is called the base of the cone, or the base radius. R is called the base radius of the cone. If you have a cone like this, the angle created at V here, which we are going to call theta, is called the vertical angle. So the total angle created here is called the vertical angle. Half of this angle, half of the vertical angle, which we are representing by alpha in this diagram here, is called the semi-vertical angle. So the semi-vertical angle is half of the vertical angle. If you divide the vertical angle by 2, you will get the semi-vertical angle. In the same way, if you multiply the semi-vertical angle by 2, you will get the vertical angle. Okay. The base of a cone may be closed or open. So this circular base that we have here, it can be either closed or open. If it's closed, the cone is called a closed cone. If it's open, the cone is called a hollow or open cone. So let's learn some formulas relating to cones. We have learned that the circular base of the cone can either be closed or open. If the base of the cone is closed, then the total surface area of the cone is equal to pi r squared plus pi rl, where r is the base radius of the cone and l is the slant height of the cone. So if the base is closed, then the total surface area is given us pi r squared plus pi rl. If the base of the cone is open, that is a hollow cone, then the total surface area is equal to pi rl. So if the base is closed, the total surface area is pi r squared plus pi rl. But if the base is open, then the total surface area is pi rl. So you can see from here that the total surface area, the formula for finding the total surface area, depends on whether the cone is closed or open. If it's closed, it's pi r squared plus pi rl. If it's open, it's pi rl. But the formula for finding the curved surface area and volume does not depend on the condition of the cone. What this means is that whether the base is open or closed, the curved surface area of a cone is pi rl. It doesn't depend on whether the base is open or closed. So the curved surface area of a cone is pi rl. And the volume of the cone does not also depend on the condition of the base. That is, whether the base is open or closed, the volume of the cone is 1 divided by 3 times pi r squared h, where h is the height of the cone and r is the base radius of the cone. You can also see from these formulas that the total surface area of an open cone is the same as the curved surface area of a cone. So if the cone is open or hollow, then the total surface area is the same as the curved surface area. But if the base is closed, the total surface area is pi r squared plus pi rl. These are the formulas that we are going to use to solve questions on cones. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to use these formulas to solve questions on cones. Bye-bye. We are on the topic mensuration. In the previous video, we learned how to find the total surface area, curved surface area, and volume of a cone. In this video, we are going to use the formulas that we learned in the previous video to solve some questions. So let's consider the question for this video. The base radius of a cone is 10 centimeters and its height is 14 centimeters. Calculate the slant height of the cone, curved surface area, total surface area, volume of the cone, semi-vertical angle, and vertical angle. Correct your answers to one decimal place and take pi as 3.142. So you have been given the base radius of the cone and height of the cone. We will solve the first 3 questions in this video, then we will solve the next 3 in the next video. This is the cone. We are going to call the vertex V. O is the center of the circular base, and B is a point on the circumference of the circular base. We learned in the previous video that if we draw a line from V to O, that is going to be the height of the cone. So the height of the cone is 14 centimeters. In the same way, if we draw a line from O to B, which is a point on the circumference of the circular base, OB is going to be the base radius of the cone, and that is 10 centimeters. The height of the cone and the base radius of the cone will meet at right angle. So it means that the angle here will be 90 degrees. So if you pick the points VOB, it forms a right angled triangle VOB, as we can see here, with VO as 14 centimeters and OB as 10 centimeters. The first question said we should find the slant height. In the previous video, we learned that the slant height, which is usually represented by L, is going to be this height. So from V to B is the slant height represented by L. So on our right angle triangle here, VB is the slant height. We have VO and OB, and we need VB. We can use the Pythagoras theorem. So this is our right angle triangle. If we apply the Pythagoras theorem here, you will see that VB squared is equal to VO squared plus OB squared. You have VB squared is equal to 14 squared plus 10 squared. So VB squared is equal to 296. You take square root of both sides, and VB is equal to 17.2 centimeters. What this means is that the slant height of the cone is 17.2 centimeters. So we now have the base radius R as 10 centimeters, the height H as 14 centimeters, and the slant height L as 17.2 centimeters. The question said we should find the curved surface area of the cone. We learned in the previous video that the curved surface area of a cone is equal to pi RL. R is 10 centimeters and L is 17.2 centimeters. The question said we should take pi as 3.142. So you have 3.142 times 10 centimeters times 17.2 centimeters. And this will give us 540.4 centimeters squared. Remember, the question said we should correct our answer to one decimal place. So when you do this, when you find this on your calculator and you correct your answer to one decimal place, you have 540.4 centimeters squared, since it is the surface area or the curved surface area. So the curved surface area of the cone is 540.4 centimeters squared. The question also said we should find the total surface area. Now remember, in the question we were told that this cone is a closed cone. What that means is that the base of the cone is closed. So the total surface area of a closed cone is equal to pi r squared plus pi rl. Pi is 3.142, r is 10 centimeters, and L is 17.2. So you have 3.142 times 10 squared plus 3.142 times 10 times 17.2. And this will give us 8 854.6 centimeters squared. So the total surface area of the cone is 854.6 centimeters squared. So you can see from here that the total surface area of the cone is bigger than the curved surface area because this is a closed cone. The question also said we should find the volume of the cone, and we are going to do that in the next video. So see you in the next video, and let's continue solving this question. Welcome back. In the previous video, we started solving this question. We solved the questions I, and I. In this video, we will solve the three remaining questions. That is the volume of the cone, the semi-vertical angle, and the vertical angle. So, IV, volume of the cone. We have the base radius as 10 centimeters, the height as 14 centimeters, and the slant height as 17.2 centimeters. The formula for finding the volume of a cone is equal to 1 divided by 3 times pi r squared h. So you have 1 divided by 3 times 3.142. Since the question told us to take pi as 3.142. So we have 1 divided by 3 times 3.142 times 10 centimeters squared times 14 centimeters. So the volume of this cone, you correct your answer to one decimal place just as the question told us to do. You have 1466.3 centimeters cube. Since it's the volume, the unit is going to be in centimeters cube. So the volume of the cone is 1466.3 centimeters cube. The question also said we should find the semi-vertical angle. In the first video on cones, we learned that if we have this cone here, the total angle created here is called the vertical angle. Now, half of this angle, as we have here, is called the semi-vertical angle. So, to find the semi-vertical angle, we are going to say that let theta represent, or let theta equal to the semi-vertical angle. What that means is that the angle that will be created here is called theta. So we are calling this semi-vertical angle theta. Considering the points V, O, B, we will form this right angle triangle VOB with VO as 14 centimeters, OB as 10 centimeters, and the angle created at V here as theta. So if you're able to find theta, that is the semi-vertical angle. Now considering this diagram, you will see that 10 centimeters is opposite to theta and 14 centimeters is adjacent to theta. So to find theta, you will say that tan theta is equal to 10 centimeters divided by 14 centimeters. To find theta, theta is equal to tan inverse of 10 divided by 14. So theta will give us 35.5 degrees. Remember, correct your answer to one decimal place. So you will say that the semi-vertical angle of the cone is 35.5 degrees. The next part of the question says that we should find the vertical angle. In the first video on cones, we learned that the vertical angle is equal to 2 times the semi-vertical angle. So if the semi-vertical angle is 35.5 degrees, then the vertical angle is equal to 2 times 35.5 degrees. And that will give us 71.0 degrees. It's 0.0 because we are correcting our answer to one decimal place. So the vertical angle of this cone is 71.0 degrees. The semi-vertical angle is 35.5 degrees. Thank you for watching this video. Subscribe to this channel for more videos. A cone can be formed from the sector of a circle. In the next video, we are going to learn how to find the height, base radius, slant height, total surface area, curved surface area, and volume of a cone formed from the sector of a circle. Bye-bye. We are on the topic mensuration. In the previous video, we learned how to find the total surface area, curved surface area, and volume of a cone. In this video, we are going to consider cones developed from the sector of a circle. A cone can be formed by folding the sector of a circle such that the ends meet. In the video on parts of circles, we learned that the sector of a circle is the part of the circle bounded by two radii and an arc. So in this circle, O is the center, P and Q are points on the circumference of the circle. This part of the circle, POQ, is bounded by the radius OP and OQ and the arc PQ. So POQ is a sector of this circle. If we cut POQ out of this circle, we are going to have this figure that we have here. We will have this figure and we will have this bigger one also. So POQ here and POQ. This smaller one is called the minor sector and the bigger one is called the major sector. We learned this in the video on parts of circles. What this point is telling us that if we fold this sector such that the side OP meets the side OQ, we are going to have a cone. In the same way, if we fold this major sector such that the side OP meets the side OQ, we are going to form another sector. So we can form a cone by folding the sector of a circle such that the radius will meet. If we fold them such that the radius OP will meet the radius OQ, then we will form a cone. So you can try this at home. Draw a circle as we have here with O at the center. Pick any 2 points on the circumference. Then after you have this sector in the circle, cut this sector out of the circle to get the shape that we have here. When you do that, you see that you have this minor sector and this major sector. Now, fold this sector, this minor sector, such that OP will meet OQ. You will see that if you do that, you are going to get a cone. In the same way, if you fold this sector, this major sector, such that OP meets OQ, you are going to form another cone. One thing you need to know about cones formed from the sector of a circle is that they are hollow cones. So cones formed from the sector of a circle is hollow or an open cone. So the total surface area is given by pi RL. We learned in the first video on cones that for hollow cones or open cones, the total surface area is the same as the curved surface area. So for cones formed from the sector of a circle, the total surface area is the same as the curved surface area, and the formula for finding both of them is pi RL, where R is the base radius of the cone and L is the slant height of the cone. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to apply what you have learned in this video to solve questions on cones developed from the sector of a circle. Bye-bye. We are on the topic mensuration. In the previous video, we studied how to develop a cone from the sector of a circle. In this video, we are going to solve a question on cones developed from the sector of a circle. Let's consider the question for this video. A cone is made from a sector of a circle of radius 7 centimeters and an angle of 60 degrees. Find the radius of the base circle of the cone, height of the cone, vertical angle of the cone, volume of the cone, and curved surface area of the cone. Take pi to be 22 divided by 7. We will solve the first question in this video, that is the radius of the base circle of the cone. and we will solve the others in the next video. So let's consider this one very carefully. Now, this is the circle with O as center. We have points P and Q on the circumference of the circle. OP is a radius and OQ is also a radius. The question told us that the radius of the circle is 7 centimeters and the angle of the sector is 60 degrees. That means that the angle between the radius OP and OQ is 60 degrees. POQ, we can cut POQ from this circle and fold it into a cone. So we have the sector POQ. We have cut it from this circle and we can fold this sector POQ into a cone. So we have the angle here to be 60 degrees and the radius as 7 centimeters. If we fold the sector POQ into a cone, we are going to have something like what we have here. So this cone will be a hollow cone. Remember, in the previous video we said that cones developed from the sector of a circle are hollow cones. If you look at these diagrams very carefully, you will see that if we join the side OP to meet OQ in order to form this cone, then the slant height of the cone will be the same as the radius of the sector. So from this distance to this distance here, which is the slant height of the cone, will be the same as the radius of the sector. So for this cone, O will be the vertex here, then the slant height will be 7 centimeters, which is the same as the radius of the sector. If you look at the diagram very carefully again, you will also see that if we join OP to OQ to form this cone here, then the circumference of the circular base of the cone, its circumference will be the same as the length of the arc PQ. If you look at the diagram very carefully, you will see that if you join OP to meet OQ, then the circumference of the circular base here will be the same as the length of the arc PQ. Now, we can say that the length of the arc PQ is equal to circumference of the circular base of the cone. We are going to use this to find the radius of the circular base of the cone. So we have the sector POQ with the radius 7 centimeters and an angle of 60 degrees. To find the base radius of the cone, we first need to find the length of the arc PQ, because we have seen that the length of the arc PQ will be the same as the circumference of the circular base of the cone. From the video on circles, we learned that the length of an arc is equal to theta divided by 360 times 2 pi r, where r is the radius of the circle and theta is the angle between the two radii forming the sector. So theta is 60 degrees and r is 7 centimeters. You substitute them into this formula and you are going to have 7.3 centimeters. So the length of the arc PQ is 7.3 centimeters. That means that if we fold this sector to form this cone here with O as the vertex and a slant height of 7 centimeters, the circumference of the circular base here will also be 7.3 centimeters, because when you fold the sector here to form this cone, PQ will be the circular base, will be the circumference of the circular base. So we can say that the circumference of the circular base is 7.3 centimeters. So the circumference of this base here, which is a circle, is 7.3 centimeters. Now let's concentrate on the cone. Let's call the center of the circular base B and a point on the circumference A. If we draw a line from the center to a point of the circumference, it's going to be the radius of the circle. Now we are focusing on the circular base. So the radius of the circular base here is r. In the video on circles, we learned that the circumference of a circle is equal to 2 pi r, where r is the radius of the circle. Now we know the circumference of this circular base here. It is 7.3 centimeters. So we can say that 7.3 centimeters, which is the circumference of the circular base, is equal to 2 pi r, which is also the circumference of the circular base. So if you're able to find this r here, it will be the radius of the circular base. To find r, we will divide the left hand side by 2 pi and we will divide the right hand side by 2 pi. When you do that, you will see that 2 pi will cancel 2 pi. So r will be 7.3 divided by 2 pi, and we can find that on our calculator. Remember, the question told us that pi is 22 divided by 7. So you search on your calculator and you have 7.3 divided by 2 times pi is 22 divided by 7, so 22 divided by 7, and we are going to have 1.1613, and the numbers goes on and on and on. So you correct that to one decimal place, and the radius of the circle is 1.2 centimeters. So we can say that the radius of the base circle of the cone is 1.2 centimeters. In the next video, we are going to learn how to find the height of this cone. So see you in the next video, and let's continue solving this question. Welcome back. In the previous video, we started solving this question and we considered the first part, which is the radius of the base circle of the cone. We are going to solve the remaining questions in this video, beginning with the height of the cone. In the previous video, we learned that, or we were able to find out that the base radius of the cone is 1.2 centimeters and the slant height of the cone is 7 centimeters. So if this is our cone with O as the vertex, B as the center of the base circle, and A as a point on the circumference of the circular base or the base circle, then the radius is 1.2 centimeters and the slant height, which is OA, is 7 centimeters. To find the height of the cone, we can see that if you pick the points OBA, we have a right-angled triangle here, and the height of the cone will be given as OB. So we are going to apply the Pythagoras theorem on this right-angled triangle to find OB. If you apply the Pythagoras theorem, you will have OA squared is equal to OB squared plus BA squared. Remember, we are looking for OB. We have OA as 7 centimeters and BA as 1.2 centimeters. So 7 centimeters squared is equal to OB squared plus 1.2 centimeters. If you simplify this, you will have OB as 6.9 centimeters. So the height of the cone is 6.9 centimeters. The question also said we should find the semi-vertical angle. So now we have the slant height of the cone, we have the base radius of the cone, and we have the height of the cone. In the first video on cones, we learned that the semi-vertical angle is half of the vertical angle. So if we let theta to be equal to the semi-vertical angle, then we can say that the angle that will be formed here is theta. Considering the points O, B, A, we have this right angle triangle with OA as 7 centimeters, OB as 6.9 centimeters, and BA as 1.2 centimeters, where theta is the semi-vertical angle. Okay, so the semi-vertical angle here is theta. We have 1.2 centimeters being opposite to theta and 7 centimeters as the hypotenuse. We also have 6.9 centimeters as the adjacent to theta. So here we can use any of the trig ratios and you'll be able to find theta. I'm going to pick sine. So sine theta will give us opposite, which is 1.2 centimeters, divided by the hypotenuse, which is 7 centimeters. So sine theta is equal to 1.2 divided by 7. Theta is equal to sine inverse of 1.2 divided by 7, and theta will give us 10 degrees. So we can say that the semi-vertical angle of the cone is 10 degrees. The question told us to find the vertical angle, not the semi-vertical angle. But in order to find the vertical angle, we first need to find the semi-vertical angle. We know that the vertical angle is equal to 2 times the semi-vertical angle. So if the semi-vertical angle is 10 degrees, then the vertical angle is 2 times 10 degrees, which is 20 degrees. So the vertical angle of the cone is 20 degrees. The question also said we should find the volume of the cone. The formula for finding the volume of a cone is 1 divided by 3 times pi r squared h. H is the height of the cone and r is the base radius of the cone. So the volume is equal to 1 divided by 3 times. The question said we should take pi as 22 divided by 7. So 1 divided by 3 times 22 divided by 7 times 1.2 centimeters squared times 6.9 centimeters, and you have 10.4 centimeters cube. So the volume of this cone is 10.4 centimeters cube. The question also said we should find the curved surface area of this cone. This is a hollow cone, so the curved surface area is the same as the total surface area, and the formula is pi rl, where r is the base radius and l is the slant height of the cone. The question said we should take pi as 22 divided by 7. So 22 divided by 7 times 1.2 centimeters times 7 centimeters, and the curved surface area is 26.4 centimeters squared. So the curved surface area of the cone is 26.4 centimeters squared. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on cones developed from the sector of a circle. Bye-bye. We are on the topic mensuration. In the previous video, we learned how to solve questions on cones developed from the sector of a circle. In this video, we are going to solve another question. The question for this video is: the diagram below shows a major sector of a circle with center O and radius 14 centimeters. If the sector is folded to form a cone, find, correct to 2 decimal places, I, the radius of the circular base of the cone, total surface area of the cone, and volume of the cone. So we have been given this sector here with a radius of 14 centimeters, and the major sector was folded into a cone. That means that the minor sector has been cut out of this cone. The angle for the minor sector was 70 degrees. The first part of the question says that we should find the radius of the circular base. In the previous video, we learned that if a sector is folded into a cone, then the slant height of the cone is the same as the radius of the sector. So here the slant height of this cone will be 14 centimeters, which was the radius of the sector. In the same way, the circumference of the circular base of this cone will be the same as the length of the major arc AB. We learned this from the previous video. So we can say that the length of the major arc AB, or the arc AB, is equal to circumference of the circular base of the cone. So we have to find the length of the arc AB. The arc AB is a major arc. In the video on circles, we learned that to find the length of a major arc, it is 360 degrees minus theta divided by 360 degrees times 2 pi r, where theta is the angle of the minor sector. The angle of the minor sector here is 70 degrees. So the length of this major arc will be 360 degrees minus 70 degrees divided by 360 degrees times 2 times pi times 14 centimeters. You find this on your calculator and you have 70.8 centimeters. This is the length of the arc AB, and it is also the circumference of the circular base of the cone, 70.86 centimeters. We know that the circumference of a circle is equal to 2 pi r. So if the circumference of the circular base is 70.8 centimeters, we can say that 70.8 centimeters is equal to 2 pi r. To find r, we divide both sides by 2 pi, and r is equal to 11.28 centimeters. That means that the radius of the base circle of the cone is 11.8 centimeters. The next part of the question said that we should find the total surface area of the cone. Remember, cones formed from the sector of a circle are hollow cones, and the total surface area of a hollow cone is given by pi rl, where r is the base radius of the cone and l is the slant height of the cone. The base radius of the cone here is 11.28 centimeters and the slant height is 14 centimeters. So the total surface area is equal to pi times 11.28 centimeters times 14 centimeters. And this will give us 496.12 centimeters squared. So we can say that the total surface area of the cone is 496.12 centimeters squared. The next part of the question said we should find the volume of the cone. Remember, in order to find the volume of the cone, we will need the height of the cone. So we first need to find the height of the cone. If we consider the points OBA, you will see that we form the right angle triangle OBA here, with BA as 11.28 centimeters and OA as 14 centimeters. From the diagram, OB is the height of the cone, so we need to find OB. We are going to apply the Pythagoras theorem. If we apply the Pythagoras theorem here, we will have OA squared is equal to OB squared plus BA squared. And this will give us 14 squared is equal to OB squared plus 11.28 squared. We simplify this and OB is equal to 8.29 centimeters. The question said we should leave our answers in 2 decimal places. So OB is equal to 8.29 centimeters. Therefore, the height of the cone is 8.29 centimeters. Now, we have the height of the cone as 8.29 centimeters. Volume of a cone is equal to 1 divided by 3 times pi r squared h. In this case, r is 11.28 centimeters and h is 8.29 centimeters. So the volume is equal to 1 divided by 3 times pi times 11.28 centimeters squared times 8.29 centimeters. And when you do this on your calculator and you simplify or you round your answer to, you give your answer in 2 decimal places, you have 1104.59 centimeters cube. So the volume of the cone is 1104.59 centimeters cube. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to consider another solid figure. The solid figure we'll be considering is a sphere and a hemisphere. Bye bye. We are still on the topic mensuration. In the previous video, we solved a question on cones developed from the sector of a circle. In this video, we are going to consider a sphere and hemisphere. Sphere. A typical example of a sphere is a football, as you can see in this picture. If we have a sphere and we draw a line from the center of the sphere to a point on the sphere, that line is called the radius of the sphere. So in this diagram here, r represents the radius of the sphere. That is the distance from the center of the sphere to a point on the sphere. The formula for finding the surface area of a sphere is 4 pi r squared, where r is the radius of the sphere. And the formula for finding the volume of the sphere is 4 divided by 3 pi r cubed, where r is the radius of the sphere. So to find the surface area of a sphere, the formula is 4 pi r squared. And to find the volume, the formula is 4 divided by 3 pi r cubed. A hemisphere is half of a sphere. So for example, if we cut this football here into 2 equal parts, a half of it is called a hemisphere. So we have in this diagram here a hemisphere with r as the radius. Since a hemisphere is half of a sphere, the formula for finding the surface area of a hemisphere is equal to half times the formula for finding the surface area of a sphere, which is 4 pi r squared. So the formula for finding the surface area of a hemisphere is equal to half times 4 pi r squared, which will give us 2 pi r squared. In the same way, the formula for finding the volume of a hemisphere is equal to 1 divided by 2, or half times 4 divided by 3 pi r cubed. So since the hemisphere is half of a sphere, the volume of the hemisphere will be half of that of a sphere, which is half times 4 divided by 3 pi r cubed, and this will give us 2 divided by 3 pi r cubed. So for a hemisphere, the surface area is pi r squared, 2 pi r squared, and the volume is 2 divided by 3 pi r cubed. These are the formulas that we are going to use to solve questions on spheres and hemispheres. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to use the formulas that we've studied in this video to solve questions on spheres and hemispheres. Bye-bye. We are on the topic mensuration. In the previous video, we studied how to find the surface area and volume of a sphere and hemisphere. In this video, we are going to solve a question on finding the surface area and volume of a sphere. The question for this video is, the diameter of a sphere is 28 centimeters. Find the surface area and volume of the sphere. Give your answer in terms of pi. So you have been given the diameter of the sphere as 28 centimeters. We learned that the radius is equal to diameter divided by 2. So radius r is equal to diameter, which is 28 centimeters divided by 2, and that will give us 14 centimeters. That means that the radius of this sphere is 14 centimeters. In the previous video, we learned that the surface area of a sphere is equal to 4 pi r squared, where r is the radius of the sphere. So for this sphere, the surface area is equal to 4 times pi times 14 centimeters squared. Remember, the question said we should leave our answer in terms of pi. So you have 4 times 14 squared times pi, and that will give us 784 pi centimeters squared. So the surface area of this sphere is 784 pi centimeters squared. We are also going to find the volume of the sphere. We learned in the previous video that the volume of a sphere is equal to 4 divided by 3 pi r cubed, where r is the radius of the sphere. So the volume is equal to 4 divided by 3 times pi times 14 centimeters cubed. The question said we should leave our answer in terms of pi. So you have 4 divided by 3 times 14 cubed times pi, and this will give us 3658.67 pi centimeters cube. So we can say that the volume of the sphere in terms of pi is 3658.67 pi centimeters cube. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the volume and surface area of a sphere. Bye-bye. We are on the topic mensuration. In the previous video, we solved a question on finding the surface area and volume of a sphere. We are going to solve another question in this video. The question for this video is, the surface area of a sphere is 1848 centimeters squared. What is its radius and volume? So we have been given the surface area as 1848 centimeters squared, and we are going to find the radius and volume of the sphere. In the first video on spheres and hemispheres, we learned that the surface area of a sphere is equal to 4 pi r squared. We have been given the surface area of the sphere in the question. So we can say that 1848 centimeters squared is equal to 4 pi r squared. We want to find r, and that is the radius of the sphere. In order to do that, we will divide the left hand side by 4 pi and we will divide the right hand side by 4 pi. So when we do that, you will see that 4 pi and 4 pi will cancel out. That means that r squared is equal to 1848 divided by 4 pi. So r squared is equal to 147.06 centimeters squared. 1848 divided by 4 pi will give us 147.06 centimeters squared. To find r, we take square roots of both sides. So you take square root of the left hand side and you take square root of the right hand side. And r is equal to 12.1 centimeters. That means that the radius of the sphere is 12.1 centimeters. The question said we should find the volume of the sphere. We have the radius r as 12.1 centimeters. Volume of a sphere is equal to 4 divided by 3 pi r cubed. R is 12.1 centimeters. So you have 4 divided by 3 times pi times 12.1 centimeters cubed. And when you do this on your calculator, you have 7420.70 centimeters cubed. So the volume of the sphere is 7420.70 centimeters cubed. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the surface area and volume of a hemisphere. Bye-bye. We are still on the topic mensuration. In the previous video, we solved a question on finding the surface area and volume of a sphere. In this video, we are going to solve a question on finding the surface area and volume of a hemisphere. Find the surface area and volume of a hemisphere of radius 7 centimeters. Take pi as 22 divided by 7. So in this question, we have been given pi as 22 divided by 7, and the radius of a hemisphere as 7 centimeters. And we are supposed to find the surface area and volume of this hemisphere. In the first video on spheres and hemispheres, we learned that a hemisphere is half of a sphere. So if the radius is 7 centimeters, the surface area of a sphere is equal to a hemisphere is equal to 2 pi r squared, and this is half of that of a sphere because the surface area of a sphere is 4 pi r squared, and since the hemisphere is half of a sphere, the surface area of the hemisphere is 2 pi r squared, and r is 7 centimeters. So you have 2 times pi is 22 divided by 7 times 7 centimeters squared, and this will give us 308 centimeters squared. So the surface area of the hemisphere is 308 centimeters squared. The question also said we should find the volume of the hemisphere, and the volume of a hemisphere is 2 divided by 3 pi r cube, where r is the radius of the hemisphere. So the volume of this hemisphere is equal to 2 divided by 3 times, the question said we should take pi as 22 divided by 7. So 2 divided by 3 times 22 divided by 7 times 7 centimeters cube. So we are going to have 2 divided by 3 times 22 divided by 7 times 7 cube, and that will give us 718.67 centimeters cube. So the volume of the hemisphere is 718.67 centimeters cube. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to consider another solid figure. The solid figure we'll be considering is a pyramid. So we will learn how to find the total surface area and volume of a rectangular pyramid and a triangular pyramid. Bye-bye. We are on the topic mensuration. In the previous video, we learned how to find the total surface area and volume of a pyramid. In this video, we are going to solve a question on a rectangular pyramid. Let's consider the question for this video. The diagram below shows a pyramid with vertex O, stands on a square base ABCD, and OA is equal to OC is equal to OD is equal to OB and is equal to AB, and they are all 5 centimeters. We have been given 4 questions here to calculate, and we will do the first one in this video. So we are being told to calculate the height of the pyramid, the total surface area of the pyramid, the volume of the pyramid, the angle between the plane OAB and the base of the pyramid. We will solve the first one, which is the height of the pyramid, in this video. So from the diagram, from the question, we are being told that OA is equal to OC and is equal to OD, and that is equal to OB is equal to AB, and they are all 5 centimeters. What that means is that OA is 5 centimeters, OB is 5 centimeters, OC is 5 centimeters, and OD is also 5 centimeters. The question also said that the base of the pyramid is a square. If the base of the pyramid is a square, what it means is that AB is 5 centimeters, BC is 5 centimeters, DC is 5 centimeters, and AD is 5 centimeters. Okay, so we are supposed to calculate the height of the pyramid. Remember that in this diagram, OH represents the height of the pyramid. That is the distance from the vertex of the pyramid to the center of the square base. H is at the center of the square base and O is the vertex of the pyramid. That means that if we draw the square base here, we have A, B, C, D. AB is 5 centimeters, BC is 5 centimeters, DC is 5 centimeters, and AD is also 5 centimeters, and H is at the center of the pyramid. So how do we find the distance OH? Now look at something here. If we draw a line from point A to meet H, it's going to meet the line OH at right angle, or the angle that will be created here will be 90 degrees. That means that with the points O, A, H, we can form a right-angled triangle and use the Pythagoras theorem to find OH. OAH will give us a right-angled triangle, and using the Pythagoras theorem, we will be able to find OH. We already know that OA is 5 centimeters. So to help us find OH, we need to find AH. From the diagram here, we have said that H is at the center of the square base. What that means is that if we're able to find the distance AC, the distance from A to C, that is the diagonal of the square, half of it will give us AH since H is at the center. So to help us find AH, we are going to find AC because half of AC will give us AH. So this is the square base. AC is the diagonal. With the points A, B, C, we will form this right angle triangle here, ABC, with AB as 5 centimeters and BC as 5 centimeters. If we apply the Pythagoras theorem here, we will have AC squared is equal to AB squared plus BC squared. Remember, we are looking for AC. We have AB and BC. So AC squared is equal to 5 squared plus 5 squared. You simplify this and AC is equal to 7.1 centimeters. So the length of the diagonal of the square base is 7.1 centimeters. Now let's use this to continue solving the question. So we have been able to find AC as 7.1 centimeters. We are interested in finding AH. We have seen that AH is half of 7.1 centimeters since H is at the center of the square base. So the distance AH is 7.1 centimeters divided by 2, and that will give us 3.55 centimeters. 7.1 divided by 2 is 3.55. So what that means is that the distance from A to H, which is half of AC, will give us 3.55 centimeters. So from A to H is 3.55 centimeters. Now with the points O, A, H, we can form this right angled triangle OAH with OA as 5 centimeters and AH as 3.55 centimeters. Remember, we are looking for OH, which is the height of the pyramid. So we apply the Pythagoras theorem on this right angle triangle. We will have AO squared or OA squared is equal to AH squared plus HO squared. We are looking for HO, which is the height of the pyramid. We have AO as 5 centimeters and AH as 3.55 centimeters. So 5 squared is equal to 3.55 squared plus HO squared. You simplify this, you have 5 squared minus 3.55 squared is equal to HO squared. And HO squared is equal to 12.3975. So you take square root of both sides to find HO, and HO is equal to 3.5 centimeters. What this means is that the height of the pyramid is 3.5 centimeters. The question also said that we should find the total surface area of this pyramid. We will do that in the next video. So see you in the next video and let's continue solving this question. Welcome back. In the previous video, we started solving this question and we considered the first part, that is the height of the pyramid, and we got 3.5 centimeters. In this video, we are going to concentrate on the second part, that is finding the total surface area of the pyramid. So the total surface area of the pyramid. In the first video on pyramids, we learned that the total surface area of a rectangular pyramid is equal to the area of the rectangular base plus the area of the triangular faces. The base of this pyramid is a square, so the total surface area of this pyramid is going to be the area of the square base plus area of the triangular faces. This is the net of the pyramid. So if you open up this pyramid, we are going to have a figure like this, where A, B, C, D is the base of the pyramid, and these are the triangular faces. So to find the total surface area of this pyramid, we need to find area of the square base, then we find area of each of these triangles and we add them together. Let's first begin with the square base. A, B, C, D is the square base. it has the length of the side as 5 centimeters. We know that area of a square is equal to length times length. Here the length is 5 centimeters. So area of the square is equal to 5 centimeters times 5 centimeters, and that will give us 25 centimeters squared. So the area of the square base is 25 centimeters squared. We are done with the base. We now concentrate on the triangular faces. If you look at these triangles very well, I'm going to call this first one here triangle 1. I'll call this triangle 2. I'll call this one triangle 3. And I'll call this triangle 4. You can see that all these triangles, triangle 1, 2, 3, 4, have the same dimensions. They are all equilateral triangles with sides 5 centimeters. So all that you need to do is to find the area of just one of them, and you multiply your answer by 4. Because area of triangle 1 will be the same as area of triangle 2, and to be the same as area of triangle 3, it will be the same as area of triangle 4. So if I'm able to find area of triangle 1 and multiply the answer by 4, I'll get the area of all the triangles. So let's pick one of them and find its area. So I'm going to pick the triangle OAB. So triangle OAB. For triangle OAB, the side OA is 5 centimeters, as you can see here. The base AB is 5 centimeters also. In the video on triangles, we learned how to find the area of an equilateral triangle. We learned that the area of a triangle is equal to half times base times height. So for this triangle, we have the base. What we need to do is to find the height. If we draw a line from O to meet AB, I'll call the meeting place point M. The angle created there will be 90 degrees. This perpendicular line is the height of the triangle. We learned how to find this when we were finding the area of an equilateral triangle under triangles. So OM is the height of this triangle. OM will also bisect the line AB. That means that it will divide the line AB into 2 equal parts. So from A to M will be half of 5 centimeters, which is 2.5 centimeters. And from M to B is also half of 5 centimeters, which is 2.5 centimeters. Now, if you consider the points OAM, you will see that it forms this right angle triangle OAM, with OA as 5 centimeters and AM as 2.5 centimeters. And OM is the height of the triangle. So we can apply the Pythagoras theorem here to find OM. When we do that, you will see that AO squared is equal to AM squared plus MO squared. Remember, we are looking for MO or OM. So we have 5 squared is equal to 2.5 squared plus MO squared. When you simplify this, you are going to have MO is equal to 4.3 centimeters. What that means is that the height of the triangle is 4.3 centimeters. Okay, so the height of the triangular faces is 4.3 centimeters. Now, we have the base to be 5 centimeters and we have the height to be 4.3 centimeters. So we can find the area. Remember, the area of this triangle will be the same as the area of this triangle, and to be the same as area of this triangle, it will also be the same as area of this triangle. So, area of all the triangular faces is equal to 4 times the area of this triangle, which is 4 times half times base, which is 5 centimeters, times the height, that is 4.3 centimeters. And this will give us 43 centimeters squared. So half times base, which is 5 centimeters, times height 4.3 centimeters is the area of this triangle. But since we have 4 identical triangles, the area of all the triangles will be 4 times half times 5 centimeters times 4.3 centimeters, and that will give us 43 centimeters squared. So the total surface area is equal to area of the square base, which we have already found, plus area of the triangular faces, which we have found here. Area of the square base, we found that to be 25 centimeters squared, and we have just found area of the triangular faces as 43 centimeters squared. So the total surface area of this pyramid is equal to 25 centimeters squared plus 43 centimeters squared, and that will give us 68 centimeters squared. So the total surface area of the pyramid is 68 centimeters squared. The question said we should find the volume of the pyramid, and we are going to do that in the next video. So see you in the next video, and let's continue solving this question. Welcome back. We are still on this question. We have solved the first and second part of this question in the previous videos. In this video, we will solve the third and final part, that is the volume of the pyramid and the angle between the plane OAB and the base of the pyramid. In the first video on pyramids, we learned that the volume of a pyramid is equal to 1 divided by 3 times area of the base times height. Since the base of this pyramid is a square, it's going to be 1 divided by 3 times area of the square base times the height of the pyramid. We have found out that area of the square base is 25 centimeters squared and height of the pyramid is 3.5 centimeters. So the area of this pyramid is equal to 1 divided by 3 times 25 centimeters squared times 3.5 centimeters. And this will give us 29.2 centimeters cube. So the area of this pyramid is 29.2 centimeters cube. The question also said we should find the angle between the plane OAB and the base of the pyramid. So we are referring to this plane OAB and the base of the pyramid. The plane OAB will create an angle with the base of the pyramid. To help us do that, you draw a line from the vertex O to the middle of the line AB. So from O to the middle of the line AB, and I'll call the point where that line will meet AB point M. If you draw that line, you will see that there will be an angle created between this line, the line you've drawn, and the base of the pyramid. That is the angle the question wants us to find. So we are going to look for the value of that angle. To help us do that, I'll join the point M to the point H. So from point M to point H. If you join point M to point H, the angle created here will be 90 degrees or a right angle, which means that if we are able to find MH and OH, we can use one of the trig ratios to find this angle here. That is the angle between the plane OAB and the base of the pyramid. So how do we do that? Let's proceed. Let theta equal to the angle between the plane OAB and the base. So this is the angle theta. This angle theta here is the angle between the plane OAB and the base of the pyramid, just as you can see in this diagram. We know that OH is the height of the pyramid. We have found out that that is 3.5 centimeters. So we need to find MH. This is the base of the pyramid, A, B, C, D. H is at the center of the pyramid. That means that from M to H will be half of BC. Since H is at the center of the pyramid, from M to H will be the same as half of this distance here, BC. BC is 5 centimeters, so half of 5 centimeters will be 2.5 centimeters. So from M to H, we know that H is at the center, so it means that from M to H is the same as dividing this into 2 equal parts. That means that from M to H is half of BC, which is 5 centimeters, and that will give us 2.5 centimeters. So now we have, I'm going to clean this so that you can write here. So now we have MH, we also have OH. and the angle created here is 90 degrees, which means that we can use our trig ratios to find the value of theta. If we pick the points O, M, H, we will form this right angle triangle here with MH as 2.5 centimeters and OH as 3.5 centimeters. That is the height of the pyramid. We are looking for theta. 3.5 centimeters is opposite to theta and 2.5 centimeters is adjacent to theta. So we are looking for theta and we have opposite and adjacent. We are going to use tan because tan theta is equal to opposite divided by adjacent. So from this diagram, tan theta is equal to opposite, which is 3.5 centimeters, divided by the adjacent, which is 2.5 centimeters. And so theta is equal to tan inverse of 3.5 divided by 2.5. And that will give us 54.5 degrees. So we can see that the angle between the plane OAB and the base of the pyramid is 54.5 degrees. The angle between the plane OAB and the base of the pyramid is 54.5 degrees. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the volume and total surface area of a triangular pyramid. Bye-bye. We are on the topic mensuration. In the previous video, we solved a question on rectangular pyramids. In this video, we are going to solve a question on triangular pyramids. The question for this video is: PQRV is a right pyramid with a base PQR, which is an equilateral triangle of size 18 centimeters. Each sloping edge of the pyramid is of length 13 centimeters. G is the center of symmetry of PQR. Given that PG is equal to 10.4 centimeters, calculate I, the angle between PV and the base. Correct your answer to the nearest degree. II, height of the pyramid. III, total surface area of the pyramid. And IV, volume of the pyramid. So you have been given the pyramid PQRV. Now, because it has a triangular base, this is a triangular pyramid. The question told us that PQR, which is the base of the pyramid, is an equilateral triangle of size 18 centimeters. That means that PQ is 18 centimeters, QR is 18 centimeters, and PR is also 18 centimeters. It also says that each sloping edge of the pyramid is 13 centimeters, meaning that PV is 13 centimeters, RV is 13 centimeters, and QV is also 13 centimeters. It goes on further to tell us that G is the center of the pyramid. So G is the center of the triangle PQR. So the center of triangle PQR is G. And the distance from P to G, as we can see in this diagram here, is 10.4 centimeters. And we are supposed to calculate the angle between PV and the base. We should calculate the height of the pyramid, the total surface area of the pyramid, and the volume of the pyramid. We will solve the first two questions in this video. So let's begin with the first one, the angle between PV and the base. As we just saw from the question, it is said that each of the sloping surface is 13 centimeters. That means that PV is 13 centimeters. The question also told us that PQ is 10.4. Sorry, the question also told us that PG is 10.4 centimeters. So 10.4 centimeters. Now we are supposed to find the angle between PV and the base. So we have PV here and the base PQR. From the diagram here, the angle, if we let the angle between PV and the base, if we let theta represent the angle between PV and the base, we can indicate theta on the diagram as the angle that we have here. Now this is PV, and PQR is the base. So it means that the angle between PV and the base is this angle here, represented by theta, as we can see from the diagram. So how do we find theta? We have PV, we have PG, and GV. If we pick these 3 points, P, V, P, G, it forms a right-angled triangle, as we can see here. So P, V, G, where PV is 13 centimeters, PG is 10.4 centimeters, and we are looking for theta. From this diagram here, we can see that 10.4 centimeters is adjacent to theta, and PV is the hypotenuse. So 10.4 centimeters, which is PG, is adjacent to theta. PV, that is 13 centimeters, is the hypotenuse. So we are looking for theta. We have adjacent and hypotenuse. We are going to use cos. So cos theta is equal to adjacent 10.4 centimeters divided by the hypotenuse 13 centimeters. To find theta, we are going to find cos inverse of 10.4 divided by 13. So theta is equal to cos inverse of 10.4 divided by 13. And theta will give us 37 degrees. Remember, the question said we should correct our answer to the nearest degree. So if you find this on your calculator and you correct your answer to the nearest degree, you will have theta to be 37 degrees. So the angle between PV and the base is 37 degrees. The next part of the question said we should find the height of the pyramid. From this diagram here, VG is the height of the pyramid. VG is the height of the pyramid. So if we pick the points PVG, we will have this right angle triangle here, PVG, and the angle at P here as theta. But we have just found out that theta is 37 degrees. So the angle here, which is theta, is now 37 degrees. From this diagram, as we've said, VG is the height of the pyramid. So we have this angle here, which is 37 degrees. We have PV as 13 centimeters, PG as 10.4 centimeters, and we are looking for VG. So here you have the option of either using the Pythagoras theorem to find VG, since you already have PG and PV, or you can use one of the trigonometric ratios to also find VG. You can use either one of them and you will still be correct. So here I'm going to use tan. Tan 37 degrees will give us opposite, which is VG, divided by adjacent, which is PG. Somebody can also decide to use cos. Somebody can also decide to use sine, because sine 37 degrees will give us opposite, which is VG, divided by hypotenuse, that is 13 centimeters, and you are still going to get the same answer. Here I'm going to use tan. Tan 37 degrees is equal to opposite, that is VG, divided by the adjacent, which is 10.4 centimeters. So tan 37 degrees is equal to VG divided by 10.4. To find VG, I'll multiply the left hand side by 10.4 and the right hand side by 10.4. So you have 10.4 here cancelling 10.4, meaning that VG is equal to 10.4 tan 37 degrees. If you find this on your calculator, you have VG to be 7.8 centimeters. That means that the height of the pyramid is 7.8 centimeters. The question said we should find the total surface area and volume of the pyramid. We are going to do that in the next video. So see you in the next video, and let's continue solving this question. Welcome back. We started solving this question in the previous video, and we have considered the first and second parts. In this video, we are going to consider the third and fourth part, that is the total surface area of the pyramid and the volume of the pyramid. Let's begin with the total surface area. In the first video on pyramids, we learned that the total surface area of a pyramid is equal to area of the base plus area of the triangular faces. So the total surface area of this triangular pyramid is equal to area of the triangular base plus area of the triangular faces. The question told us that the base of this pyramid is an equilateral triangle. So PQR will have the same sides. That means that if PR is 18 centimeters, then PQ is 18 centimeters and QR is also 18 centimeters. The question also said that each of the sloping surface is 13 centimeters. So if PV is 13 centimeters, then QV is also 13 centimeters and VR is also 13 centimeters. That means that if we draw the net of this pyramid, we are going to have PQR as the base with 18 centimeters, 18 centimeters, and 18 centimeters. Then we will have these three triangular faces. If you look at them, if you look at the three triangular faces very well, you will see that I'm going to call this one 1, 2, and 3. You will see that each of these triangular faces have a base of 18 centimeters and the length of the sides as 13 centimeters. So they will all have the same area. That means that if I'm able to find area of the triangular base, I'll just need to find area of one of the triangular faces and multiply it by 3, because the area of 1 will be the same as area of 2 and area of 3. So I'll just need to find area of just one of them, then I'll multiply my answer by 3. So I'll begin by finding area of the triangular base. The base is PQR. It's an equilateral triangle. So the lengths PQ, QR, and PR are all 18 centimeters, just as the question has told us. It means that the base is 18 centimeters. So we need to look for the height of the triangle. Okay, if we draw a line from Q to meet PR, I'll call the meeting point point M. The line OQ is the height of this triangle. OQ will divide PR into two. It means that PM is equal to MR. So PM is 9 centimeters and MR is also 9 centimeters. If we pick the points PQM, we will form this right angle triangle here. Remember, we are looking for QM, which is the height of the triangle. We will apply the Pythagoras theorem here. So PQ squared is equal to PM squared plus MQ squared. We are looking for MQ. So you have 18 squared plus 9 squared is equal to MQ squared. If you simplify this, MQ is equal to 15.6 centimeters, meaning that the height of the triangular base is 15.6 centimeters. Now, we have the height of the triangle and the base of the triangle. Formula for finding the area of a triangle is equal to half times base, which is 18 centimeters, times height, which is 15.6 centimeters. So the area of the triangular base is 140.4 centimeters squared. Let's go on to the triangular faces. We are done with the triangular base. Just as I've already said, the area of these triangular faces will all be the same. So you need to find just one of them. Okay, so I'm going to pick the face PVR. So I'm picking this face PVR. The base is PR, that is 18 centimeters. PV is 13 centimeters and VR is also 13 centimeters. We are interested in finding the height. If we draw a line from V to this line here, PR, the line VM will be the height of this triangle. To find VM, we are going to pick the points PVM. We know that VM will divide PR into two equal parts. So PM is 9 centimeters and MR is also 9 centimeters. So if you pick the points PVM, we will form this right angled triangle. We apply the Pythagoras theorem here to find VM or MV, which is the height of this triangle. This will give us 13 squared is equal to 9 squared plus MV squared. So if you simplify this and you find MV is equal to 9.4 centimeters. It means that the height of this triangular face is 9.4 centimeters. That means that the height of all the triangular faces is also 9.4 centimeters. Now, we have three triangular faces. Each of them will have a base of 18 centimeters and a height of 9.4 centimeters. So the area of all the triangular faces is equal to 3 times the area of this triangular face, which is half times the base, that is 18 centimeters, times the height, which is 9.4 centimeters. So half times 18 centimeters times 9.4 centimeters is the area of this triangle. But since we have three identical triangles, the total area is equal to 3 times half times 18 centimeters times 9.4 centimeters. This will give us 253.8 centimeters squared. So the area of all the triangular faces is 253.8 centimeters squared. Now let's move on to the area, the total surface area of the pyramid. At the beginning we said it is the area of the triangular base plus area of the triangular faces. We found out that area of the triangular base is 140.4 centimeters squared, and area of the triangular faces is also 253.8 centimeters squared. If you add this, you are going to have 394.2 centimeters squared. So the total surface area of the pyramid is 394.2 centimeters squared. The question said we should find the volume of the pyramid. Since this is a triangular pyramid, the volume of the pyramid is equal to 1 divided by 3 times area of the triangular base times the height of the pyramid. Area of the triangular base is 140.4 centimeters squared. Height of the pyramid is 7.8 centimeters. So the volume of the pyramid is equal to 1 divided by 3 times 140.4 centimeters squared times 7.8 centimeters. You simplify this, or you find this on your calculator, and you are going to have 365.04 centimeters cube. So the volume of this pyramid is 365.04 centimeters cube. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve questions on finding the area and the total surface area and volume of composite figures. Bye-bye. We are still on the topic mensuration. In the previous video, we solved a question on finding the total surface area and volume of a triangular pyramid. In this video, we are going to solve a question on finding the total surface area and volume of composite shapes. The question for this video is, the model in the figure below is made up of a cylinder with a closed base and a hollow cone. The cone fits directly to the open end of the cylinder. Calculate, correct to the nearest whole number, I, the volume of the model, II, the total surface area of the model. In the video on plane figures, I explained composite figures. When you have two figures put together to form a single figure, the resulting figure is called a composite figure. A typical example is what you have here. We have a cone on top of a cylinder. The question says that the end of the cylinder is closed and the cone is also hollow. So the open part of the cone fits onto the open part of the cylinder. So the base of the cylinder here is closed. The diameter of the cylinder is 14 centimeters. The height of the cylinder is 30 centimeters and the height of the cone is 15 centimeters. The question says we should find the volume of the model, this model here, and the total surface area of this model. We will solve the first part in this video, then we will solve the second part in the next video, and we are to take pi as 22 divided by 7. So, volume of the model. To find the volume of this model, we split it into the two individual models that we have here. So here, to find the volume of this figure, we will split it into the two individual figures we have. That is the cylinder and the cone. So the volume of this model is equal to volume of the cylinder plus volume of the cone. So you will first need to find the volume of the cylinder. From the diagram here, we can see that the cylinder has a height of 30 centimeters and a diameter of 14 centimeters. From the video on cylinders, we learned that the volume of a cylinder is equal to pi r squared h, where h is the height of the cylinder and r is the radius of the cylinder. So in this diagram, we have been given the diameter of the cylinder as 14 centimeters, but we know that radius is equal to diameter divided by 2. So if the diameter is 14 centimeters, then the radius is equal to 14 centimeters divided by 2, which is 7 centimeters. The height of the cylinder is 30 centimeters. So we now have the height of the cylinder and radius of the cylinder. So we can find the volume of the cylinder, which is pi r squared h. The question said we should take pi as 22 divided by 7. So we have 22 divided by 7 times r squared, 7 centimeters squared, times h, which is 30 centimeters. When you do this on your calculator, you will have 4620 centimeters cube. So the volume of the cylinder is 4620 centimeters cube. We now have to find the volume of the cone. Volume of the cone. From the videos on cones, we learned that the formula for finding the volume of a cone is equal to 1 divided by 3 times pi r squared h. Now, the question told us that the cone fits directly onto the cylinder. That means that the distance from here to here, that is the diameter of the cylinder, which we have as 14 centimeters, is the same as the diameter of the cone, since the cone fits directly onto the cylinder. So the diameter of the cylinder will be the same as the diameter of the cone, meaning that if point O is the center of the circular base of the cone and A is a point on the circular base of the cone, and we draw a line from O to A, this line here is going to be the radius of the cone. And since the diameter of the cylinder is the same as the diameter of the cone, then it means that the diameter of the cone is also 14 centimeters. So the radius of the cone is going to be 14 centimeters divided by 2, since radius is equal to diameter divided by 2. We have been given the height of the cone here, that is from the center to the vertex, as 15 centimeters. So from the center to the vertex is also 15 centimeters. So now we have the radius of the cone as 7 centimeters and height of the cone as 15 centimeters. So we can find the volume. So the volume of this cone is equal to, we have the radius as 7 centimeters and height as 15 centimeters. The volume is equal to 1 divided by 3 times pi is 22 divided by 7 times r is the radius, that is 7 centimeters squared, times height, which is h, 15 centimeters. You simplify this on your calculator, or you find this on your calculator, and you will have 770 centimeters cube. Remember, the question told us to write our answer to the nearest whole number, so 770 centimeters cube. So we now have the volume of the cone. We also have the volume of the cylinder. So the volume of the model is equal to volume of the cylinder plus volume of the cone. Volume of the cylinder is 4620 centimeters cube. Volume of the cone is 770 centimeters cube. So the volume of the model is equal to 4620 centimeters cube plus 770 centimeters cube. And this will give us 5390 centimeters cube. So the volume of the model is 5390 centimeters cube. The question said we should find the total surface area of the model. We are going to do that in the next video. So see you in the next video and let's continue solving this question. Welcome back. We started solving this question in the previous video and we solved the first part, that is calculating for the volume of the model. In this video, we are going to consider the second part, that is the total surface area of the model. The total surface area of the model is equal to the total surface area of the cylinder plus the total surface area of the cone. So if we find the total surface area of the cylinder and we add it to the total surface area of the cone, we are going to get the total surface area of the model here. Let's first deal with the cylinder. This is a cylinder with one end open. Remember, the question said that the base of the cylinder is closed and the top part here is open. So the formula for finding the total surface area of a cylinder with one end open is pi r squared plus 2 pi r h, where r is the radius of the cylinder and h is the height of the cylinder. The radius of the cylinder is 7 centimeters since the diameter is 14 centimeters. And the height of the cylinder, we can see from this diagram that it is 30 centimeters. So the total surface area of the cylinder is equal to pi r squared plus 2 pi r h. The question said we should take pi as 22 divided by 7. So you have 22 divided by 7 times 7 centimeters squared plus 2 times 22 divided by 7 times 7 centimeters times 30 centimeters. And this will give us 1474 centimeters squared. So the surface area of the cylinder, that's the total surface area of the cylinder, is 1474 centimeters squared. We are done with the cylinder. Let's move on to the cone. The total surface area of the cone. To find the total surface area of the cone, we need the slant height, VA. In the previous video, we were able to see that the diameter of the cylinder here will be the same as the diameter of the cone. So it means that the diameter of the cone is 14 centimeters. That means that the radius is 7 centimeters. So from O, which is the center of the cone, to A is 7 centimeters. And from V to O, which is the height of the cone, is 15 centimeters. The height of the cone and the radius of the cone will meet at right angle or 90 degrees. So if we pick the points VOA, we are going to form this right angle triangle VOA with VO as 15 centimeters and OA as 7 centimeters. We are looking for VA, which is the slant height of the cone. So we can apply the Pythagoras theorem here. We will have VA squared is equal to VO squared plus OA squared. We are looking for VA. So VA squared is equal to 15 squared plus 7 squared. And if you simplify this, you are going to have VA is equal to 16.55 centimeters. So we can say that the slant height of the cone, which is VA, is 16.55 centimeters. So now we have the slant height. We know that this is a hollow cone. That means that the base of the cone is open. So the total surface area of a hollow cone is equal to pi RL, where R is the radius of the circular base and L is the slant height of the cone. So here R is 7 centimeters and L is 16.55 centimeters. So the surface area of this cone is equal to 22 divided by 7 times 7 centimeters times 16.55 centimeters, which will give us 364 centimeters squared. So the surface area, or the total surface area of the cone, is 364 centimeters squared. Now we have the surface area of the cylinder as 1474 centimeters squared and the surface area of the cone as 364 centimeters squared. So the total surface area of the model is equal to the surface area of the cylinder plus surface area of the cone. That means that the total surface area of the model is equal to 1474 centimeters squared plus 364 centimeters squared. And this will give us 1838 centimeters squared. So the total surface area of the model is 1838 centimeters squared. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the total surface area and volume of composite shapes. Bye-bye. We are still on the topic mensuration. In the previous video, we solved a question on finding the total surface area and volume of a composite shape. In this video, we are going to solve another question. The question for this video is: a cylindrical piece of metal of diameter 6 meters and height 10 meters is melted completely and recast into the shape of a child's toy. The toy consists of a right solid circular cone mounted on top of a hemisphere. The base of the cone fits exactly to the plane face of the hemisphere. The height of the cone is 4 times the radius of the hemisphere. Calculate, correct to 2 decimal places. 1. The radius of the hemisphere. 2. The volume of the cone. And 3. The total surface area of the toy. So there was this metal in the shape of a cylinder. And the cylinder had a diameter of 6 meters and a height of 10 centimeters. This cylinder was then melted and recast into the shape of a toy. The picture here shows us the toy. The toy consists of a cone mounted on top of a hemisphere. So the toy consists of a cone on a hemisphere. The question goes on to say that the base of the cone fits exactly to the face of the hemisphere. So just as you can see here, the circular base of the cone fits exactly on top of the hemisphere. The height of the cone is 4 times the radius of the hemisphere. So you can see from here that because the cone fits exactly on top of the hemisphere, the radius of the cone is going to be the same as the radius of the hemisphere. And the question also says that the height of the cone is 4 times the radius of the hemisphere. And we are supposed to calculate the radius of the hemisphere, the volume of the cone, and the total surface area of the toy. We will solve the first question in this video, then we will solve the others in the next video. So the radius of the hemisphere. Now, this is what the question wants to tell us. There is this cylinder with diameter 6 centimeters and height 10 centimeters. This cylinder was melted, then it was recast or remolded to form this toy here. So you can see from here that the volume of the cylinder here will be the same as the volume of the toy, because it was this cylinder that was melted to form the toy. So the volume of the cylinder will be the same as the volume of the toy. And the volume of the toy will be the volume of the cone plus volume of the hemisphere. So let's go ahead and find volume of the cylinder. This cylinder here has a diameter of 6 centimeters and a height of 10 centimeters. We know that the volume of a cylinder is equal to pi r squared h, where r is the radius of the cylinder and h is the height of the cylinder. Since the diameter is 6 centimeters, the radius will be half of the diameter, that is 3 centimeters. So the volume of this cylinder is equal to pi times 3 centimeters squared times 10 centimeters. And this will give us 282.74 centimeters cubed. So the volume of this cylinder is 282.74 centimeters cube. That means that the volume of the toy is also 282.74 centimeters cube. Now, how do we find the volume of the toy? The toy consists of a cone and a hemisphere. So the volume of the toy is going to be the volume of the cone plus volume of the hemisphere. Because the cone fits directly onto the hemisphere, the radius of the cone will be the same as the radius of the hemisphere. We know that volume of a cone is equal to 1 divided by 3 pi r squared h, and volume of a hemisphere is equal to 2 divided by 3 pi r cubed. So here, the r here is the radius of the hemisphere and is the same as the radius of the cone. The question told us that the height of the cone is 4 times the radius of the hemisphere. That means that h here, which is the height of the cone, is equal to 4 times r, which is the radius of the hemisphere. So h is equal to 4r. So we can replace the h that we have in the volume of a cone with 4r. If we do that, you have volume of the cone is equal to 1 divided by 3 times pi r squared times, this time instead of h, we know that h is 4r, so times 4r. And this will give us 4 divided by 3 pi r cubed. So now we have the volume of the cone in terms of r. We also have the volume of the hemisphere in terms of r. But we know that the volume of this toy here will be the same as the volume of the cone plus volume of the hemisphere. Volume of the cone in terms of r is now 4 divided by 3 pi r cubed, and volume of the hemisphere is 2 divided by 3 pi r cubed. So if you add these two, you see that you have 4 pi r cubed divided by 3 plus 2 pi r cubed divided by 3. Since they have the same denominators, we can add the numerator straight away. We learned this in fractions. So you add 4 pi r cubed to 2 pi r cubed. From algebra, 4 pi r cubed plus 2 pi r cubed will give us 6 pi r cubed. So we have 6 pi r cubed divided by 3. 3 will cancel itself 1 and cancel 6 2 times. So you will have 2 pi r cubed. That means that volume of the cone plus volume of the hemisphere is 2 pi r cubed. We also know that the volume of the cylinder is 282.74 centimeters cube. And we have just found out that volume of the cone plus volume of the hemisphere is equal to 2 pi r cubed. Remember that volume of the cylinder is the same as volume of the toy, and volume of the toy is equal to volume of the cone plus volume of the hemisphere. So we can equate these two. So we are going to equate 282.74 centimeters cube and 2 pi r cubed, since they are the same thing, because volume of the cylinder is the same as volume of the toy, which is 282.74 centimeters cube, and volume of the cone plus volume of the hemisphere is also the same as volume of the toy. That means that volume of the cylinder is equal to volume of the cone plus volume of the toy plus volume of the hemisphere. Volume of the cylinder is 282.74 centimeters cube, and volume of the cone plus volume of the hemisphere is 2 pi r cubed. We want to find r, which is the radius of the cone and the hemisphere. So we will divide the left hand side by 2 pi, and we will divide the right hand side also by 2 pi. When you do that, you are going to see that 2 pi and 2 pi will cancel. So you will have r cubed is equal to 282.74 divided by 2 pi, and that will give us 45. So 282.74 divided by 2 pi will give us 45. So you have 45 centimeters cube. So you take the cube root of r cubed and you take the cube root of 45. So cube root of r cubed then cube root of 45. That will give us, if you take cube root of r cube, you are going to get r. If you take cube root of 45, you have 3.56. So the radius is equal to 3.56 centimeters. That means that the radius of the hemisphere, which is the same as the radius of the cone, is 3.56 centimeters. The question said that we should find the volume of the cone and total surface area of the toy. We are going to do that in the next video. So see you in the next video, and let's continue solving this question. Welcome back. We started solving this question in the previous video. We considered the first part, which is the radius of the hemisphere, and we got 3.56 centimeters. In this video, we are going to solve the second and third part, that is the volume of the cone and total surface area of the toy. So, volume of the cone. We know that the formula for finding the volume of a cone is 1 divided by 3 pi r squared h. But the question told us that the height of the cone is equal to 4 times the radius. Remember, we have found the radius to be 3.56 centimeters. The radius of the hemisphere in this case is the same as the radius of the cone, since the cone fits directly onto the hemisphere. So we will say that this is equal to 1 divided by 3 pi r squared times 4r, since h is the same as 4r. But we have found r to be 3.56 centimeters. So the volume is equal to 1 divided by 3 times pi times r, which is 3.56 centimeters squared, times 4 times r, which is 3.56 centimeters. And this will give us 188.99 centimeters cube. So the volume of the cone is 188.99 centimeters cube. Remember, the question said we should leave our answers in 2 decimal places. Okay, the question also said we should find the total surface area of the toy. The toy is made up of a hemisphere and a cone. So the total surface area of the toy is equal to the total surface area of the hemisphere plus the total surface area of the cone. Let's begin with the total surface area of the hemisphere. The surface area of a hemisphere is equal to 2 pi r squared, where r is the radius of the hemisphere. We have found the radius as 3.56 centimeters. So the total surface area of this hemisphere is equal to 2 times pi times 3.56 centimeters squared, and that will give us 79.63 centimeters squared. So that is the surface area of the hemisphere. Let's move on to the cone. For the cone, we know that the radius is 3.56 centimeters. So from O to A is 3.56 centimeters. We also know that the height of the cone is 4 times the radius of the hemisphere. So h is equal to 4r. Now, h is equal to 4 times 3.56 centimeters, since r is 3.56 centimeters. And you have h as 14.24 centimeters. So it means that from O to V, which is the height of the cone, is 14.24 centimeters. In order to find the total surface area of this cone, we need the slant height, which is VA. If we pick the points VOA, we are going to form this right angle triangle VOA with OV as 14.24 centimeters, OA as 3.56 centimeters, and VA as the slant height. If we apply the Pythagoras theorem here, we will have VA squared is equal to VO squared plus OA squared. We are looking for VA, which is the slant height. So VA squared is equal to 14.24 squared plus 3.56 squared. And if you simplify this, you are going to have VA is equal to 14.68 centimeters. That means that the slant height of the cone is 14.68 centimeters. The total surface area of a hollow cone is equal to pi RL. And this cone here is a hollow cone. So its total surface area is pi RL, where R is the radius of the cone, in this case 3.56 centimeters, and L is the slant height of the cone, which is 14.68 centimeters. So the total surface area of this cone is equal to pi times 3.56 centimeters times 14.68 centimeters. And this will give us 164.18 centimeters squared. So we now have the surface area of the cone as 164.18 centimeters squared and the surface area of the hemisphere as 79.63 centimeters squared. We know that the total surface area of the toy is equal to the surface area of the cone plus surface area of the hemisphere. So the total surface area of the toy is equal to 164.18 centimeters squared plus 79.63 centimeters squared. And this will give us 243.81 centimeters squared. So we can say that the total surface area of the toy is 243.81 centimeters squared. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the volume and surface area of composite shapes. Bye-bye. We are on the topic mensuration. In the previous video, we solved a question on finding the total surface area and volume of composite shapes. In this video, we are going to solve another question. The question for this video is: a rectangular sheet of metal made of uniform material is 9 centimeters long, 8 centimeters wide. 6 circular holes of radius x are drilled through the sheet. I. Find an expression for the volume of the metal sheet before and after the holes were drilled if h is the thickness of the metal. II. If the ratio of the new volume of the sheet to the original volume of the sheet is 13:20, find, correct to 2 decimal places, the value of x. So you have been given this metal sheet in the shape of a cuboid or a box, and the dimensions are 8 centimeters by 9 centimeters by 8 centimeters. The question says that 6 holes, that is 6 circular holes, are drilled through this metal sheet, and each of these holes is having a radius of x. The first part of the question says we should find the volume, an expression for the volume of the sheet before and after the holes were drilled. And if the ratio of the original volume to if the ratio of the new volume to the original volume is 13:20, we should find the value of x. We will solve the first part of the question in this video, and we will solve the second one in the next video. If you look at this sheet very carefully, you can see that before the holes were drilled, the volume of this metal sheet is equal to the volume of the cuboid, because before the holes were drilled, there will not be any holes here, so the volume of this metal sheet will be the same as the volume of the cuboid. Volume of this cuboid is equal to 8 centimeters times 9 centimeters times 8 centimeters, since the volume of a cuboid is length times breadth times height. So the volume of this cuboid is 8 centimeters by 9 centimeters by h centimeters, and that will give us 72 h centimeters cube, meaning that the volume of this cuboid before the holes were drilled is 72 h centimeters cube. The question also said we should find the volume of this cuboid, or the volume of this metal sheet, after the holes were drilled. So the volume of the metal sheet after the holes were drilled. Volume of the metal sheet after the holes were drilled is equal to volume of the cuboid minus volume of the 6 holes. So now we have drilled 6 holes into the metal sheet as we have here. So the volume after the holes were drilled will be the volume of the cuboid, that is before the holes were drilled, minus the volume of the 6 holes. Okay, so now we need to find the volume of the 6 holes. If you draw a circular hole into a metal sheet like this, or if you draw a circular hole into a sheet like this, the holes will be in the shape of a cylinder. If you draw a circular hole into a sheet like this, the holes will be in the shape of a cylinder. So it means that the shape of these circular holes are cylinders. So this is in the shape of a cylinder, this is in the shape of a cylinder, and all the holes are also in the shape of cylinders. So the volume of these holes will be volume of cylinders. And since they all have radius of x, it means that they are all going to have the same volume. Now look at something. If you draw a hole through this metal sheet, the height of the cylinder that will be created will be the same as the height of the box, of the rectangular box or the cuboid. Since you draw the hole from the top part here to the bottom, so the height of the cylinder will be the same as the height of the cuboid or the rectangular box. So 1, the holes will be in the shape of cylinders, and 2, the height of the holes will be the height of the cylindrical holes will be the same as the height of the box or the cuboid. Okay, so we can say that the volume of the 6 holes is equal to 6 times volume of the cylinder created by one hole. Since they all have a radius of x and they all have a height of h, they are going to have the same volume. So the volume of the 6 holes is equal to 6 times volume of the cylinder created by just one hole. And this will give us 6 times volume of a cylinder is equal to pi r squared h, where r is the radius of the cylinder and h is the height of the cylinder. So in this case, the radius is x, since the radius of the holes are x, and the height is h, since the height of the holes will be the same as the height of the rectangular box. So this is equal to 6 times pi times the radius is x and the height is h. We are going to have 6 times pi will give us 18.85. So we have 18.85 s squared h centimeters cube. So the radius was x. So we have 6 times pi times s squared times h. 6 times pi will give us 18.85. So you have 18.85 s squared h centimeters cube. Now this is the volume of the 6 holes. Remember we said that volume of the metal sheet after the holes were drilled is equal to volume of the cuboid, which is 72h centimeters cube, minus volume of the 6 holes, which we have now found to be 18.85 s squared h centimeters cube. So volume of the metal sheet after the holes were drilled is equal to 72h centimeters cube minus 18.85 s squared h centimeters cube. We have h here, so we can factorize that out, and that will give us 72 minus 18.85 s squared into bracket h centimeters cube. So this is the volume of the metal sheet after the holes were drilled. The question gave us a ratio and it told us to use that ratio to find the value of x. We are going to do that in the next video. So see you in the next video, and let's continue solving this question. Welcome back. We started solving this question in the previous video, and we considered the first part, that is finding an expression for the volume of the metal sheet before and after the holes were drilled. We are going to consider the second part in this video, that is the ratio of the new volume of the sheet to the original volume of the sheet. If the ratio is 13:20, then find the value of x. Okay, so the question says that the ratio of the new volume of the sheet to the original volume of the sheet is 13:20. From ratios, we learned that if we have a ratio 13:20 is the same as 13 divided by 20. So what this means is that the new volume of the sheet divided by the original volume of the sheet is equal to 13 divided by 20. But what is the new volume of the sheet? The new volume of the sheet is the volume of the metal sheet after the holes were drilled. So the new volume is the volume of the metal sheet after the holes were drilled. We were able to find that in the previous video, and we got 72 minus 18.85 s squared into bracket h centimeters cube. So this is the new volume of the sheet. That is the volume of the sheet after the holes were drilled. The original volume of the sheet is the volume of the metal sheets before the holes were drilled. That is the original volume. And in the previous video, we found out that that is 72 h centimeters cube. So this is the new volume and this is the original volume. Now the question says that the new volume divided by the original volume is equal to 13 divided by 20. That means that 72 minus 18.85 s squared h centimeters cube divided by 72 h centimeters cube is equal to 13 divided by 20. So let's cancel some common terms out. So centimeters cube and centimeters cube will be gone. H and H will be gone. Okay, so after doing that, we are going to have 72 minus 18.85 s squared divided by 72 is equal to 13 divided by 20. Once again, you should understand that 72 here and 72 here can't cancel. We explained this in the videos on fractions. So here, in order to find the value of x, we are going to cross multiply. That is, the denominator here, which is 72, will multiply the numerator here, which is 13. And the denominator here, which is 20, will multiply the numerator here, which is 72 minus 18.85 s squared. So we will do cross multiplication here. This will give us 20 into bracket 72 minus 18.85 s squared is equal to 72 times 72 times 13. Now remember that because 72 minus 18.85 s squared is a binomial, if you are multiplying that with 20, you have to put the binomial in a bracket. We explained this in the videos under algebraic expressions. So we have 20 into brackets 72 minus 18.85 s squared is equal to 72 times 13. We open the bracket here. We will have 1440 minus 377 s squared is equal to 936. We group like terms. We have 1440 minus 936 is equal to 377 s squared. And this will give us 377 s squared is equal to 504. Since 1440 minus 936 will give us 504. So we divide the left hand side by 377, we divide the right hand side by 377, and this will give us s squared is equal to 1.34. We take square roots of both sides, and x will give us 1.16 centimeters. So that means that the radius of the holes drilled through the sheet is 1.16 centimeters. Thank you for watching this video. Subscribe to this channel for more videos by clicking on the subscribe button that you see below. This is the end of the videos on mensuration.